When the DARPA Lift Challenge began, no one knew quite what to expect.
We're excited to compete in the DARPA Lift Challenge.
This is such new tech, you don't know what to expect.
But as the week progressed, it became a display of not just innovation, but determination and grit.
We're very resilient.
We fail fast, but that doesn't define us. It's how we pivot.
Well, you win some, you lose most.
A community that came together to push the boundaries of aviation.
The camaraderie has been amazing.
Supporting each other, cheering people on.
Collaboration, trading of parts and expertise.
Every failure moving us forward. Every success celebrated by all. Today, the culmination. Who will lift the heaviest? Millions on the line. More important, history in the making. The DARPA Lift Challenge Final begins now.
And we welcome you to Super Sunday at the DARPA Lift Challenge. The National Museum of the United States Air Force is buzzing with excitement. The teams have been up all night tweaking, prepping, and getting ready. The drones have made their way to the flight line, and the launch pads are ready for liftoff. It's all for one final shot to reach the coveted 4-to-1 payload-to-weight ratio. And the question is, who will go for broke?
Flight line, be advised, the flight window is now open. I repeat, the flight window is now open.
So it is official. We are off and running on Super Sunday here at the DARPA Lift Challenge as we have reached the final day. Todd Harris alongside Joshua Bardwell. This man, Philip Smith, also known at call sign Donna, is the program manager. We made it. We made it to the last day. I know you had some thoughts on Tuesday and Wednesday. We were thinking the rain, the weather, all that stuff. We're going to never get there, and here we are.
Man, that weather has turned us a couple of days here. But, no, this has been just a once-in-a-lifetime opportunity. I was walking around a little sentimental last night, talking to the teams. And then this morning, a lot of the staff was like, this feels like the last day of summer camp, like you had an amazing time, all of your friends, you didn't know anybody when you showed up, and then when you left, you're like, we're going to be friends forever. You're sad, you're happy. It's like all of those emotions going on, and we have a packed day of flights. We have 3 lanes. I think almost all of them are full. I'm sorry, 3 flight windows. Right. Almost all of those are full. We've got a number of people who are going to try for the 4-to-1 here on the last day. I mean, we brought this down to the line. Yeah. We did not plan that for everybody out there. It's just the way it happened.
JB, you've been working your sources. You've talked to a lot of teams. Multiple teams have said they will be going for the 4-to-1.
That is right. And we've been speculating, are they going to try to kind of take baby steps and maybe inch their way up, which obviously that's a strategic decision only they can make. But certainly we want to see them swinging for the fences and finally breaking that 4-to-1 payload-to-weight ratio.
We're going to be on the edge of our seats all day. It's going to be crazy.
All right, let's take a look at the leaderboard as we get ready for fly times here at the first flight window, the 9 a.m. Eastern time. Aviadrone still sits on top. One of the teams that Joshua Bardwell talked to that said they will be going for the 4-to-1 ratio. They currently sit in first place with 3.84. MTech Operations sits in second. Extreme Aerial Concept sits in third. And then you have H Squared and Team MacGyver out of Baltimore, Maryland, currently in 5th place. We also have a list of chasers who still have an opportunity also to jump up. But again, you've got to get that full competition run in, that scoring run that has to be certified. I like where Defentex is, Donna, but they have a lot of work to do, and unfortunately they went through a lot of inventory.
They did. Yeah, they yesterday's flight was the last one for them. They said they even pieced that one together. We saw yesterday that they had duct taped or, taped it all, reinforced it, and that was their last go. They said, all right, we're going to hang around and see if this works, but or, if anybody else makes it. But
this was yesterday,
that was it for them. That's right.
Those 3 teams all went for it, and had they been successful, they would have been in line for the $2.5 million payout. Defentex, though, went huge at 6.11. But as mentioned, Defentex is no more here with this competition. Aviadrone sits on top, and that is where the 4th member of our broadcast team today on Super Sunday, Elena Buenrostro, is standing by.
I've been chatting with teams all morning, and I had a chance to speak with Team Aviadrone, who is the leader, as you mentioned. And they actually came with 3 drones. They've crashed a few, they've rebuilt. They have 1 functional drone right now, and they're planning to go back out at 11 to beat their own record. So for now, they're just going to have some coffee, sit back, watch the rest of the challenge, and cheer on some other teams. Back to you, Todd.
Do sit in first place, JB. That's the luxury of it. They can swing for the fences. They have nothing to lose. They're in first place. Someone's going to have to surpass that 3.84, and I got to think if someone's going to pass 3.84, they're just going to go hit 4.
Yeah, I think so. I mean, at this point, there's no sense not going for it. And if it's the last day, everybody wants to go big and then go home.
And remember, we did this for that 4-1, right? So, yeah, nothing to lose, but everything to gain, right?
Yeah.
Everything of that marker that we set, that people said was not possible. And then what we saw all week was, it is really hard, right? All of these teams trying to break this and getting so close to it, right? If they can just make that mark, history and the goals of this competition, the goals of what they set out to build will be accomplished, and that's going to be so amazing for them.
Yeah, and more than just hitting that mark and having a sense of pride, but also they have to hit that 4-1 ratio.
That's right.
It's going to double their prize money. They're only in the money for half of that $2.5 million first prize.
That is correct. Yeah, it's funny where people have come. So a lot of people said, okay, there's the money on the line, right? That gets people in the door. When they got here and they started, working through all their issues, they kept on crashing, but then able to rebuild. I think a sense of, I don't know what you call it, destiny or just that goal, that insane drive to be able to hit that goal is now what people are going after.
Yeah, I was talking to one of the team members today, and he said, we just keep bumping up against that ceiling and things keep breaking. We keep figuring it out what it is. It's not like, I hit 3.85. I can just add a little more weight.
Right.
Surely they're right at the edge of what is physically possible.
MacGyver currently in the air, guys. They are just doing a test flight here, but I got to think this morning with the cooler temperatures, there's not much wind at all. This would be an opportune time to do that. Quickly want to go back to the leaderboard and take a look at the top 5 that we got. Of course, Aviadrone sits on top. Again, it's all about the payload to weight ratio. Aviadrone has the mark right now. They are out in front. Don, as you look at this, you see a lot of promise.
Yeah. So Aviadrone's going to be flying in our 11 o'clock window. MacGyver, as you just saw, they had to rebuild. So they are doing their test flights to prove that this rebuilt version is still safe to fly.
Okay.
H squared is out, so they will not be flying. Extreme is on the flight line right now. I talked to them earlier this morning. They're really happy with the temperatures, the density, altitude right now. So they're going to actually try and push that up and move on the leaderboard. And then MTech is also going to be flying today.
This is Extreme Aerial right now out on the flight line. You're looking at live pictures as they have fueled up and they are lifting off. So the cool temperatures, very little breeze this morning here in Dayton. They got some weight on there, JB.
Yeah, we see some plates. It doesn't look like a full load. We should be able to get
actually
some of that
3.71. They're going for second place.
It is a full load.
There we go.
3.71. That's remarkable. So we're going to take a look here at the heads-up display. We can see the distance that they've gone.
Yep.
We can see their altitude, their ratio, and if they begin a competition run, what we're going to look for is for them to climb to 100 feet is the minimum altitude. They have to complete that within the first half mile, and then they have to stay above that 100-foot floor and below the 200-foot ceiling within the bounds of the safe area for the entire run.
All right, so this is the final day of the DARPA Lift Challenge. Again, you have to carry a 4-to-1 ratio, as Joshua was just pointed out, above 100 feet, staying below 200, and it's 4 nautical miles. Drop the weight, go an extra nautical mile, and that is a scoring run. So we have a few teams that have dropped out or have no longer been able to compete today, so that has slimmed it down to 3 flight windows. We'll have one at 9, 11, if I've done my math correctly, 2 o'clock?
2 o'clock, that's right.
11 and 2.
Donna, we talked about, we can see here liquid fuel. We've talked about some of the fuels that people are using. We assume they're using gasoline, some of them. We've heard about nitro fuel.
Right,
What are the different liquid fuels that people are using?
Yeah, so we only have 2 teams that have what we consider exotic fuels. So nitromethane is one of those. That's FNP. They will be flying as well today, so we'll see them up. In general, though, you're looking at aviation gas, which is similar to what you have in your car, and then you're looking at a diesel derivative, which is what we use in this one right here, this Extreme Aerial. So that's a turbine engine. So you're using, in military parlance, JP8, JP5, one of those. It is just a more refined gasoline, right? And then you have those exotics with the nitromethane. So we haven't seen a lot in the earlier days of proposals. People had those. This goes back to, Fast and Furious, where you hit the nitro for that last little bit.
Well, Todd asked, is that the same nitro that they hit in Fast and Furious?
That is. It's the same thing. Engines work the same way all around.
How about that? I said it wasn't. Looks like that's 2 times this broadcast. You've been right.
Joshua's our resident Vin Diesel.
And I was wrong.
No, I mean, obviously there are differences, and we've gotten it wrong up here. I got it wrong yesterday. It's not Kevlar in that inflatable drone. It's Dyneema. So when we're up here on the broadcast, we can only speculate, armchair quarterback, and look at what people have. But that's the beauty of this is the details, and all of the engineers out there are so passionate about their designs, and getting the details of exactly what they're doing is very important, right? There's a big difference between a nitro that you would use in a car and a nitro used here. But in general, it's the same thing. You give it a little more juice, it burns hot, and you get more power.
This is MacGyver up, and this is another test run for MacGyver. So they're getting an opportunity to work out all the overnight bugs and kinks. And we will say that a big tip of the cap to the crew, the folks in the orange, the television folks. A lot of rain came through last night when we finished up around 7:30. Heavy rainstorm came through, so. Some electrical issues on campus, but we've got them all sorted out.
Yeah, and if we look
up and running.
If we look at the upper right corner there, it says run 24. The number isn't so important. That's just the number of times they've taken off and set down. That could be anything. But that is black, and that does indicate that whatever they're doing right now is not a competition run. Of course, we can also see that their payload is only 1.9 pounds. That wouldn't be a competition run either. The minimum weight they have to carry for a competition run being 110 pounds. And minimum 2-to-1 payload to weight ratio to get in the money, and 4-to-1 to unlock the full price.
So another interesting point on that top right corner, you see that it's run 24. So in 7 days of competition, they have attempted or flown 24 times to be able to get to today, and to be able to get to that 4.0 payload to weight ratio, a 4-to-1 payload to weight ratio.
So that is cumulative over the whole event, not just this flight window.
That's a running tally.
So what you're saying is they're getting their money's worth.
They have been working. They have been working nights, all day, working on their aircraft, rebuilding after crashes. But I've heard this from a number of people that I've talked to, is the experience that they have gotten, and that they've been allowed to because of not only the FAA authorizations that we have had for this event, but also the safety that we have provided. There are a lot of places in America where you can fly, but that don't have the safety apparatus that we've done, right? So they can really push the limit. They know that if it crashes and goes on fire, you're not going to have a wildfire. That's a very big concern in a lot of part of the country. And what we're seeing here is all of the lanes, all 15 lanes out here on the runway. And then on each one of those pads, those squares, you see those teams getting prepared. When I was driving out on the line this morning, I think I saw 3 to 4 lanes that were empty. But otherwise, we've got a full packed schedule for today.
Do we have any scheduling? This is a question, I guess, to look towards the end of the day. Anyone that's going into 2 flight windows, or is it just one?
No. We did a couple of things with this last day. We said, okay, everybody gets 1 flight window.
There you go. Okay.
And there's no rolling today. So there we go. This is our top contenders. Now, this is just what we've seen all week. There's some people out there that are saying, now's the time. Now's when I'm actually going to be putting up the payload. So we could see some surprises. and we would be so excited for that leaderboard to be making some crazy jumps today.
So there you see 6 notable contenders on that board. MacGyver's and Chaser's on there as well. Extreme Aerial, MTech certainly in there. Avidrone. VertSolve, we had Kevin Horn on yesterday to close the broadcast. His team will be up at 11 a.m., the 11 a.m. Eastern flight. And then Capstone Airlift System will be at 2 o'clock. And that will be the final flight window here at the DARPA Lift Challenge. So if you really want some great excitement, be here by at least, I'd say, 3 o'clock. And you're going to probably see some people scrambling in that last window because it's going to take 22 minutes. So at 3 o'clock, if you're serious about breaking this, you better be ready to go.
That's your last chance. This one here is University of Buffalo. Very interesting design here. They have over 300 pounds of thrust on that aircraft. Their production and what they came in with was carbon fiber and aluminum. They had to drop weight for it, so they've made this out of wood, balsa wood around there. It's crazy, but they went all out on reducing that weight of the aircraft and increasing that thrust. And they have some impressive capabilities. They've been very remarkably stable, even in high winds. The number of props at the RPM that they have there has been impressive.
Well, let's talk about that, because we've seen a lot of designs in this competition with great big gigantic rotors. We've talked about those being more efficient. Here we've got a huge number of much smaller rotors spinning at a higher RPM. Why might they have made that decision?
So this is also the team, the university, and their design concept for going on towards production. They want to have a modular aircraft. So each one of those sections with a rotor, or a prop in this case, can be pulled off and on depending on the mission, right? So you can attach some for a lighter load or for a heavier load and remove them for a lighter load. So that was their design concept coming in. But theoretically, and this is theory, this is why we have these challenges, to be proven wrong and to change the theory. But yeah, theoretically, smaller lift surfaces or airfoils require more energy. So it's not actually 1 + 1 = 2 in this case. It's actually 1 + 1 = 1.9. And then as you add up all of those, you have energy loss throughout the system, entropy, right? So each one of those wires that is going to each one of the engines, it loses through heat, right? It loses energy through heat. Each one of those motors loses energy through heat as well. Oh, they dropped the seal. This is one of the design concepts. So this is why they made this aircraft like that, is because they can lose a prop and still fly.
Yeah.
Now they are coming down. Oh, they came down hard, so it might have chopped a wire or something.
And that was a scoring run.
That was a scoring
run. It was only 2.05 on the payload to weight ratio, but it was green.
So they did crash the last time. So that did have 2.0?
Yeah,
okay,
2.05,
right.
and it was green on the top right corner.
Well, it's the announcer's curse, Donna.
I know.
As soon as you say something,
as soon as you say something,
you are right. One of the advantages of this
there
design is that if you have 15, 16, 20 props,
right,
and you lose one, you can still usually keep flying, as opposed to
almost
if you
like the whole right side, a whole bank of them failed.
Yeah, if that's the case, it's not staying up.
Yeah.
That would have been a power, what are they called? Distribution system, right? A bus may have failed, and lost all the props on a single side there.
Yeah, we talked yesterday about sometimes on these designs, each of the motors will have its own battery, so that if one fails, the others will keep going. Right. Other times you'll have a single larger battery driving multiple motors, which is simpler, but does create a single point of failure. And that's just one of those engineering decisions that these guys have to make. And at the end of the day, when you're flying a big, heavy aircraft like this and things go wrong, there's always a chance you're going to come down out of the ground.
And it's all about the linkages of complexity, right? So how many complex systems are you jamming in? In this particular case, I don't know the number of props. Let's say it's 20 or 30, whatever it is. You have 20 or 30 ways to fail. Yep. Now that's 20 or 30 ways that you can recover from a failure.
Right.
But it also adds complexity. Anytime you add complexity, you add the ability to fail in any one of those points. So it's always a design trade-off, and it's always interesting to see.
20 minutes into the 9 a.m. Eastern flight window here, and we've got MacGyver guys, and it looks like, and we're going to lean on Donna's fighter pilot eyes, that looks like they got some serious weight on there. Could this be the 4.0 that we're looking for?
So I know they've got the bench. If the bench has a black top on there, then I'm not sure what it is. Otherwise, it does look like 3 45-pound plates.
Is it 3? Or you're counting the bottom one as being the top of the bench?
Yeah, that's what I'm saying. I don't know if the top of the bench is black.
I think that the 2x4s are the bench,
Yeah, I think
and I believe it might be 4 plates.
There's no countertop.
So sometimes, Donna, we see the Titan tracker on the weight stack, and other times it's a small gray box.
Right.
Is there any logic there?
Yeah. So originally we said, okay, everyone's going to have to carry these plates, so we might as well make the tracker at the 25-pound weight plate dimension. So it was a known quantity. It was a thing that is in every sports store and gym around the world, and so we made that plate in that design. And then we started seeing the designs coming out and the way that people were carrying the plates, and realized that it wouldn't work in some scenarios. So we made the smaller box. We call it the compact tracker. It is about the same weight, and you can put that anywhere on your aircraft where it makes sense.
This is Agricultural Technologies. This is not a scoring run per se. They're just taking it out for a spin. The team out of Zeeland, Michigan.
Yep. So these guys did have an accident, a crash, a learning lesson on their last flight, so they do have to do this as a safety flight as well.
Explain what we're seeing here.
Yeah,
Donna.
so
what's up with
this is
design?
a more traditional tail sitter. So it lands on its tail and then takes off and will want to get on that wing. So once they get on, the term getting on the wing is when they get to an angle of attack that allows for lift. So right now there's the angle of attack, the wind is hitting this broadside if they were moving at this angle, this 90-degree or straight up angle. But as they tip over, they're going to start getting wind over that airfoil and providing a lift. And that takes all of the stress off of the motors. Now they're just used for forward propulsion rather than for brute force lift.
Yeah, and I think one of the coolest things about this design for me is that the motors, no wasted energy. When you transition to forward flight, those motors are just pulling you forward.
Right.
As opposed to, for example, if you had some upwards running motors and then like a different motor to push you forward or a big main rotor, you're not really wasting any weight on anything that isn't used really at any point in the flight regime.
So we call that parasitic weight. So there's also parasitic drag. It is a parasite on
stuck on
on you, and you have to carry it no matter what. So that's exactly it. That the designs that can dual use their lift and their forward propulsion. Now this course is very short, so we have not seen a lot of those tail sitters. If we were to say we're going to make it straight out for 4 miles and straight back, we would have seen a number of different design concepts that would have covered, would have had favored more airfoils.
Right.
We were right in the middle there. It ended up that people came to us with quadcopter style, octocopter style, and then a number of those prop-driven rotors, which we've seen in different variations. But, the mission, the requirement, the use case, it drives design so much more than actually in other industries. So if you think about the automobile industry, you have about the same until you get really specialized. And even in the racing community, you can see the track drives the design of the vehicle. NASCAR, off-road, Formula One, they are all drastically different because they're specialized in this. In aviation, because traditionally it's a very expensive hobby or industry, you want to specialize it for that particular use case.
Yeah, let's talk about the track. It's 5 nautical miles that they have to go in total distance, but the track itself is only 1,100 feet.
Correct.
And that means there's a lot of back and forth. So this wing design, we saw them transition from forward flight back to vertical, and there was a little bit of instability. That's a very tricky time for the aircraft, for the flight controller, and for the pilot. And if they could just do that once, they get up to speed, and then they just go for 5 miles. They might only have to make that transition 1 or 2 times.
Correct.
Whereas here they have to do it multiple times. They're losing efficiency, and they're having additional opportunities to crash.
That's
100%.
about as busy as the flight line has looked all week long, and why wouldn't it be? It's Super Sunday, the final day of the DARPA Lift Challenge. And what would a Super Sunday be without a modified Stump Donna routine? Now, this one I got to throw right at you. What is going on here? What is going on with the paint job? Anything else you can just have at it?
These guys are out here having a blast.
Yeah.
And that's, you got to have fun doing what you're doing. So this is obviously a very unique design. They have crashed numerous times this week, but because of their materials that they're using, you see PVC piping in there, you see normal foam cord board, very cheap, very easy to cut and glue and tape together. And this allows you to iterate a number of times. We've seen in other designs that it's something inside the aircraft that fails, not outside. Mm-hmm. And what they've done is they've run into problems where they can't rebuild fast enough. Composite materials take time to cure in normal language. The glue has to dry, right? And that takes time for that to happen. These guys are like, no, I don't need that. I cut it, I put it up, try it again. And so they're working out a lot of the kinks inside the system. Remember we saw the guy turning in circles yesterday?
Right.
Mm-hmm. So he was having problems with his compass. We explained that yesterday. But he had a very expensive aircraft out there, and he was having a problem with such a small little piece of his aircraft or his design. This allows you to, even if you have a possibility of a problem, you can try it, right? You can throw it up there and give it a go.
This is Super Jeopardy for just Donna, because I know JB knows the answer. This is APRAD. Do you know where they came up with their name? This is Stump Donna 2.0.
I do not. There you go. You got me. Yeah.
We had to find something to stump him with.
Look at it carefully, Lieutenant Colonel.
I'll give you a clue. Think forwards and backwards. Forwards
and backwards.
That's your clue.
My clue.
Go backwards with it. Read it backwards.
Oh, sorry. There
it's
you go.
DARPA backwards. It's DARPA backwards.
Yeah.
The week has been a success. One time we've stumped Donna.
Oh, and
APRAD.
We actually ran into them at dinner last night.
Oh, nice.
And that's the only reason we know that. But I was like, we got to stump him.
Yeah.
We got to stump him.
There was a team that didn't make it, but I think they called themselves DARPA, and of course they had some funny acronym for it. Let's talk about the team names for a little bit. Okay. Now that we're on it,
What the hell?
Reasonably adequate.
Flying nuisance.
Flying nuisance
is good.
There's been some really innovative ones, and when it first started out with 487, we were as a team we were like, diving into all these papers and things that people were sending us, but those names stuck out to us. It was really fun.
Maybe not worth $500,000 on one of the superlative awards, but maybe $50 for the best name.
Right.
We just isolate that. This is MacGyver, and that looks like a load of weight. Won't speculate on what it is.
Oh.
We're going to wait for the Titan to pop up. Right there. That's JB at the gym. That's 4 plates aside. 3.32 is what I'm being told.
3.32 payload to weight ratio. That's the weight of their payload relative to the weight of their craft and its fuel or battery. And you can see them doing just some little test dips and wobbles just to see how the aircraft responds.
Look at that weigh-in. 55.0.
Yeah.
Man,
they are right
there.
Right
they
did not give themselves any room. That is great.
Yeah, if you've ever been at the check-in counter taking shoes out of your bag, hitting that 55.0 exactly is not easy.
And here we go. This
Donna's
is
new favorite team.
APRAD.
You'll never forget that.
Yeah, right? I know.
So we see here, this must be a tip-driven rotor because they don't seem to have any kind of counter torque to keep them from rotating.
So they've got, it looks like one on each.
And I asked him, why do you have a tail fin? What is it doing? And he said, I'm not very good at rotorcraft. But I love it. This team just coming up with innovative designs. I'm familiar with some of the designs some of their team members have made in the past, and this is right up their alley.
Right.
Just trying new things, coming out here to the DARPA Lift Challenge.
So of note, they have smaller props on that base, the bottom. So if you can see on the corners of that square base, they have 4 props. So this is a combination of a quadcopter style and a prop-driven rotor. So they're getting that high lift capability out of the rotor, and they're getting finite control out of that quadcopter. Now, the problem with this one is it's got a lot of surface area, so any bit of wind is going to be pushing this thing around, and it's also got a lot of mass.
So here we go. This is the current leaderboard. Aviadrone continues to lead, that 3.84. But you talk about MacGyver, their strategy, Donna. They're at 2.51 right now, fifth, which is technically out of the money. But they're at they're above 3.31, and that would jump them into third place ahead of Extreme Aerial Concepts. So they go from no big money to $1 million if they can stay in third.
Right. So now it's, what do you push for? Do you push for 3.32?
Right.
And get in the money, or do you go for higher, 3.65? They're also limited to the weight plates they have, and now these guys are using Velcro, so they don't have a limitation on their holding post, right? The post that they have to be able to put it on, but they might have a limitation on just the number of weights that they can do.
This is advanced vert. They're at, I'm just being told they're not quite there. They're 2.22. So this is a scoring run. You can see top right corner in the green. Got to stay above 100 feet of altitude.
Looking really stable there in that turn. They only fluctuated by a couple of feet. Remarkably stable. This is, remember, we were talking the other day about the suspension wires, the hanging bridges, the suspension bridging. So what they've done here is they've taken a relatively traditional octocopter, hexacopter, however many blades they have and arms, and they've lightened the airframe. So there's a number of ways that people have gone about this competition. If you take the major components, you take the battery, the motor, the propellers, and they definitely dipped down there.
This is In-Sky.
In-Sky.
In-Sky's on the same ratio.
So all of this different subcomponents, people have focused on different ones in order to make that payload to weight ratio. That suspension system means that they took an effort to reduce the airframe size.
Because there's
right?
two ways
airframe
you can change that ratio. One is by carrying more weight, and one is by reducing the weight of your craft.
Correct.
Well, I saw some runs. One of the runs, they were just 1/10 of a pound under. I believe it was second place, and I thought, why didn't they just shave just a few ounces? And of course, obviously, there was a good reason.
Right.
But
sometimes there's just nowhere to shave.
There's nowhere to. You've shaved it all already.
You've done it, and that's all you got.
Yeah.
So In-Sky out of Miami, Florida, looking to do something here as we're looking at advanced vertical.
I'm really amazed at how stable that weight is with those guy lines underneath it. You would think it would be flopping around, and it just isn't. Even when they tilt the craft, it tilts with it. It's so stable.
And whether it was this team or another team, we saw them this past week where that payload was wobbling back and forth, and you could tell it was giving them controllability issues. So maybe over the last couple of days in flights, you see up there on the top right, this is their 20th flight. Maybe they figured out a way to stabilize that payload and not have the associated controllability problems.
This is the team, College Station, Texas A&M. Flight pioneers here trying to get this done. They got to stay above 100, below 200. This is their 20th, so they've got some experience. Again, one of the teams getting their money's worth, but a 2.22 payload to weight ratio for them. 5 minutes into this one, they have traveled just over that nautical mile. Remember, they need to get 4 nautical miles. This is In-Sky over on lane 5. They're at 133, also at 2.22 on the ratio.
Yeah, 4 nautical miles loaded, land, unload the weights, and fly 1 more nautical mile without the weights, because, of course, an aircraft that carries a weight and can't drop it off and come home again has limited uses.
Yeah, so let's talk about a 2-to-1 payload to weight ratio. So in general, what you see on the market today in a production aircraft is around that 0.5 to 0.3. You can get specialized ones just at that 1 or just barely above it. So this 2.22 is still good, right? It is still an industry increase in ability, but not quite where we were at, but that's why we put the 110-pound minimum on there. So we said in order to get a scored run, you have to do better than standard industry right now. You can't just bring your commercial off-the-shelf drone and fly it in this competition. You got to do something to it. You got to work on it, and that's the minimum capability that we require.
It's interesting you say that. We've been saying throughout this broadcast that about 1-to-1 payload to weight ratio is what you get from like the best modern drones and all the way up to full-scale cargo helicopters and such.
Right.
But you raise a good point. That's the best, and the typical numbers are way lower than that. What number did you give?
So, remember, you have to, with aviation, and you know this, so I'm talking to the choir here, but it's all about the distance that you need it to do and what you're doing in that distance, right? If you're doing dynamic maneuvering, you need to have more power. You need to have more control authority to be able to do that. So when we talk about this 0.2 to 0.3 ratio, that is more of a generalized drone. I can fly anywhere, I can do anything.
It's not optimized just for carrying cargo.
Correct, and just for this. And it also has to have the weatherization and all of the other factors, the safety requirements and all that. So that's why I talk about more of that one-to-one. So if we took that away, if we took those things and you said specialize it for daytime only, good weather, and this course, then you're getting up more to that 1.5, 2.0 kind of standard. Now, that's still the most specialized drones, right? That's the best people in the industry with all of the financial backing coming behind them doing that, like just going out and saying, I'm going to lift heavy for a short distance and then come back home and recharge my batteries. So that's the interesting part. In addition, normally, if you were to go out into industry right now and say, I want a 111-pound payload, or just let's make it even, 100-pound payload, you're generally going to go out and find 100 to 150-pound aircraft, and that's extremely expensive. I don't want to say extremely. It is somewhat of a factor more expensive than a 55-pound.
Well, it always
drone,
matters.
right?
I mean, if I have to pay for, $5,000 versus $1,000, I care.
Or $100,000 versus $10,000, right?
Yeah.
Yep. So this goes back to that original concept that I've had in a couple of the videos and we've talked about, is that cost per pound per mile transported. It's very important in commercial industry when you're doing your cost-benefit analysis, and then in the military as well when you're trying to build and produce in mass and deploy in mass.
So going back to the payload to weight ratio, it sounds like it would be fair to say that we are roughly doubling or quadrupling the capabilities of essentially all
state-of-the-art
modern cargo aircraft.
Yep. So that the state-of-the-art is around 1. So we're doubling or quadrupling, trying to quadruple the state-of-the-art.
Right. We haven't quadrupled it yet. That's a very good point.
We're
hovering at 3.84 at the top of the leaderboard.
So close.
So close. I mean, nobody wants to get 3.84 tattooed on their arm, right? 4 to 1.
4x. That's what we got.
Well, Advanced Vertical Flight Laboratory right now is coming up on the 4 nautical miles. They have stayed above the 100 minimum altitude for the hard deck. They are at 2.22 on the ratio. So we'll see if the good folks from College Station, Texas can bring this home, unload the weight, and then put down 1 more nautical mile to make this an official scoring run.
Look at that! Look at that aircraft. Would it be fair to call that majestic? Just,
I mean, with with the backdrop and the view,
great.
It's great. So we just got reports that InSky broke the geofence boundary, and they have called it quits for the day. They're back on the landing pad. So geofence, for those who haven't been tuning in, for safety and course, right? We have geofences. For those who aren't familiar, it's georeference points in the air, and it is, think of a long 2x4 or 4x4 in the air at 100 to 200 feet, and they have to fly within that. Obviously, they have to ascend and descend out of that box to be able to complete the run. So we have a couple of different parameters there, but if you break that geofence, if you fly outside of that box for any reason, your scored run is over. You've got to come back.
So again, this is Advanced Vertical Flight Laboratory, very close, as they are not officially there yet. They'll get the indication, but they're coming back to land. They have completed 4 nautical miles. They have stayed above 100 feet in altitude. So Advanced Vertical Flight Laboratory, and
man,
the announcer jinx.
Right. They got the 4 miles. They were coming back to land, and something happened. Maybe ran out of juice.
What do you think of the way it bounced on that landing? It didn't seem to take any damage at all.
No, it was a very controlled landing. My first instinct, like I said, it ran out of juice. Maybe the batteries just couldn't make it.
Here's one more time.
Here we go. So we don't see any structural failure. We don't see any, a single prop failing in this, and it comes down in a relatively controlled manner. If we had a little bit of more reference points to the skyline, we'd probably be able to see that this is flight level. And the way batteries work is when they get to the end, you start seeing that power reduction. It's getting right to the end. You still have controllability. That pilot, if it was manually operated, was able to bring it down and prevent any damage.
Yeah, it's not like your car where you sort of run out of gas and the engine just goes sput. Right. When that battery gets low, it's still got a little bit of juice to give, just not enough to keep the craft in the air. And if I'm in that situation, well, in a normal situation, I'd see the battery getting low and I'd just come home and land. But I imagine they might have thought, well, we're so close to it.
We're pushing
As soon as we get this weight off, the battery's going to be able to recover. If we can just get it back in, set it down, and get the weight off, we can probably finish this run. And then, of course, it starts dropping, and you just use what little power you have left to try to soften that landing, and it sure looks like that's what that pilot did.
Gosh, I'd love to find out just how close they were to bringing it home. They were still above 100 feet on the elevation, so they hadn't begun the descent to bring it on the... look at that. Come on.
Right there. They were at 4.01 miles.
My gosh, so close.
They were so close to getting back to the pad.
That doesn't count, though.
No. So
they can't just take the weight off and finish their run.
No, and they can't change batteries on this pit turn either. So they would have had to land inside that 5-foot circle on the second platform, the farther one away, inside of the circle that's painted on there, release the weights, and then go and fly for that 1 mile unloaded lap.
Yeah, looking at how it came down so flat and level, no mechanical failure, and looking at how close they were to the pad, I have to imagine that what happened is the pilot saw the battery getting low and thought, maybe I can make it, and the battery's just flashing red, out of fuel, and you're like, I got to make it to the next gas station. That's right, land now, he was seeing. That is correct, Todd.
All right, so they come up just a little bit short as we are now 45 minutes, so halfway into the 9 o'clock flight window, so 45 minutes to go. It looks like MacGyver may be adding some more weight. We saw them going up, testing with some weights, and it looks like they're cracking out the bigger. They were at 3.32 last time. This looks like bigger Velcro straps. So is that a fifth plate?
Yeah, I don't know. Well, we'll know as soon as he gets up in the air and we have to tighten data.
Could this be the moment that Donna starts cracking out the big fancy Sharpie pen to sign a check? Speaking of which, the award show tonight. Tell us what's going to happen at the award show, the banquet, the final finale.
Yeah, so we're going to be in the museum, an amazing spot, historic and awesome aircraft all around us. It's going to be relatively short and sweet. It's going to be great. We're going to announce the subjective prize categories and the winners. Well, not announce the categories, but announce the runner-ups. And then we'll announce the winners of each one of those subjectives. And then the first, second, and third place teams will in turn get their awards, their check, the trophies that we have here on the desk.
Yeah.
And handshakes all around, hugs. It's going to be great.
6 teams are going to be very happy later tonight.
6 teams are going to be happy. That's right.
Yeah, talk to us about the superlatives: most revolutionary aerodynamic design, most revolutionary powertrain design, and most promising.
Right.
The word revolutionary jumps out at me.
Correct. So there's 2 ways of attacking this problem, and one is taking known science and try and make it better. So we were talking about that with the different subcomponents of the aircraft. And then there is the try something entirely new, right? And there's risks in those. The risk is we have a known science. We know, because we've been doing it for the last 10, 20, 30 years, that there's only so much juice that we can squeeze out of this. There's only so many things that we can do. On the revolutionary, it's high risk. It's very high risk. And you've seen that with a number of the prop-driven rotors that we've seen. So theory says that those would be able to do it. It has been very difficult to get those to fly, to get them to be able to be controllable in the different configurations. So what we wanted to do is recognize with those designs the people who went outside of the box, that did not take a normal approach, didn't take a known science and just try and squeeze the juice out of it, but said, hey, this is actually thinking differently about the problem, and that's what we wanted to do. Regardless of whether they crashed, whether they didn't make it, they had to get to the pad and they had to make an attempt. That was the requirement, They couldn't just show up to the event and, sit in the hangars the whole time.
Yeah, I think if you're sort of in the comments section, it's easy to look at some of these novel designs, and say, like, is that even a serious attempt? And you guys are taking them very seriously.
Very serious, yep. Because that's there are a lot of ideas. Some of them are good and some of them are not. But only at events like this and with people like this around that are willing to try, that are willing to say, okay, this may have failed 10 years ago or 20 years ago, but maybe it was just because they didn't know how to do it, and I'm going to be the one that figures it out, right? So this type of event, these type of people that have come here are exactly what we're looking for in those two categories. So powertrain and aerodynamics.
So we are more than halfway through the first flight window of the day here on the last day of competition. This is APRAD again. Looks like they're going to spin up.
Are they?
They're going halfway.
Yep. The weights are attached to the
They're
weights are rotating.
Spinning. They're actually spinning.
That's such an interesting decision. We were just talking about, novel ideas.
Yeah, so this is their half-weight safety flight. So what they're going to do, and you see that there with the 50 pounds, 51.5 or 51.9. That 1.9 is the tracker that they have on there. So they got two 25-pound plates. They are going to spin up. It looks like they're spinning down, but they're going to have to do one lap, so just out and back, to prove that they can safely fly before they can actually go for a competition run.
Let me make an argument. Right? Let me make an argument as to so. Like my first thought, and I love it. I've had this experience so many times here at the DARPA Lift Challenge. I see something, I go, "That's ridiculous. Why would you do that?" And then my brain starts working, and I go, "Well, why would you do that?" If they've got their weights on the shaft, what's the downside? It's balanced. It's spinning. It's going to actually help stabilize that shaft. It's going to help give it momentum to keep rotating. Maybe if they had any interruption in motor power.
Just like a bicycle wheel, right? So a bicycle, you stand it up stationary and it falls over. But you start spinning those wheels. You see it in the science classes, where you got the wheel spinning in front of you. So there is value in that centrifugal force and the forces that it has.
Maybe act almost a little bit like a flywheel.
JP, this is a local team from right here in Dayton, as you know, and they have a connection to a high-quality restaurant that you visited.
That is true.
Give them a little love. Come on.
Oh well, I don't want to call anybody out, but I will say we ran into this team at dinner. I said this is a fantastic restaurant, and the team member said this is my mom's restaurant.
There you go.
So there you go.
APRAD, not just great at flight. This is MacGyver in the air. And we're going to wait and find out if we get some data off this thing. And, we know we're going to get some data off this thing. We're going to find out what the weight is. So they are at 3.34, just a little bit more than we saw them on the test. And so the green comes up as they get up to elevation. Remember, they've got to be above 100 at 0.50 nautical miles. So they have time, and they've reached that. This would put them into third place.
Yeah, third place, of course, is a $1 million prize, but you have to break the 4-to-1. So it really is going to amount to $500,000. Yep. Still no small amount of money.
Exactly. So they're going for that strategy we were talking about, just going, points up, hundredths of a place up on the payload to weight ratio in order to jump into that third spot. The team that is in third right now, we saw Extreme Aerial Concepts. They were the helicopter design that took off and hovered a little bit, and then maybe saw that they didn't have the power margins, so they came back and landed. But they're still out on the field, and according to our time, if MacGyver makes this, they still might be able to make a run and take it back.
Go back up and put an extra few ounces on there. So 334 is the ratio. Power, remember, it's payload to weight ratio. This would put MacGyver currently in fifth, would move them into third. If someone goes over the 4.0, obviously that changes the dynamics for everyone, but as it stands right now, no one going over the 4, them not going over the 4, they would get the $500,000.
Right. So we see at the bottom of the screen that 54 pounds and 182 pounds. For any parents out there with kids, think about that. If you have a, 7-year-old, right, somewhere around there. I have a 6-year-old, he's a little bit lighter than that, so maybe around a 7-year-old is 54 pounds. And 180 is about the average for males, somewhere around there. So if that 7-year-old can lift their dad and go 4 miles, that's what we're doing.
That's pretty awesome.
That's what we're doing.
Pretty awesome.
Yeah, and 4 miles, and they're going. We've seen them going 15, 20, even as much as 40 miles an hour.
They're at 25 right now.
So your 7-year-old carrying the dad, running for 4 miles. That's what we're asking these machines to do.
All right, question is, the top right corner has gone to black. It is no longer green.
Right, so we did see a bobble.
Yeah.
I wasn't watching quite, but they were up at 200.
Yeah, they got an altitude violation.
Yeah, so they got an altitude. This might be the same that we saw.
Uh-oh. Coming down fast. Coming gentle. Bounce. Lost the weight. And back up in the air. And a relatively minor hard landing.
Hard landing, that's right.
It looked to me for that multi-rotor. I'm almost starting to think it might be a feature that Velcro breaks loose when they hit the ground. And it's sort of like, like an F1 car comes apart in a crash to disperse the kinetic energy.
All right, handshakes.
Yeah.
All right, we made an effort for third place.
Currently sitting in top 5, so here's one more time. This is MacGyver after the violation.
Coming down. Velcro comes off.
Pilot regains control.
Flies for a little bit.
Keeps it from going over the
brings it
flight
right
line.
back to him.
Yeah.
Doesn't look. I mean, the rotors are still going. They just.
Yeah. Just that power settling. Couldn't get the power to idle fast enough. That's why it flew. It looks like it's somewhat under control there. Came down. Now, what you sometimes have seen, you've seen it with the RPICs, the remote pilot in command. They've been standing behind that Jersey barrier with the fence. So we thought that this might be a scenario where an aircraft could come back. There you go. You see it on the right with that Jersey barrier. So they're hiding behind that for these scenarios.
It's just so close, and I imagine they have some spare parts out there with them. What are the chances? They've got 35 minutes.
Man, that would be crazy. The aircraft is right there. They brought it back to them, but I doubt they'll be able to put that back together in time for this. But really great effort there. Trying for third place. Couldn't quite make it.
So MacGyver sits in 5th as it stands right now, and they have a little bit of a conflab to see what they're going to do, and they're going to speak with the course marshals, supervisors, to find out, hey, fellas, I think we can fix this. Donna gave us some special duct tape earlier this week. I think we can make it work.
It's that Dyneema duct tape.
Exactly.
Yeah, you look at that and it looks relatively intact. In fact, I almost don't see a broken propeller.
That's right.
And you might think, well, just slap the weights on it, get it back up in the air again. But after an impact like that, that's really the last thing you want to do, isn't it, Donna?
No, and you got to think about safety and probably, what are the spare parts. So after a crash like this, we actually would not let it go back up. So it sustained a major impact where it had an uncontrolled departure there. So we would actually require them to go back to the run-up area to do a safety check in the run-up area, then come back to the line and do their safety flights again before they were allowed to go.
Let me ask you a question. If they had hit the ground, the weight detached, and then they had regained control and not had the subsequent impact, do you think they would be allowed to fly again?
Yep. Oh, yeah. They're one of the props came off. So that one on the right does have a broken prop. There it is on the
I do see that
runway.
And I actually thought I saw one of the props slow down and the folded, which would indicate the motor lost RPM before they hit the ground.
Interesting.
So they'll stay in 5th, 2.51 payload to weight ratio for MacGyver. Great job. Extreme Aerial is still out on the flight line as we are approaching the final 30 minutes of the flight window here at the 9 o'clock Eastern time. Remember, we've got another one coming up for you at 11 o'clock Eastern time. They are fully loaded for go. Extreme Aerial out of San Jose, California. We did see them go up earlier, do a little test run. And they went up with 3.71, which would not put them in the lead, but it would put them into second place.
I noticed it looks like there's a tape line on that fuel tank. Looks like that's their fill line. And that, you see, we talked about how you want to go up with just enough fuel to finish the run, but no extra weight. I'm guessing that tape line is showing them exactly where they need to be. And it also looks like there's another line down at the bottom. I wonder if that's a marker they've put on there for their final leg. Maybe that's their
They're
last
ready to
little
be
bit.
for the final
I
nautical
don't know.
mile.
It's pure speculation here. It could
But it's
just
good
be a part of the tank.
speculation.
Yeah.
There's a lot to this. You look at the right-hand side of this, trying to find out where they've put that Titan monitor. Is it on the
Bottom right corner
Bottom
right there,
right corner, okay.
that gray box that's
Okay.
facing up. It's random data if you guys want to know, but there's the tracker number on that white piece of tape, so that connects into our system so that we know that, hey, this tracker is in this lane. That's how we register it into that geofence, and then how it has that automated tracker. So the lane coordinator is not having to use their eyeballs and say, hey, you're too low, you're too high. And it helps with fairness, right? So this is all automated. It's the system that we have prepared for it.
Well, here's what the Titan screen looks like, and we're talking about that. The little gray box is attached to every single craft that goes up. This is the data that is given back to the ground. It goes back to ops, and they can tell you exactly the numbers they're putting up. It can tell you what kind of material they're running, what kind of fuel they're running.
Yeah, and their location. You see those green dots showing the exact location of the aircraft inside the flight line, and that's how they make sure that they're not breaking that geofence, both from a perspective of safety and from a perspective of scoring and adjudicating the event.
Yeah. So this is a live shot. So it's interesting. You see that one green dot that's a third of the way up the lane there, and that's one of the crashes. So it is laying there waiting.
Still sending out signal.
For still sending out the signal, but waiting for the end of the flight window, the all clear, the cold range, and then our recovery crews will be able to go down there and pick up those aircraft and bring them back.
Is that something that was developed specifically for the DARPA Lift Challenge, or is that something that existed beforehand?
The tracker was, and a great team of guys 3D printing those boxes, and they were in there with little screwdrivers and putting everything together. So we got a networked radio on there. We've got the battery pack. We've got the GPS and the 2 antennas as well. So we have a GPS antenna that's put on the aircraft, and then a communications, a radio antenna that's also put there.
Donna, what might be on that screen that's in front of the pilot?
So that's probably their control system, their computer behind the scenes, so that it's just large enough so that they're able to see the fine print. You see some guys, so that guy has is that a laptop or an iPad? No, it's an iPad in front of them. They are given one of the iPads, the tracker iPads, so that visual observer that you see there on the left in the green, he's got an iPad that he is tracking Titan, so he's able to give commands to the RPIC, the pilot, and also probably has his system running through that screen on the tripod to be able to monitor his system status.
You know, you said the term RPIC, the pilot, and I told Todd earlier that some full-scale pilots object to drone pilots being called pilots because our butts aren't actually in the seat.
Right.
As a full-scale pilot, you're a Harrier pilot. You want to weigh in on that?
Oh boy, you're gonna get him in trouble.
You know, it's kind of like fighting the future. It's kind of futile. No, there's respect all over the board, but yeah, there is a little difference, and I'm biased, but when you've got yourself in that aircraft and your life is on the line, but different skills, different capabilities, and as we see here, still willing to take risk, just in a slightly different way.
Yeah. I'm going to take back my tape comment. I think that is a metal strap that is holding the fuel tank onto the aircraft. It's just a coincidence that it's built to that line. Yeah. Maybe they put the strap there specifically.
This is extreme aerial now to San Jose, California. And a 3-4-5 ratio. So, gentlemen, this would put them into third place.
Which would keep them there. They are in third right now. But this is good on them, right? They're in third place. You just saw the rest of the field. Their competitors kind of dropped out. Now, there is the other 2 fly windows. So what they're doing here is trying to cement that 3.45. They did that hover, which was at, I believe, 3.7, somewhere around there. 3.71, so that would have put them into second. They did a systems check. They saw that kind of settling. They didn't have enough power. They brought it back, and they still said, you know what, we're going to bump up our numbers here and try and ensure that we hold on to that third place spot.
So protecting third spot for Extreme Aerial Concepts out of San Jose, California. see if they can get it done. Remember, keep an eye on that upper right corner. If that stays green, it is good. They've got to travel 4 nautical miles, not exceeding 200, not dropping below 100, drop off their payload, then do another nautical mile without the payload, and then land it in the appropriate spot. Got to do it all within 30 minutes, and they're right about 30 minutes left in this flight window.
So if you remember H Squared, they had a very similar design. Actually, the engine manufacturer is the same company, the same person who hand builds these engines right now. And they crashed, was it 2 days ago, I believe? And talking to the team afterwards, it was very disappointing. They had a simple engine flameout, and that caused the aircraft to crash. So they were a little disappointed that it wasn't something else. A structural failure or a tail rotor failure.
Something that would have pointed to...
and said, okay, this is what you need to reinforce and learn from. Back to our conversation earlier, though, about complexity of systems. So these ones are extremely simple. You have a turbine that drives a drive shaft, and that goes to that single main rotor. So your failure points are much lower. But as we just saw, if it fails, it goes down, right? There's no backups. But what we're seeing from all the electric versions out there is very similar. Because of that weight constraint that we've put on people, they don't have backup systems. They don't have a second and third order backup system. So any failure fails just the same as these relatively direct and simple versions as well.
You said turbine, and I've heard people talk about that one of the revolutionary things that's being done here is turbine-driven rotorcraft. What's the alternative, and why is that revolutionary?
Well, so actually, all aircraft, that almost all of the helicopters you see flying around are turbines. Now, more specifically, turbo shafts. So a turbojet or turbine jet engine is what you see in your normal jet aircraft, anything from a Boeing down. There's different ratios, bypass ratios, that make them specialized in certain ways. But these ones, instead of blowing air out the back to create that thrust, they blow air into another set of fans that turns a shaft. So that's why it's called a turbo shaft. That is how all or most of our helicopters fly around today. The revolution here is that they were able to get such a small version of that.
I see. So turbine engines are normally too big for a craft of this size and weight.
Correct. So being able to get it down. So this one is an 8-pound turbo shaft creating 23 horsepower, which is really impressive. Normally those are heavier turbo shaft engines to be able to create that 23 horsepower. So that's what allowed both of these teams to come into the competition and say, I think we can do it.
Boy, they were pushing almost 40 miles an hour there for a short time. And you see when they make the turn, they drop it down to around 5. They are over a 1.8 nautical miles into their 4 nautical mile run. Stayed at about 154 above. Payload to weight ratio, again, is 345. So they're carrying 189 pounds plus. And that vehicle is just under the margin of 54.9.
You know, Donnie, would you say that another goal or another effect of the DARPA Lift Challenge is to shine a light? Like, this guy's got this engine, it's got a ridiculous power to weight ratio, and potentially a lot of people out there have never heard of him. He comes here, whether he gets in the money or not, he does something very interesting and people start noticing.
100%. And actually, that actually happened to me 2 days ago. I got an email from a military leader who said, I need transport. I need it, up from short range to long range. I need it from low weights to high weights. He's like, now that you're doing this challenge, what do you have? Because we need it right now. I told him, I was like, sir, can you give me a couple of days? I gotta finish this challenge, and then we're gonna be on emails and starting that process. And now for everybody who's watching and the skeptics and stuff, these are prototype competition aircraft, right? Some of them are relatively quick to be able to get into a commercialized product, and others are going to take more work, and that's okay. We're identifying them. Obviously, you have to weatherize them, so they have to be able to fly in the rain. You have to bring down that payload a little bit to increase the safety margins. and then you've got to add the communications equipment, the other safety equipment, or just operational equipment to it. So you're going to have to add things. You're not going to have these payload to weight ratios in the operational sense, but that's where that 4x ratio was, right? So we dropped down to 3x. Okay, that's 3 times better than what we have today. That's a massive improvement.
Yeah, I see a lot of people out there. They have a lot of marketing materials and a lot of claims, and then you kind of just have to buy their product, and maybe it works or maybe it doesn't. And now these people are coming here and they're proving what they can do.
And they're proving it in pretty, actually, for aviation, fairly difficult conditions. And you would say, what? It's beautiful out there. It's hot. The sun is beaming down. UV index is high. These aircraft are soaking it up. Now this morning it's a little bit better than it has been the last couple of days, but it's real conditions, real weather. So far we have not canceled anything for weather. We actually have a 25 knot limit, so if this is blowing like it was yesterday at 17, I think we got up to 17 knots, people were still having to fly or they were having to forfeit their window.
So still, Extreme Aerial Concept, they have passed over the halfway point of the 4 nautical miles. They're at 2.17, still green at the upper right corner and still above 100 feet. And it looks like MacGyver's got that thing up on the table. Are they just assessing, or are they trying to think?
That's a screwdriver.
They're trying to prove Donna wrong. They're saying, we're going to get this thing back up and flying.
So once again, I made a armchair quarterbacking here from the broadcast booth. If the lane coordinators go up there and say, hey, you didn't sustain that much damage, right? They're inspecting it now. All you have to do is replace a prop. They're making that on-field call, right? And so I've got very talented people out there, safety conscious. We'll have people reviewing it and seeing if they, in fact, can go out here. We are running towards the end of our flight window, but if we remember back from their run, they were cooking.
Yeah,
they were cooking.
Looks like they were inspecting their battery pack, that sort of gold-colored thing on the bottom.
Speaking of cooking, look at this. Extreme Aerial Concepts, they're coming up on, 2.5 nautical miles. They're only into this thing 9 minutes, and their speed is just fluctuating. It goes down from 7-8 miles an hour up to 30 and 40, so looks like this is a turn. Really slow it down. What do you call it, a hockey turn?
So the hockey stop, the hockey stop is when they just pull it up just like a hockey skater, right?
Come in,
slide, and then go back the other direction. These guys are actually using their tail rotor to be able to kick it over and then turn direction.
Yeah, they're making a little bit more of an aggressive turn as opposed to sort of leaning back, sliding to a stop and turning.
This also gets to the comfort level of this design. In reality, normal manned helicopters, they would be a much more dynamic maneuver, and there are ways of actually conserving power and therefore conserving the energy, but also the forces that act, the G forces that act on your aircraft. So you can do sort of a looping maneuver. You can go up and then turn that bleeds off your airspeed as you're climbing and then coming back around. The thing is, with this small box that we have, you don't have a lot of room for error, and everybody is working on their flight controllers and figuring out the controllability or the maneuverability of their aircraft, so they're not doing the traditional turns that we see in normal helicopter aviation.
Yeah, and certainly from the way that it's making those turns, there's almost like a pause, tick, a robotic nature to the movement. I would assume that they're flying autonomously, and autonomous flight controllers aren't so good at those aerobatic maneuvers.
So here we go. Extreme Aerial Concepts is just passing 3 nautical miles. One more to go. And look at this. MacGyver has MacGyvered this thing, and they've got it back on the pad. They're in 5th place right now with just under 20 minutes. Let's just call it 20 minutes even. This would be amazing. If they get this even, just get it back up in the air.
If they just get it back up in the air, even put some weight, but run out of time. The grit, the determination. They're 5th place, and to get out there and not to just throw up their hands and walk off the stage,
that's awesome.
It's inspiring.
Extreme Aerial, look at this, 3.1. Watch the speed come up after they make that turn. Pushing 30 miles an hour, 32 miles an hour, 35, 37.
39,
40. Holy smokes.
and then decelerating as they get into that. So just peaking out at 40, and then they immediately begin decelerating for the turn. Look at how long they spend accelerating and decelerating.
Right.
As you said, Donna, the short length of this field is definitely affecting the competition. If they could get up to that cruise speed, they may not be hitting their optimal cruise speed, but if they could just get there and stay there,
correct,
spending a lot of energy,
spending a
down,
lot of
speeding
energy
up again.
And it's also stressing all of the components, right?
Sure.
So if we made this course for just 4 miles straight line, we'd be seeing a number of different concepts going and breaking that 4.0. And this goes back, Josh, to the comment you made just recently about websites. So it's very funny looking at websites and all the claims that they're making and everything. But they don't tell you under what conditions. There's no kind of standardized evaluation of aircraft, similar to miles per hour or gallons per mile, miles per gallon. That's sort of a standardized factor that the auto industry has, so that customers can compare equally.
Right.
In aviation, because there's so much variability in what you're doing and so much ability to specialize the aircraft, there isn't that baseline. And that actually makes it very difficult for the customer to go out and see and know what they're doing. And part of this competition was to do that, was to have that standardized course and then to judge everyone equally on that standardized course.
So we are watching Extreme Aerial Concepts. This is, in fact, a scoring run. They are approaching the 4 nautical miles. The length coordinator will give them the okay, the clear, to bring that payload down. And that's when they can drop down below the 100 feet, drop it onto the platform. Has to be there. The interesting thing is, and I don't think they're going to have an issue with time, JB, because they're only at 13 and a half minutes, so they have more than 15 minutes to unload and do 1 nautical mile.
And we have just over 15 minutes left in this flight window. They do need to be on the ground. If they're in the middle of a competition run and the flight window ends, they will have to terminate their run. But it seems like
they're at the 4 miles now, and they're coming straight down from 160 feet. That's actually a very difficult and power-hungry maneuver that they're doing right now. In manned aviation, you generally use the glide slope, and you come down nice and slow. But with the automated systems, like you said, JB, the complexity sometimes is not there. So they went right to, just over 4 miles, and then they just are hovering straight down from 160 feet, I think I saw.
Now, do you think the pilots, I do think the pilot is bringing it in manually. You can see the helicopters coming in tail first.
Correct.
We've talked about that pilots, when they're flying manually, will typically fly nose out to maintain orientation. Why might they be landing manually instead of just letting the autopilot? Wouldn't the autopilot do a better job?
There's so many ways. There's so many differences. You don't always know what the autopilot is going to do, but if you have a good enough pilot who's comfortable with the aircraft, you might trust that. Right, there you go. That was great. So you just say, hey, I'm going to trust the human instead of the machine at this particular point. Okay,
so they are on the clock. They've got 15 minutes to go before the flight window closes on this run. Remember, it's 30 minutes. And what I'm looking at right now, Joshua, is that fuel. Did they call it exactly right? You call those 2 pieces of tape. That looks like what they need for the final nautical mile?
Yeah, well, this is what we saw last time. We've seen them do a weight change before, and I noticed it was at about that same level. This is a little lower this time, so they're potentially carrying a little more weight and consuming a little more fuel. But we don't know if that marker is indicative of anything to them or not.
So you're probably correct with that one line that goes across the tank, but from this view you can see a little black dot, and we did see the fuel at the beginning just above that tape.
Yep.
So they might have marked the fuel line with a black dot, and then also you see the tape at the bottom, and they're at an angle. They might have said, hey, these platforms are kind of tilted, and so whichever way it's tilted, I'll know what the fuel line. So on the right side, it's right there on the line. This is speculation once again. This is us just kind of gaming this, but these are techniques that people use. So it's not coming from random thoughts here. It is the way that people go out and do flight testing.
So now they've got to get that payload off there. They've still got 15 minutes. You know, not speculation. MacGyver, back in the air.
Back in the air.
Back in the air. Let's go to this. This is just a short time ago. Look at this. Just to prove they could. without the weights. But you know what? I love this.
I mean, the fact that it's flying at all.
Yeah. What was that?
25
minutes ago? 25, 30 minutes ago? Look at us.
We're doing it.
That's just showing off now.
Well, I think that clearly indicates there weren't any major repairs, or they wouldn't have gotten done this fast, and they wouldn't have been allowed back in the air
and obviously
again.
the lane coordinator checked it, made sure for safety reasons it wasn't beat up, and they just slapped some glue on it.
But no, they just wanted to show, hey, it's still breathing, it's still living.
5th place, 2.51. I think a lot of teams would have said, hey, if you can guarantee me top 5, I'm good for that.
We're already seeing emails now of people saying, man, I wish I could have made it. I could have done it. I could have been on the leaderboard. We're like, yeah, you could have.
Well, let's talk about that. I heard from people when I started talking about this event, and I only started talking at the very last minute. They said, boy, if I'd only known about this, I would have competed. How can people get in the pipeline to find out about DARPA challenges?
You know, I was actually talking to a team this morning about exactly that. And it's funny. We made a massive push for this. We hit the different societies, so AIAA and Vertical Flight Society. We had them push it out via their email list. We hit university lists for all the engineering programs. We did social media pushes. We did media interviews. So we did a valiant effort on pushing out the information. But sometimes people, they just don't watch the news. I know I don't sometimes, and so it's difficult finding them. But it's also one of the reasons that we're doing this. For instance, this broadcast, this is one of the reasons that we're doing it, is to be able to reach those people, is to be able to bring awareness to this issue and to this technical challenge, and to say, hey, not only the people that came to this competition, but also the ones that didn't and never heard about it, please try, right? Try and do it. Try and go for that 4X.
Do you think your phone's going to be blowing up on Monday?
It probably is. It probably is.
I'm sure it already is.
Yeah.
So there you see the fuel situation right now. They've got the weight off. Now, can they do any modifications at this point?
Nope.
This is just straight reload.
Well, okay, so sorry, let me go back to the rules. So they're not allowed to add energy sources here. So they're not allowed to add any fuel or change batteries. We did see some interesting concepts early on that were transforming or morphing because some designs fly drastically different when they're loaded and unloaded. That people had a concept where, hey, I'm going to morph this aircraft, transformer style, and when I take off the weight, I'm going to take off those or collapse the large lifting surfaces, the one that are used to lift heavy things, and I'm going to use smaller things. We didn't allow them to remove it, so it had to stay with the aircraft, but we did allow them to do something. We haven't seen any of those designs or those concepts out here. We had one person who was going to switch blades in between, but the blades, the old blades and the new blades would have stayed on the aircraft and would have been counted in that 55-pound weight.
Okay. I noticed as the rotor was being adjusted there, once the rotor in a certain position, I suppose, both the tail rotor and the main rotor moved together. Those are mechanically linked and driven off the same drive source, and in some cases they'll actually interleave with each other and be just carefully timed so they don't hit. Of course, in this case, we don't see them overlapping.
That's right. Remember Aviadrone, so they're coming up at 11. Remember when they dropped the weight?
Right.
So I talked to the team, and we were going back and forth here saying there's two things that could have happened. One is they could have a failure in that automated release mechanism. The other is that they could have seen an issue that was happening with their aircraft, dropped the weight, came back and fixed it. It was actually that. So they have a belt-driven system, and that belt was not tight. It was skipping. And they could hear it out on the flight line. We couldn't hear it here, of course, in the broadcast, but they could hear it on the flight line. They went out, did one flight. They were hearing the skipping, and they said, you know what? We can't do anything about it right now. We're going to send it. And that's when they went to the 4-1. The first time they went up there, they heard it. They said, maybe let's try and tighten it. They pickled off. Pickled is a word we use for just dropping. So they pickled off those weights. They came back, they tried to tighten it, they put on that 4.0 and sent it. So that actually was a strategic decision and an advantage to those designs that have an automated release mechanism.
So Extreme Aerial is spinning back up minus their payload. They've already completed the 4 nautical miles. They just have to complete 1 nautical mile now without the payload. They're trying to up their third place number and give themselves a little stronger hold on third place. They bump on up to 3.45, so make it a little more difficult for either teams to try to jump them into third.
Yeah, and third place, of course, being the last place that gets a cash prize.
Yep.
So if you're in second place, well, you're not going to rest, but you might feel a little bit secure knowing that $1.5 million prize would only go down to $1 million. But if you're in third place, getting knocked right out of the money, you definitely have an incentive to try and improve your standing. And you can see that. I like the liquid fuel, because when they have batteries, I don't know how much juice they have left in the tank. But with the liquid fuel, I can see that tank.
Definitely.
I can know for sure. It sure seems like they have pretty good odds of finishing this unloaded test flight. This aircraft. We talked about how some of the aircraft will fly better with the weight on than with the weight off, but these helicopter-style designs don't seem to have too much trouble.
So still green in the upper right hand as Extreme Aerial continues their final nautical mile before they bring it home. I want to say thank you so much to Philip Smith, the program manager, call sign Donna, all week long, man. We appreciate you've been generous with your time, your insight.
Thank you,
it's
guys.
been fantastic. Couldn't have done it without you.
Yep.
JB and I would have been hoarse by now if you hadn't filled in. So we
this
thank
has
you
been
so
amazing.
much. And to your entire team. I mean, it's been brilliant.
This has been fun. I didn't realize how much fun I would have up here calling these aircraft and what has been happening. I'm going to spend the last 2 flight windows out on the line with the team. We're going to have FOD walk at the end, aviation tradition, where everybody gets on line and walks down and picks up all of the pieces of our valiant warriors who have crashed. But I really appreciate you guys. Thanks for everybody who's been watching, and hopefully this has been an inspiration to all those at home, a catalyst to more innovation, to more groundbreaking technologies. So thank you very much.
Thank you. If this DARPA thing doesn't work out for you, there's always a spot for you on TV.
Hey, I'll think about it.
All right. Thank you so much, sir. We appreciate your time. Donna's going to step aside and go do his day job. We appreciate him for all his work, all his insight. JB, he saved our bacon a time or two.
He's definitely added a ton of insight.
Bringing some insight, bringing some stuff to us. So, and we continue to watch now Extreme Aerial Concepts. They are 464. There you see their altitude. They're good there. Their payload to weight ratio 345. As we said, that would just give them a stronger hold on third place. And as JB pointed out, that is the final paying position. 473, they're getting awfully close. It'll be interesting, Joshua, if they come in and do exactly what they did when they dropped the payload, come in reverse and just do it manually.
Oh, yeah. It seemed like they're landing it manually. You know, that autopilot bases its position on GPS, and GPS drifts a little bit. You know, sometimes your Uber shows that you're on the wrong side of the street. And when you have to land within that 5-foot radius circle, 5-foot radius seems big, but you know, it's not so easy when you're trying to set her down.
They did it well, and so far so good. They're at 24 minutes, coming up on 25. They have just a little bit of time to go, but they should have more than enough, and more than enough fuel. I've been watching that tank as they come around and seeing the tape lines on there, and they called it right.
Yeah, and I see that pilot over on the right. You can see he's got eyes on the craft, and from the way he's holding his controller in his hands, the way his fingers are positioned, it sure looks to me like he's flying manually, or at least ready to take over flying manually. Now he's a little more relaxed.
So the lane coordinator right there is confirming on the stats off of Titan that they have in fact gone the 5 nautical miles. Let him know he can bring it down. Look at that. Look at the fuel.
That turn. Yep, just enough fuel, not too much, not too little. And all we need to see is for them to come in and make that landing on the landing pad, and that should finish out this scoring run.
Nice way for Extreme Aerial Concepts to end their stay here at the DARPA Lift Challenge on the 7th and final day on their 10th run, so a pretty good ratio to success. They will come in at 345 on the payload to weight ratio. That will put them firmly into third place, giving themselves a little bit of a buffer, but still 2 more flight windows to come after this one closes down. Again, we will have one at 11 o'clock and then 2 o'clock Eastern time, and here is the landing.
Just need to see them touch down to the center of the plate in the circle.
dead, solid, perfect.
Doesn't get much better than that. Look at that rotor right in the middle of the circle. And cool as a cucumber. No cheers, no fist pumps.
Yeah.
Just another day at work for this team.
Ain't no thing but a chicken wing on a string as they drop it down. 3, 4, 5, success. So Extreme Aerial Concepts solidifies their spot in third place. Good time, too. I mean, they didn't rush it, JB. We saw their times go up and their speed going up to 40 miles an hour at some points, then dropping down for the hockey stops, as Donna likes to call it, but now they'll bring the rotors down slowly and look at the fuel. Call it just. How much further do you think they could have gone?
Well, I mean, we know how far they went. They went 5 nautical miles. Like, what percentage of that tank is left? You know,
maybe half a mile?
Maybe 10%. Yeah, maybe half a mile. Also, that.
Look at this. MacGyver back up with weight. I mean, this is 4.13. They're not going to have enough time, but this is amazing.
They're showing that they can do it. Lifting, 4.13 payload to weight ratio. Oh my gosh. Yeah, they don't have time to complete a run, but just want to see if they can get up there, show everybody what they could have done potentially.
Wow, look at this. I mean, that thing weighs 55 pounds. They've got 226.9 pounds on board. That would put them at the magic 4.13. If you're just joining us, they were up on a scoring run. They had a crash. The weights jettisoned, but we thought, they're done for the day. Cracked out some screwdrivers, JB, and look at this. Back on the line, flexing their muscle. Yeah, again, they would need to fly 5 nautical miles with that weight to actually score, but they were like, as long as we got some time, let's get it in the air. Let's let everybody remember our name. They look happy. So well done, MacGyver. Yes. 4.13. They got it up in the air for a minute. That's amazing. I mean, that is amazing how quickly they turned around on the fix. Yeah. Certainly speaks to some of the advantages and disadvantages of the different designs. We've seen we saw one design made of balsa wood, very light, very strong, not very repairable. This design, one of the advantages is that it is fairly robust. It bounced off the ground, it shook a little bit, they replaced a prop, they made some minor repairs, and 15 minutes later they were back in the air again. So since they're so close to the platforms, we'll go out and retrieve that. And I would say that is a very successful flight window for MacGyver. Yeah, everybody here. Just getting here, just being invited to be here is a success. And then getting here and getting off, getting onto the leaderboard, completing a competition run. There are so many successes for all of these teams as they have gone through the competition. Of course, the biggest success everybody reaching for is that number one, to get on the leaderboard, getting the money, and then number two, to break that 4-to-1 payload to weight ratio. And I believe there are some teams who have said they are definitely going for that 4-to-1 in the next flight windows. Well, some more numbers to throw your way. 489 teams applied to be here at the DARPA Lift Challenge. 132 were selected. 76 made the trip here to Dayton. And MacGyver was one of them, and they currently sit in the top 5 position. So just a final few moments here in this first flight window of the day. We've got 2 more to go. Of course, coming up at 11 o'clock Eastern time. And then the final flight window. Double secret probation, final. There is no more. There's no overtime. There's no anything. Will be 2 o'clock Eastern time as the next teams are starting to make their way out for the 11 o'clock flight window. The slow parade route, and we'll just know who's coming up in that 11 o'clock flight window. Maybe it's a team you've been pulling for if you've been watching all week long. Again, this is day 7, and there is a team that probably we're going to take special note of, JB, because we're going to watch them. 11 o'clock you'll see MTech, you'll see Avidrone, the current leaders, and Vertsolve, who joined us on the set the other day. And then at 2 o'clock Capstone. Look at this, MacGyver still flying. Just keep going, guys. I guess the lanes aren't closed. They're like, hey, they're waiting for Donna to come shut them down personally. Donna's going to go have to shut them down personally. We're hearing that they got a 5-minute extension. So, and you say, what are they going to do in 5 minutes? I'm going to fly my drone. I came here to fly my drone. I came here to put weight on my drone, and I came here to fly it. And by gosh, that's what I'm going to do. says right now they're at 5 feet, descending to 4 and 3, but it looks a little higher than that. Again, 4.13, that's 226 pounds. And a very stable hover. Why not just use up the juice you brought?
You know what they might be doing? It just occurred to me. So lithium batteries don't like to be fully charged. They don't like to be empty. They like to be right in the middle.
They're going to set it down. There we go.
If you have a gigantic lithium battery and it's fully charged and you don't use it, you have to take it home and you have to do what's called put it at storage voltage. And that takes a long time. Of course, your drone motors are pulling a huge amount of power, generates a huge amount of heat. If you have to take it home and put it into storage mode, it could take hours and hours and hours. And so a lot of times if people have fully charged batteries at the end of the day, they'll just put the drone up and they'll just run it.
Let it drain.
Try and run it down to storage. And maybe they're just running their batteries down. It's possible.
So 4.13, unfortunately, they did not go the full 4 nautical miles plus. But look at this. I mean, that is something to behold. If I'd have told you 6 months ago, JB, that a drone's going to pick up a 4.13 ratio.
I would have said, I would have said, prove it. I would have said, prove it.
And I would have said, MacGyver.
In my head, I would have said, I don't think so. But I've been wrong enough in my life that I wouldn't have said it. But I would have said, okay, prove it.
Well, we just watched.
Talk is cheap.
We just watched a MacGyver mic drop.
Yes, sir. A lot of mic drops. A lot of mic drops.
Will we see the big kahuna mic drop? Can they go the full nautical miles 4 and 1 and make the 4-to-1 challenge actually happen in the payload to weight ratio competition here at the DARPA Lift Challenge in Dayton, Ohio? This is Super Sunday. We're coming down the home stretch, and the final moments are starting to tick away. Folks are starting to pack things up, loading up in their vans. Not quite top secret transport, but
is that going to fit?
Yeah,
is it going to turn it sideways?
You go to the rental car agency. I say, I need a car that I can fit my drone into.
Yeah, I told you about those folding props. You see how important they are.
They're not driving back to Puerto Rico on that. I can tell you right now.
It would not have fit. Now they're going to break that down and ship it, I'm sure.
We're coming up on closing time, and that will happen roughly at 3:30 Eastern time today as the DARPA Lift Challenge will come to a close. Looks like, is this Hanamontan?
I believe it's Hanamontan.
Maybe they have some lithium batteries they want to.
I don't know. I guess they wouldn't be going in the air if the flight window had closed, so they presumably have gotten an extension. Yes.
Yeah, I don't think they gave them. I mean, the next flight window starts in less than 30 minutes, and they would need almost 30. It's 3 minutes past the no joy of 10:30.
Yeah, we don't know exactly why they got an extension, but some of the things that could cause it would be, number one, if the tracker was down for any reason, then they would extend their time, because that, of course, is DARPA's issue, not the team's issue. The other thing that we've seen cause an extension in the past has been when one team crashed and had a fire, the adjacent lanes were not allowed to fly in case there needed to be a response, and of course those teams were granted an extension. We don't know why Hanamontan got an extension here.
A lot of creative reasons and strategies to try to get a little extra time out of Ann in the control area, but command center. But no one's used the. Donna wasn't on the flight line during my flight, so
they might have tried it.
Yeah,
they might have tried it, but
they got him off the set. We won't unfortunately not get him back, but we do appreciate his time over the last few days. This is Hanamontan as we come to the end of the flight window at 9 a.m. Eastern. Get this thing up and let's see what it can do. You might as well spin them.
Yep. Might as well.
So we can't officially say the flight window for MacGyver has come to an end. So they have closed. They are done for the day, done for the week.
Yep,
we are waiting for the final call that the range is cold.
Yeah, these teams are going up. In the past we've seen them go up. We've seen them try things, and we've said, well, they'll be back. But this is the last day, and for I think all of these teams, this is their last chance On previous days, some of the teams might have had, if there was an open spot, they may have been allowed to roll into that open spot and make additional attempts. But today, this is it.
So we'll remind you, coming up in less than 30 minutes, the 11 o'clock flight window will open. This is Aviation. That is the team that is currently in the lead with a 3.84 payload to weight ratio. Now, since they haven't broken the 4-to-1, Joshua, they are not entitled to the $2.5 million. But if they stay in this position and do not go over the 4-to-1, they're still entitled to $1.25.
$1.25 million, and you know that's certainly enough money to get you out of bed.
Yeah.
But beyond that, it's about more than the money for these teams. I mean, obviously everybody appreciates it. These teams, all of them, everybody who got here is about just trying to do something that's never been done before. That 4-to-1 payload to weight ratio, or even heck, a 2-to-1 payload to weight ratio.
So there's the flight line. When we speak of it, you can see just how expansive and long it is, and there's plenty of room for these creative industry folks to push the limits of what is possible here at the DARPA Lift Challenge. This is day 7, Super Sunday, the final day of competition, and we've got 2 more flight windows to go, one at 11 o'clock Eastern and 2 o'clock Eastern.
Flight line, be advised the flight window is now closed. I repeat, the flight line is now closed.
So it is now a cold range. It is official. That gives us about 22 minutes until the next flight window. The team's already down there, and they are in their prep tents getting ready, and they will be on the flight line as soon as that window opens. We will have coverage for you of that, continuing coverage all the way through. Once again, our thanks to Philip Smith-Donna, the program manager for the DARPA Lift Challenge. It has been fantastic having him on the set. Unfortunately, we lose him for the next 2 flight windows, but it'll be great. So on behalf of Joshua Bardwell, Elena Bueno-Rostro, I'm Todd Harris. We'll see you back here at 11 o'clock Eastern for the next flight window.
All right, so we're flying right now. As you can see in the background, it's up in the air. It's a little bit windy today, and actually from the lane coordinators, we were told unweighted flights are a bit of a no-go here. We're doing... Oh, boy. Well, you win some, you lose most.
We're feeling pretty good. We've developed our controls for high wind. We've been showing wind all week, so we think we've got the wind pretty much figured out. So hopefully we're going to have a pretty good unloaded wind run. Then we're going to start loading, and we're hoping that all the values scale for the heavier weights, and try to do some impressive flying. I don't know if we're going to be able to post a score, but at the very least put a decent, demo of the technology.
Temperatures are a little bit lower than the last day, so we try a little bit more weight. We might be going in a range between 180 and 200 pounds. So far, I think we lifted the most weight of any competitor, but we will see how the day is going on. So we're very excited, and we'll see how it works.
And today we're just going to keep it easy. It's a little breezy out there, and we're just going to maybe some hovering, some maneuvers, just to see how it handles today, and then maybe some flight tests. Once I get the batteries all hooked up, we'll head out to the flight line when it's open and have some fun. Oh, flight window's officially started. We're going to have fun in a few minutes.
Well, we're going to be flying today, Alpine Combat Systems Lane 2. We're feeling pretty great. We did a lot of tuning last night. We stayed up a little bit. Yeah, we're excited to fly. We thought we weren't going to fly, but we are, and we're just excited that we're going to get this last opportunity, it seems like.
Our goal today is to, first of all, qualify, get on the board, make sure nothing falls off the thing, and then I believe we have 2 flight windows back-to-back, so, we want to get data. We want to analyze that and try and, boost it up best we can after we get the qualifying run done.
But these guys, man, they were so smooth the other days. We're excited to see them. They had, this is H squared, okay, yeah, 3.35.
Okay, so no,
no.
they dipped.
So we saw them tilt backward, which itself is not necessarily a problem, but unexpected.
Our team worked really hard over the last 24 hours to do a bunch of weight reduction to the aircraft to improve that overall ratio. And so we were attempting to fly with 175 pounds, which would have calculated us out to be a 3.35 ratio, which would have bumped us into potentially second place as the leaderboard stands right now. During the flight, we did notice with the high winds that we're starting to see that it was starting to oscillate, so really wasn't comfortable with that. So I did take over the aircraft in manual. I was coming in for a landing. Aircraft felt fine, and then the turbine engine quit running. So I attempted an auto rotation, but with 175 pounds on board, that's just not possible at that weight. So unfortunately, this is probably the end of the road for us on this event, but we gave it all that we could do, and if this happens again next year, you might see us again.
So today was our second attempt of going up and lifting half weight. The bird was flying really well, super stable. As with all these test things, every time we fly, we learn something new. So we actually lost one of the supports on one of the motors. The motor stopped spinning, but the drone was fully controllable. So the pilot decided he was going to bring it in and fly another day. So tonight we're doing a quick turnaround, quick repair job, and we'll be back fighting again in the morning. Get on the board.
The intention was to make another flight with some higher weight. We did already 4 flights the entire week, quite successful. Unfortunately, we saw in the neighbor lane some crashes, and the wind picked up pretty bad. And I was looking over there, and it seems that there are showers and rainfalls coming in. And so we decided the risk is too high, and we will try another flight tomorrow, hopefully. It's sad things that happened, but I think it's our right decision, and I will wait for better weather tomorrow.
Just a check flight, making sure everything's good, no weight on there. As they will come back in, and then they'll do a half weight check if I'm not mistaken. And once that is done, then they can go up and go for real.
Well, we're excited. We actually had to come in with a strategy. We've been getting better each time, but we're also on our last props. It's windy today, so our goal was to get our check empty flight at least. But we're not going to lie, we kind of waited to see what the other crew did because they had a similar setup. But once we saw that they flew great, we went for it.
So protocarbon is up in the air. This is just a test flight.
He's got to set it down back in the intended location. That's part of the protocol. And I want to really be sure that you are controlling the aircraft and it's doing, well, maybe not exactly what you intended to, but within safe margins.
And so today, really just the main goal was to get into a stable hover, get some data on the tune for the vehicle that we just don't have. And it might not look like a lot from the outside, but this is more time this vehicle has ever spent in the air, by a factor of 10, and we have more data than we've ever had. So huge success for us and for the vehicle today.
The DARPA Grant Challenge is a prize-based competition that, in my opinion, is one of the best ways to accelerate technological innovation and breakthroughs. It is so clear and simple in terms of defining, hey, here's the finish line, cross it.
We are a high-risk, high-reward organization. That is how we work. And because of that, we look for risks in ideas that could change science and the fundamentals of understanding of technology.
So DARPA Challenge actually asks the world to invent something that one can only imagine. So there is no prescribed solution to a problem.
This format encourages small startups, non-traditional thinkers, and garage innovators to take the kind of high-risk swings that might not survive standard government design review.
DARPA is unique among the innovation organizations in the United States and around the world. I would venture to say that no one else could put a competition like this, have the reach, have the ability, and also have the history to prove that it's possible, that a challenge like this can redefine the world, can change the way that we operate in the military and also on the civilian side.
History shows us something fascinating. A technology doesn't necessarily change the world when it is invented. It changes the world when it becomes affordable enough for widespread adoption. Take the automobile. For its first 20 years, the car was a toy for the rich. It didn't change how the world operated. But when Henry Ford brought the cost of production down, it completely restructured human civilization. We also saw it with computers. They were around for decades, but until the personal computer was created, they didn't have a significant effect on how we lived our lives. And today we're seeing it in space. Space used to be a domain exclusively for superpowers and the exquisitely funded. But by transitioning to reusable rockets, the cost plummeted, and suddenly a massive commercial space economy is emerging that we previously thought was impossible. Today we're standing at the edge of the next great technological inflection point, heavy vertical flight that is economical for widespread adoption. Right now, if a company needs to move cargo, they run a cost-benefit analysis, they look at trucks, trains, and ships. Helicopters and drones almost never make the cut. Why? Because the cost per pound per mile transported is just too high. Vertical lift is reserved only for the most critical missions or the most well-funded industries. At DARPA, we want to shatter that cost barrier. That is why we launched the DARPA Lift Challenge. Our goal is audacious. We are challenging innovators to build a heavy lift drone that can lift 4 times its own weight. Let me put that into perspective. Today, a highly specialized helicopter has about a 1-to-1 payload to weight ratio. A 1,000-pound aircraft carries 1,000 pounds of payload. And commercial drones are often much worse. As you scale up the size of the drone to carry more weight, the cost just explodes. We want a 4-to-1 ratio. If we achieve that, we flip the math. Instead of a massive expensive vehicle, you can carry the same heavy payload with an aircraft that is a fraction of the size and a fraction of the cost. If we can drastically decrease that cost per pound per mile metric, we open the floodgates. We can envision moving heavy construction materials to remote mountainsides or rapidly deploying medical infrastructure. But the most exciting part, it's the unknown. Just like no one in 1908 could have predicted the drive-through window or the modern suburban neighborhood. We don't know exactly what new industries will emerge from this, but history guarantees that when you unlock this level of economic efficiency, transformative innovation inevitably follows. And of course, at DARPA, our core mission is national security. Today's battlefields are dominated by small drones. But because they don't scale well, they're limited to tiny payloads. Breaking this weight barrier will revolutionize military missions, allowing us to supply our warfighters anywhere on Earth at a fraction of the cost. In 2004, the DARPA Grand Challenge sparked the self-driving car revolution. The communities that formed in the desert that day went on to build an entirely new global industry. This is exactly what we are doing with the DARPA Lift Challenge. We are building the community, proving the hardware, and giving America the jumpstart it needs to dominate the multi-billion-dollar aerial economy of the future. This isn't just about building a better drone. It's about redefining how human civilization operates.
I'm here with my college friends. I just love RC airplanes and airplanes in general.
So that's why I'm here at Flight Fest. So this is my P-40 Warhawk. It's called the Nutball Annihilator. A nutball is another type of airplane, and it was the first kill this airplane got. It's gone through a lot of combat, it has a lot of damage, but it's doing pretty good still.
I've been coming to Flight Fest for 10 years now. My first time was in 2016, and it's a great event where I can put up these cheap foam board airplanes and not worry about crashing, and we're gonna put them head to head in just a minute here. My target today is my friend Luke. He has another P-40 that's painted very similar. I'm gonna look for him and try to take him down because we're driving back together tonight and we can't fit both our airplanes in the car.
Imagine carrying 4 times your own body weight. Crazy, right? We want a drone doing exactly that. That's the challenge we here at DARPA are throwing at inventors across America. And if they succeed, we could see a whole new generation of propulsion systems. Today's drones are limited by how much thrust they can generate for their weight. Some drones can carry a lot of weight, but they are very heavy and cumbersome themselves. But what if the teams competing in the DARPA Lift Challenge create ultra-efficient motors, revolutionary propellers, or entirely new and previously unimaginable ways to generate thrust? Suddenly, a compact drone could carry equipment that today requires something much larger and way heavier. More efficient propulsion could influence cargo, emergency response, and future air transportation systems. More lift, less weight, better performance. Sometimes when engineers chase an impossible sounding challenge, they end up reinventing the future.
Welcome to Dayton, Ohio. This is the birthplace of aviation. This is the home of Wilbur and Orville Wright. This is the place where they flew their first practical airplane in 1905. And now we're pleased to have you here as we take the next step in aviation development, the DARPA Lift Challenge. For the United States Army, Wright Field was the Army's aviation development center all the way through World War II. At this airfield, the first fully pressurized aircraft in the United States was flown by the United States Army. This is the airfield where the first woman flew a jet aircraft in 1944 off of this field. This was the Army's development center, so fitting into the DARPA development mission, easy fit.
Being here at this museum is amazing. It is filled with design innovation from brilliant minds who have thought outside of the box. For me, this journey is personal, this competition. My grandpa was a pilot, my dad's a helicopter pilot, and then I joined the Marine Corps and became a Harrier pilot. Aviation is in my blood. I have a passion for it. I love it. This challenge is not the end for me. I'm going to keep on going, keep on pushing the limits, and hopefully helping you guys push the limits as well.
I will venture a bet that in less than 5 years, this museum will have its own hangar for drones, US-made drones. And I think that the DARPA Lift Challenge will have a big impact on making that happen.
What's exciting for me is to think in 20 years, how many more designs will be around these hangars? How many will be here that were inspired by this challenge, by the things that you brought, that the teams brought to this challenge? The future is being created, and it's going to be celebrated in these hangars for decades to come.
feeling good. Haven't slept at all last night, so we're very tired. But today's kind of our last day of attempts, I would say, because we're probably a bit too tired to rebuild another one in one night. So we'll just send it, I think.
We'll take a look as they get into the air. Do they take off stable? Do they have any oscillation or wobbles?
That's 6.11 on the payload to weight ratio.
112.
All right.
Minimum.
So this is interesting, right? So look at their vehicle weight, 18.4 pounds. They were flying at 12 to 10 to 12 pounds. They've added enough structure there to be able to, what they think is to be able to carry that 6.1 ratio.
It doesn't look like they've added 6 pounds of tape, does it? They put a lot of tape on there.
That's either a lot of tape, a lot of wires, maybe some stiffeners in their structures. But they are up in the air. They still have to go 4 miles, correct? And that's where that orange bar is on the right. But they are in their altitude prior to that 0.5 total distance, half a mile.
And once you cross that 100, you cannot dip below, even if you're under the 0.50?
No, so what we did is after the 0.5, you can't dip below.
Okay.
We knew that people would kind of be bobbling up and down on their way up, but once you get into that altitude block and after the 0.5, that's when the automated geofence.
Oh, they were just about to hit the 0.50, and then they weren't.
Well, we were flying. We were very happy because we were actually underway with the full payload. That was our first kind of scoring run, and it looked promising. It was doing the mission all right, and it looks like it went down as it was turning around. I think it broke a prop, so the props are extremely light. I probably went a bit too light on the props, so they, you learn each time. I think with a few more iterations, it would work great.
And we are back at the National Museum of United States Air Force at the DARPA Lift Challenge at Dayton, Ohio. This is the 7th and final day. We like to call it Super Sunday as we get ready for the next flight window, which has already opened up at 11 o'clock Eastern Time. It will go for roughly 90 minutes. So just about to open up, I should say. Got a little premature on opening that up. I'm excited. I'm excited
hardly
to get the
blame
flight
you
line.
being
I
excited
know.
to see these guys get in the air and try to make their final attempts to either better their position or maybe crack that 4-to-1 payload to weight ratio that will unlock the full prize money. You know, all the excitement we've seen, the 4-to-1, the pride of having finally done it. Let's not forget that they're only getting half the prize money until they actually accomplish that goal.
I'm Todd Harris. That is Joshua Bardwell. He knows a lot about drones, and he has almost 500,000 followers on YouTube, so tip of the cap to you, sir. Avidrone is the current leader, and they are on the flight pad, so they are just waiting to get the green light. And they currently sit at a 3.84 payload to weight ratio. Remember, the magic number is 4-to-1 if they hit that. And if they are the only ones to hit that, they will be leaving Dayton with $2.5 million awarded to them.
Yeah, Todd, and it would be easy to say, well, 3.84 to 4.1, that's not that much more weight. It is more weight, but they've already done something so difficult.
Right.
What's a little bit more? And I think the analogy to use here is like, it's the end of the marathon. You're gassed out. You could barely run. And you're coming across the finish line on fumes. If somebody said, hey, do you want to run just 3 more miles? Could you just wake up and do it? These guys we've found the limits of what is possible in terms of the materials science, the fuel, the battery life, and just the human endurance. They're just trying to stretch that just a little bit more.
Look at this. Look who's back out on the line. This is the Stanford Online High School group. We saw them moments ago, and this is the squad from Iowa State. So they're on the line as well.
Flight line, be advised, the flight window is now open. I repeat, the flight window is now open.
So now it is official. As I jumped the gun just a little bit, my apologies there, as we are now 90 minutes away from closing the penultimate flight window here at the DARPA Lift Challenge. Remember, there's one more still to come. We'll have that for you at 2 o'clock Eastern Time. And as I predicted days ago, Joshua, it's going to come down to the last flight window?
Well, it was always going to come down to the last flight window. Even if these guys had all cracked 4-1, they'd all be trying to crack 5-1 to get into first place and just have the bragging rights of saying they walked away from this competition having done more than anybody else. These guys do not quit.
All right, so we will keep an eye on all the teams that are out on the flight line. As you heard from Ambush, it is open, so 90 minutes. Remember, the task, carry a payload of 4-1. That is payload to weight ratio, 4 nautical miles, and then unload that weight in a controlled environment, and then fly another nautical mile. You have to do it all within 30 minutes, and we've seen those successful teams complete it, not yet at 4-1, but they have completed it in just around 20 to 24 minutes. So that's kind of the sweet spot as they go out there and make their preparations. Well, it's always nice when we can bring some experienced pilots. Not that JB's not experienced enough, he is the man, but we can bring some more experienced pilots in who have participated in the DARPA Lift Challenge, and Tom Newman fits that bill. Tom's with Air Migos out of Fairfax, Virginia. Sir, thank you for your time.
Yes,
appreciate you sticking around. We had Donna on earlier, and you were kind enough to be patient. Tell us about your team, first of all, and what your experience has been like here at the DARPA Lift Challenge.
Yeah, Air Migos is a team of me and 2 of my buddies. We've been working together for 12 years now, designing, building, flying drones. We do it all. We decided to take this on. We're very competitive. We've done a lot of drone competitions and won them before. So this really fit into our wheelhouse. We built everything from 1 ounce to 3,600 pounds of eVTOLs. So this, we thought we could do very well here. We thrive on competitions and hard work. The tough part is we did it part-time. This was not our full-time job. We still had a day job. We self-funded everything, so it really demanded a lot of us, and the experience here was good. We wanted to come out and just push as hard as we can and just keep solving problems and building and flying as much as we could.
How has this competition been different than some of the other ones you've been to?
This pushes performance so much harder. I mean, you can tell that from the way they framed it, as this would be a historically high weight payload to weight ratio, 4-1. It's really never been done before. So the other competitions, they push performance in their own way, but nothing like this. This has to be, every part of the vehicle has to be pretty much perfect to get 4-1. We were actually aiming for 5-1. We think we could have gotten there.
Wow.
You just mentioned teams, if they were still flying today and they already hit 4-1, they would have tried for 5-1, and that's exactly what we were going for.
Yeah, everybody wants to go as far as they can go.
That's right, yeah.
You guys you say you're a self-funded team of 3 garage inventors.
Yeah.
And now you find yourself here in Dayton in the middle of Air Museum Field. What has been the drive? How did you get into this competition from the get-go?
Yeah, well, we saw the challenge put out there, and we thought we have a solid chance of competing and doing really well. So we designed our drone, like I said, for 5-1. And in test flights, we had, you mentioned garage inventors.
Yes.
So we took that to its absolute limit. The day before travel, flying empty, we had a control issue and damaged the aircraft. And Donna in the last segment talked about epoxy curing or glue curing.
Right.
So we repaired it and put it in the trailer, and glue was curing on the drive here to Dayton. And we got it ready, and we did our flight on Monday. We did the check flight. But then on Tuesday, I guess our repair wasn't good enough. We flew at 4-1 off field, 4.1 to 1. It was flying with 115 pounds of payload at a nearby AMA field, and I'm very thankful that there is an AMA field nearby. And then I guess our repair wasn't good enough, and it was damaged one more time. Again, we worked in our garage, in our Airbnb, so garage inventors, right? We drove to Cleveland. We got parts, as many as we could. We glued it all together, and we flew yesterday. We were rearing to go. That would have taken us down to 3.7 because it was a little bit heavier.
Would have put you in second place.
It hurts to say that. Wow. But yesterday morning we flew again 115 pounds, actually 117 if you include the tracker, at that AMA field. And but I couldn't get the props I wanted, so we had to rejigger our battery. Garage inventor. Rejigger our batteries, rejigger the props, basically a completely new airframe. I didn't even design it in CAD. Didn't have time for that. I drew it on a piece of paper, made the jigs with 2x4s and a hole saw, a laser level. I mean, really garage inventor to the nth degree. We rebuilt it, it flew, but we were really pressing to get here in time, so we pushed it a little too fast, a little too hard, and again, we got bit, so we were pushing really hard to get here, and we could have done really well. We were really close, but Garage Inventor to the max.
So tomorrow morning, what's going to be your takeaway from your experience of the DARPA Lift Challenge?
My takeaway is that we accomplished what we set out to do at the vehicle design and execution level, but on the flight test part, we just didn't have quite enough time, as much time as we should have, to refine and fly and actually show off what we can do here. All those 4-to-1 flights that we did, it would have been nice to post those on the scoreboard.
Yeah.
But we got really close. We know from a project management thing and some flight test things are things we can do better. But we've grown from it. We've learned a lot, and we're just happy to come out here and compete.
It's easy to sit there an armchair quarterback and say, well, these guys are out there, they're having problems with their control link, et cetera, et cetera, et cetera. I could have done better. I could have done it. What do you say to the people who might be in that position?
Well, come out and do it. If you really wanted to do it, the challenge was open to everybody. There were 500 teams that entered, and as Donna said, the field narrowed further and further.
Yeah.
It's easy to armchair quarterback. It was open for everybody.
I think people don't understand just how many problems you guys already solved just to get here.
Yeah.
And you get out there, and you have what seems like a very simple problem. A prop wasn't tight, or an ESC broke, and they're like,
right.
Why didn't they plan for that? But nobody sees the work you put in the weeks and months leading up to this just to get here and get off the pad.
Yeah, so why didn't you plan for that? You're working in a really compressed timeline, and like I said, for us, even doing it after work and on the weekends,
right.
There were a lot of sleepless nights, as you guys can imagine. So we do plan for that, but you're working fast and you're trying to be as careful as you can. But it was really tough for a lot of teams here, as you can see. So we're just everyone's doing the best that they can.
Well, everybody who got here and everybody especially who got off the ground deserves a big congratulations.
Well, thank you
guys.
Yeah, I appreciate that.
We're visiting with Tom Newman from Air Migos, the squad out of Fairfax, Virginia. We'll get you out of here on this. What is the future for you, and what is the future of you and your involvement in drones?
Yeah, great question. So for a living, I build drones. I design, build, fly airplanes all the time. And we are, in my full-time job, we're actually spinning out into our own independent company, and we're going to design, build, and fly not big, lumbering, heavy lifters, but a drone that can take off vertically, then move AEDs across the country at 3 miles a minute, 180 miles an hour.
Heck yeah.
That's our goal. So it's going to be a new company, emergent aircraft company. So we're taking this entrepreneurial momentum and moving it forward into a new company.
Tom, thank you much for the time. We appreciate it.
Safe
travels back to Fairfax for Air Migos, and we wish them the very best. Hopefully we'll hearing more about you.
Thanks for having me on. I really appreciate it.
Indeed. Tom Newman, thank you again. Go back to the competition. There you see the current leaders overall. Aviadrone, this looks like a test flight, not a scoring run. So the leaders out there just running through things, kind of like warming up. I guess, JB, this is kind of like if you're a world-class sprinter, maybe going for a little quick jog around the track.
I don't know if anybody here feels like they're taking a quick jog around the track. I think these guys are out of breath, they're panting, they're sweating, and they are not giving up.
So we'll see what they decide to do when they bring it back in. Remember, the window is 90 minutes. Now there is some discretion coming from the boss, and that is ambush in the command post. If there's an incident, if there's some data that's gone down, if they've lost power, things of that nature, if there's a fire in the next lane, these are all things that have actually happened. They can give you extra time. But roughly plan on 90 minutes to accomplish your task, which is 4-to-1 payload to weight ratio. Travel 4 nautical miles, bring it back in, drop the weight off, controlled, go back up. Can't make adjustments on the craft or add fuel. Do another nautical mile, bring it in, do it all with under 30 minutes. And you could be looking at a serious payday. I know Joshua Bardwell calls it walking around money, but $2.5 million if you can get that done.
Yeah, actually, I think what's happening here is that they are doing some warm-up flights to get their drive belt. Remember, this is the team that had the issue with their tail rotor and drop their weights, and they're doing some warm-up flights to get their drive belt sort of seated in, broken in, if you will, before they go for their full competition flight.
Just a thing of beauty watching them come in, just how smooth that is, and then they set it down dead center in the perfect. So, Aviadrone, they've been up, worked out the kinks maybe, got it up and running, warmed up the joints. We will see if they make history and go 4-to-1 payload to weight ratio and put themselves in position to claim $2.5 million. This is Burl Aeronautics. This is their Alpha drone. They have 2. One of the cooler designs. I mean, I look at that, JB, and it just looks like a stealth wing out of White House, New Jersey.
Reminds me of the SR-71 Blackbird. Yeah. I don't know if it's designed to have any stealth characteristics, but it sure is aerodynamic. It's very interesting how the most aerodynamic designs mimic nature, almost as if the birds and the fishes figured out how to move through a fluid in the best way possible, and we're just trying to chase them.
Now, an opposite look of this stealth look is Stanford Online High School. Now, a lot of people have bagged on them. I think it's kind of cool. It's been called Santa's sleigh inverted. It's been called a lot of other things. They might be the most tenacious group here. We've seen them crash, put it back up. We've seen them flip it twice. They just keep coming back.
Yeah, very tenacious. Nobody giving up. I don't think I've ever seen a bird or a fish that looks like this, though.
Go over to lane 3. This is Aptos Aero.
Yeah, these guys have been struggling with issues with their motors. So they've got liquid fuel motors, and liquid fuel motors, as we've discussed, like to run at a constant RPM. And because those two blades are counter-rotating, they need to spin at the same RPM or they'll become imbalanced. And they are struggling with getting those motors to run at a consistent RPM.
If I've learned anything from you this week, imbalance not good.
Imbalance not good. No, that's true.
And then we have Skyweaver, another innovative design. These are the folks from Menlo Park, California, in the Bay Area. These are 2 fixed wing aircraft, I should say, connected by a tether with the weight in the middle.
Yeah, we've seen them struggling just getting into the air. The aircraft start to go, they sort of bounce up and down, they become imbalanced and flip over or crash. You can see that they have used basically off-the-shelf RC radio control aircraft as opposed to making something custom. Which certainly saved them a lot of time in the design process, but they may be struggling with getting that to work with their unique steel-tethered rotating system. I hope they get in the air this time.
Let's head over to lane 7. This is SciLift, the team out of Ames, Iowa, and Iowa State University's Department of Aerospace Engineering, composed primarily of undergraduate aerospace engineering students. So the undergrads get in on the act. Here's my question. If SciLift was to win, do they have to share the money with the university or do they get to keep it?
Oh, I don't know what kind of arrangement they might have.
I better be getting tuition for life.
I guarantee you the minute somebody wins a prize, the phone's going to start ringing. Hey, remember that time?
Remember that time I loaned you 20 bucks?
I had somebody, as I was walking through the hangars, he said, "Hey, Joshua Bardwell, I wouldn't be here if it wasn't for you. You taught me everything I know about drones." And I said, "So I get a chunk of the prize money, right?"
Exactly. SciLift folks have their mascot mounted on top. Also, one of our fan favorites, M-Tech, out of Sudbury, Mass. They are out on the line.
Oh, is he doing the compass
calibration dance?
Now you know what that looks like, Todd. He is calibrating his compass. You hold the aircraft and you rotate it in circles, and that lets the onboard compass cancel out the magnetic field of the aircraft itself. And
it's a soft reset. Not a move on Dance Dance Revolution, but he's going to go out there from Sudbury, Mass. and get this done. Founded by MIT engineers and entrepreneurs. You had me at MIT. This is Avidrone. They're in lane 13 for those of you counting at home, and there you see they've got it. Final preparation. It's a cool design. I mean, it looks just like a helicopter, but it is a cool design, and now we're going to put some weight on here. Right next to them is Vertsolve. That's the team from Phoenix, Arizona. We had Kevin Horn on the set yesterday with us. He seemed pretty confident in their skills. He made us we're going for it promise.
Yeah, well, everybody's going for it. They may as well, because after this, it is all over.
Yeah, no flight windows on Monday.
No, sir. No,
so we will see what they can do here on Super Sunday. Burl is still up in the air.
Yeah, Burl is dangling that weight. Well, there's no weight on him right now. That is just the Titan tracker. Dangles it below them. We still do not know why they've elected to let it hang so far below the aircraft. Disadvantages of that, number one, is that it's going to swing around and it's going to create instability that the aircraft will have to counteract. And number two, if it swings outside of the geofenced area, they will be disqualified.
Stanford Online High School is up and hovering. and now back to the Earth. Go back to Burl for just a moment if we can, and I want to confirm that I heard what I heard in that Donna told us that the weight below can go below the 100.
Yeah.
As long as the craft stays above the 100.
I don't
or the
know.
Titan.
I would have to check that. I mean, you would think that the Titan tracker is the thing that
stays.
tells them where the aircraft is. So I think that it would be safer for the aircraft to go above the 200-foot marker.
Rather than...
Right, because he did say they had some headroom on their altitude requirements.
Okay.
So the Titan tracker would be below 200 feet, and the aircraft might be at 300 feet, but that would still be okay.
See what happens when Donna leaves us? Questions just come out of the woodwork.
Now, we're seeing this aircraft hover in its VTOL mode, but once it gets in the air, it actually begins to spin and becomes one gigantic rotor blade. And I think, you just distilled a rotorcraft down to its essence. It's just the rotor.
Okay, so they are down on the ground. Let's check in down on the flight line with Elena Buenrostro.
Hey, so I got the chance to talk with Team MTech, and it's been a long week for them. They rebuilt their drone last night. Two key differences is that they have new metal mounts, they weren't metal before, and new engines, which are actually smaller motors than the drone they had yesterday. So overall, they're feeling really proud, but curious to see how everything nets out with these changes in their aircraft. Back to you, Todd.
All right, thank you, Elena. Before we let you go, give us a sense of what it's been like to be down there. I know the first couple of days you were not able to be on the flight line. Now you are. Are the teams pretty receptive to having you around? Are they willing to talk, or is it kind of just crazy, leave us alone?
Yeah, I think it's a little bit of both. Some are really excited to talk and share the new updates, especially this morning or just now talking with MTech and the team and even their dad, who's just talking about the newest additions to their aircraft right now. And then some are just super focused and don't really have the time or the energy to talk because they want to make sure that they're getting everything they need and all the details ready for their next flight.
All right. Thank you so much, Elena. They are currently in second place with a payload-to-weight ratio of 3.64, and they are spinning.
And this will not be the first accolade for this team. Luke Bell and his father hold multiple drone world speed records. Basically, they set a world speed record, somebody breaks it, they just come back and they break it again. And I think they've done that like 3 times by now.
Talk about little people that want to meet you. Joshua Bardwell, who do you want to meet?
I want to meet Luke Bell.
Okay.
I mean, I've been thrilled to meet all the people here, but I've always been curious to get to know how you break drone world speed record.
Other than Elena, who's been your favorite person to meet this week?
It's been great. It's been great meeting all the teams. Okay. Donna definitely has been a highlight. I think he's coming for my job as a YouTube star if he ever decides that's where he wants to put his effort. Just a wealth of knowledge and a passion for communication and education.
So MTech comes in, took it out for a little bit of a spin, set it down, no problem with the landing. Look how quickly. How come their rotors shut down so fast?
So those brushless motors, when you stop driving them, you can have what's called a braking mode, B-R-A-K-E, like it brakes on your car, and it can cause them to stop abruptly. That is something that can sort of be configured on the electronic speed controller that drives the motor. The most common reason that you would use that is that some gliders, they have a folding propeller so that the propeller doesn't drag, and the motor will stop and it'll fold up.
You're looking at VertSolve out of Phoenix, Arizona, and Kevin Horn, former United States Air Force officer. Thank you for your service, and the primary designer of the aircraft. Beyond DLC, they are excited to continue development of the aircraft for defense and civil uses in the United States. And again, we had Kevin Horn on the set with us yesterday. It's a cool design. It was the whole jet thing, and the thing kind of blew my mind is he built that all by hand.
Yeah.
The engine completely by hand. It's a one-off.
Yeah, it's interesting. He's got that down to a much smaller size than other hybrid electric systems, and now he's out here just to prove that it can do what he claims it can do.
Here's a dumb question, and I'm full of many of them. Is there a world on a day like today where you could basically harness the sun and have a solar power system that could run these things?
The big challenge with solar-powered craft is that you need a lot of square meters or square inches of solar panels to generate power. that creates size and it creates weight.
Okay.
There have been some creations of solar-powered aircraft that could basically fly indefinitely. They harness energy during the day, and they use batteries to fly during the night, but they are extremely lightweight, extremely fragile, and they basically carry no payload at all. But it is something people are exploring.
And I'm imagining the solar panels are a little more expensive than the lithium batteries they might be using.
Well, they've got lithium batteries on there to hold the energy. The solar panels, of course, charge the batteries, and then the batteries run the motors.
But those solar panels are spendy.
Yeah.
That could be a next piece of content for you on your YouTube channel. What stupid questions does Todd have for me?
You know, I like to say that the quote-unquote stupid questions are my favorite because, you ask me a hard question, I don't know the answer, then I look dumb. But you ask me an easy question, and I get to pontificate and sound smart, and then you build a whole career around that.
There you go.
And then here you are at the Drone Lift Challenge. Todd, you might say you're going to learn something today.
Absolutely, you're going to learn something today. It's us against the drones. Here we go. It's Joshua Bardwell as we take a look, as we've got a packed 11 a.m. flight window here in Dayton. This is Vertsolf still in the air. A little bit of weight on there, but obviously not the 4-to-1 payload to weight ratio. Avidrone is still leaders in the clubhouse, and they are also in this flight window. Still tinkering just a little bit. I had a lot of questions, people firing things off to me on social saying, why did they get out to the flight line and then start tinkering? Wouldn't they have done that before they got to the flight line?
Well, it just depends on the nature of the tinkering. There may be some final little adjustments they need to make. There may have been something they learned from the previous test flight. For example, we said they had issues with their tail rotor. The belt was skipping. This was the previous day. They dropped the weight, and they came in. They've got a new belt and a new mechanism that they think is stronger. Now they're trying to break that belt in. Maybe the belt's stretched a little bit, and they're retensioning it, for example, and they're waiting until it reaches a state where they're ready to go for that final 4-to-1 payload to weight ratio.
So as a drone expert, how hard is that last 0.16? Because if I tell someone at home, 0.16 is all they need to do, bump in to get 2.5 million people, 0.16, that's nothing.
I mean, I think there were a lot of good questions before this event of how hard or easy that was going to be. There were people who said it was impossible to even get to 3-to-1, and there were people who said, well, this is too easy, we could do 20-to-1. And I think what we've proven here today is that 4-to-1 ratio is very difficult. If these guys could just slap a little more weight on, put it up in the air and do it, they would have done it by now. And we've seen multiple failed attempts.
So will Avidrone be able to do a 4-to-1 payload to weight ratio within the 90-minute flight window? Can tell you they've already ticked off about 22, 23 minutes, so it is coming down a little bit, but still plenty of time to get up in the air, maybe do a test, come back down, adjust, and then go up for the full flight. Most of the teams are taking anywhere between 18 and 24 minutes to get a scoring run in, and again, that's 4 nautical miles with weight, then drop the weight off. Another nautical mile, and you have to bring it in and land it on the landing pad. So a lot to consider, a lot to obviously check everything, and every time we see someone that does crash or has an incident, we all say, gosh, could they had a couple more minutes to tighten down one more screw or done one more little thing. That's what they're doing.
Yeah, they're making sure everything is right and everything's ready to go. Todd, it's important to keep in mind that, these crashes, these quote-unquote failures, that's just part of it, right? You want to learn how to do something that's never been done before, you're going to try. If you could have done it the first try, somebody would have already done it. And so every single one of these failures is an opportunity to look at what didn't go right and how can we make it go right the next time.
Well, as they say, if it was easy, everyone would be doing it. Here are some of the attempts yesterday at the 4-to-1 or above as they were pushing the limit on Saturday, day 6. This was Avidrone yesterday going for a 4.02. That is a rapid descent.
Yeah, the tail rotor there stopped working. We got an out-of-control yaw, and then in the crash, the battery lit on fire. Woof.
Another rapid descent.
Yep, 4.0 to 1. Payload to weight ratio. The
just missed the 4th of July by about a month. And this was Defentex. They went for 6.11. This was really swinging for the fences.
Yeah, Defentex has no choice because the minimum weight here is 110 pounds. They brought an extremely light aircraft of only 12 pounds, and so they can't go any lower.
As opposed to the Stanford Online High School Santa Sleigh. Meanwhile, Burrell Aeronautics, that's just a cool design. I don't know why that just doesn't look like. Let's see, we got to pull out and see what they have on their cable, because that's how they handle their payload. So the team out of White House Station, New Jersey.
See if we have that Titan tracker down there, or maybe we have any weight. Again, these teams are required to do an unloaded check flight to demonstrate that their aircraft is controllable and can stay within the geofenced area. Then they do a half-weight check flight, and then they do a full-weight check flight, and they're cleared to go for actual competition runs. So Burl Aero may be doing test flights or maybe just doing their safety checks. We do not know exactly what they're doing.
And there is the Titan tracker?
Mm-hmm. That's right. That's the Titan tracker that tells the system where the aircraft is, how fast it's going, how high it is, and makes sure, number one, that they're staying within the safe area, and number two, that everything is scored correctly. Now they've begun rotating. Yeah, the rotating is normal. That is how they are going to fly it. It's much more efficient to have a very large rotor. The energy required to keep your RPM up increases as the square of the size of the rotor. So bigger rotors are more than proportionally efficient. And so they take off with those very small propellers in a very inefficient flight mode, and then but they can go straight up. You can imagine if you were in a tree line or something, you wouldn't want that big thing swinging around.
How do they determine the length of that cable? I mean, is that something they've engineered, or is it just, I mean, it can't be just a random number.
No, nothing about this is accidental. It sure seems to me like a shorter one would be better. Maybe their goal, every time I say that, then my brain kicks something out. What if the goal is to begin rotating and then transition to forward flight, and you don't want that thing pulling on you when you're rotating?
True.
Perhaps?
Yeah, that would make sense.
I sure hope they're coming down in control. That transition from rotating to not rotating and vice versa, that's always precarious. Anytime you're transitioning flight regimes, I'm in VTOL flight, now I'm rotating. I'm in vertical flight, now I'm going to horizontal flight. That is always very precarious for the flight controller, the little computer that makes these aircraft stable. You can see there, it looks like a giant wing, but it's not doing anything really aerodynamically. Without that computer, this thing would just tumble out of the sky.
I know I have a reputation for delivering the weather each day, and I'm going to be your Al Roker Sunday here as I tell you that it has got to be some of the best flying conditions we've had all week, JB, because the temperatures aren't as warm. Obviously, the day it hasn't heated up, the humidity's not as high, and there's not as much wind as we've seen the last 2 or 3 days.
No, it's a good day, and considering it's the last day, you know, I guess Mother Nature's doing these guys a little bit of a favor.
All right, JB, so we're going to put your big brain to the test and give us your assessment of the most aerodynamic designs.
Oh.
And what do you like? We got some video support for you.
Yeah, let's take a look at some of these. These are superlative categories.
This is Driftless, who joined us on the set yesterday.
All right. Okay, well, what's more aerodynamic than a rotor, right? There's nothing about it that isn't aerodynamic, right? The rotor blades are going through the air, they're spinning, and what I like about this one is, like, we see all these experimental designs, and sometimes there's a little bit of struggle to keep them controllable, but it's very controllable.
UMD, a lot of surface area.
Yeah, now these, it's going to take off vertically, and then transition to forward flight with that pivoting blade, and a little bit more mechanically complex, but also getting the job done. Very aerodynamic.
And here we go, my friends at Stanford Online High School.
Very interesting with the stacked airfoil design. If one airfoil is aerodynamic, then surely a bunch of airfoils is even more aerodynamic. Maybe they were going for this superlative when they designed this craft.
Love to see them get up and get to elevation and do it down and back, and they continue. They're like bad luggage. You can't get rid of them. They just keep coming back, and they kept coming back, making some adjustments, making changes, and they just they take the entire 90-minute plus window.
Yeah, just trying to get that thing to hover, and you know they're going to take this back home, and they're going to keep working on it. You know?
That Santa sleigh could be worth $500,000 if they are deemed the most. What was it? The design,
most
aerodynamic design.
That's right. That's right. You know, everybody comes here, and the goal, of course, is to find something that can increase that payload to weight ratio. But the goal is also, I like to say, just shake the tree and see what falls out. Sometimes good ideas are out there.
But when you think of aerodynamic, obviously you think, you know, maybe thin, slender. It's like putting me next to Ariana Grande. Not aerodynamic, but that you're talking about the foils and the slats, because once it does achieve altitude, it uses that all that surface area to lift.
Every single one of those slats is a little miniature airfoil, and it's called a stacked airfoil design. And the idea is that if you have one big airfoil, you get a certain amount of airflow over that wing. But then if you sort of split it into a bunch of vanes, looks like Venetian blinds, each of them will produce more lift than the sum of the parts.
So VertSolve has done a 4 nautical mile check, but again, their ratio is just 1.31. That is payload to weight, so this is more of a test than anything else. We did have Kevin Horn on the set with us yesterday. He did say they would be going for a 4-to-1 opportunity.
Yeah. We are about a half hour into this flight window, so they still have plenty of time.
Yep.
We're seeing those runs take anywhere from, say, 18 to 22, 24 minutes. But eventually they will run out of time because they need to be back on the ground and finish their run before the flight window closes.
So they're at 1.31. It's going to be a big bump up to 4. And I've asked you this before, but for those folks who might be just joining us for Super Sunday here at the DARPA Lift Challenge, how much of a difference is going to feel driving that with
Massive.
a 4-to-1 as opposed to 1-3?
Yeah, think about you're driving a car or driving a truck, and you're driving it, then you put a trailer on the back, big, heavy trailer. And suddenly it's much slower to accelerate. You're pushing on the gas pedal. It's much slower to brake. You got to get on the brakes way earlier. And just the whole dynamics of the vehicle change, right? Going around turns, you got to be more careful. The pilot will have to adjust. The remote pilot in command will have to adjust to that. That's what they call them. And of course, they're very skilled at that.
VertSolve having some issues getting on the platform, so they're just going to shut it down. Now, had that been an actual scoring run, that run would have been DQ'd because they did not land on the platform.
They need to land within that 5-foot radius circle that's inscribed. That's a 10-foot square. That plywood platform with a 5-foot radius circle, 10-foot diameter. In front of it, they need center of the weight plate is what they use to determine the aircraft's landing location. So it is outside of that.
You got to think that everything green out there is bubbling lava, and if you land in that,
the floor is lava. The floor is lava.
Exactly.
Now, if they could have gotten back up in the air and repositioned, they can do that. But in this case, perhaps since they knew it wasn't like a full scoring run, it was a lower payload to weight ratio. Perhaps they just decided, hey, we're going to end the run. We're going to reset and do it again.
I want to put you in the minds of some of these teams that are still here. How many of them do you think say, okay, 4-to-1, we don't have the design, we don't have the time, the R&D to get that done, but 3.4, 3.5, that gets us in the money. Let's go for that.
I mean, I'm sure there's a tension between wanting to swing for the fences and try to do something spectacular even if you fail. And you say, well, at least I tried. And then being a little more sort of tactical about it and say, maybe I could get second place. Even the third place prize of $1 million or $500,000 if you don't hit the 4-to-1 payload to weight ratio, even that is life-changing money. And let's not forget that these teams have a huge amount of time and money invested in these projects.
So very busy flight line here on the final day of the DARPA Lift Challenge. You're looking at the 11 o'clock flight window. This is scheduled to go until 12:30 Eastern Time. Once that concludes and it has been shut down, then there'll be a little bit of a longer break for teams to get some lunch, hydrate, for the fans to get positioned for the absolute final flight window, which will start at 2 o'clock Eastern and run until approximately 3:30, and then the DARPA Lift Challenge will come to a conclusion. And someone is going to walk away with a big check.
Absolutely.
Actually, 6 people are going to walk away with some big checks.
Yeah, that's true. Those 3 first, second, and third prize, and then the 3 superlatives for whoever gets selected.
It's a good thing they don't give you and I big checks like that to go off, because we would.
Well, if I did something as historically groundbreaking as a 4-to-1 or even a 2-to-1 payload to weight ratio, I would deserve that check. I just show up and talk.
True. But you do a great job at that, and I appreciate all your insight. You, as well as Donna, Lieutenant Colonel Philip Smith, call sign Donna, a reserve from the Marines, Harrier jet. He has been fantastic. He has given us the insights. He's shared probably more than he initially was planning to share with us, but it was great to have his insight, and then the teams that have joined us on the set as well. We really appreciate it.
Yeah, it's been great to get a look, not just from the team's perspectives. The teams are always willing to talk to you. It's been great to get a look behind the scenes at how the event was planned and organized and run from Donna. I think a lot of people, just this whole DARPA project is just a big black box. It's been great for Donna to open that up for us.
Yeah, and some of Donna's bosses even popping by to give us a little bit of a boost. And it's always helpful to have someone come in and give their perspective on what the goal is. I think it was always amazing as we continued to look on the flight line. Oh, there's a team up, MTech's up in the air, to how fast this came together. I mean, this is a highly technical competition. And to think this came together in under a year.
Yeah,
here it is.
That accelerated timeline, that's a feature, not a bug. I can't tell you how many times I've had a deadline. This project is due in 6 months, and it's 4 months later. I haven't even started yet. But you tell me it's due tomorrow, and I'm going to pull an all-nighter. The idea here is to light a fire and get these people to try to do something even if they don't succeed, just the attempt produces valuable data, valuable information, and pushes our capabilities forward.
So that is MTech, and they have put it down on the landing pad. So that was a relatively successful test run for them, the team from Sudbury, Mass. Again, they are the ones that is founded by the MIT engineers and entrepreneurs. They've got a lot of experience in this, so we'll see if they can translate that experience into a winning run. So you see the battery change there.
Yep.
Got the leaf blower.
We heard about that leaf
Yes,
blower.
the leaf blower.
Trying to keep everything cool. Things were overheating. ESCs and motors perform worse when they get hot, and then in extreme cases, basically heat is always what kills an electric motor. Theoretically, you can wear the bearings out, but the bearings are usually pretty durable. What happens is that the electrical energy being pushed through the motor to make it spin reaches a point where the motor just basically melts itself, and then you see that white smoke come out and the aircraft falls out of the sky. So by keeping them cool, they're not only increasing the efficiency, but also just increasing the chances that they finish a flight without falling out of the air.
Different than a car battery, because I've always understood that a car battery performs worse in storage status in cold.
Yeah, so the lithium batteries that we've got will perform better in the heat to a point. So the motors and ESCs don't like to be hot. The batteries tend to get better as they heat up. And what you'll actually see if it's a cold battery when you start flying, as the battery heats up and warms up from use, it will actually improve in performance.
Okay.
Obviously, there's a limit to that. Eventually, it heats up enough that it lights on fire.
Jonathan Bardwell providing knowledge for life as we continue to wait and see as we come up on, what are we at now, JB? We're at 10:30. Oh, we're 40 minutes in.
Yep, just about.
So not even halfway through this flight window, the penultimate flight window of the competition. I do kind of like the fact that they are slow and steady.
Slow and steady.
Donna talked about that. Slow and steady wins the race. This is not a Formula One NASCAR pit stop situation.
No, and a Formula NASCAR pit stop, they are precisely rehearsed. They're going to do the exact same thing every time, and they've done it hundreds, thousands of times. Think about it this way. If you call 911, do you want to see the EMTs panicking and running your way? Or do you want to see them get out of the ambulance like it's just another day? Right?
I kind of like not to call 911
well,
first of all, but if I have to, okay.
My point is, when you've got something important to do, you want to do it smoothly. You want to take the time. It's just another day at work. We're going to do something extraordinary, but we're not going to rush. We're not going to get panicked, and we're not going to make any mistakes.
Wasn't it the great John Wooden that said, "Play fast, but don't hurry"?
That's
and I think that's kind of
great quote.
A similar theory is play fast, but don't hurry.
I haven't heard that, but that's a fantastic quote.
So we got another Dance Dance Revolution in lane 7. This is Silift doing the GPS walk.
Yep, calibrating that compass and GPS unit on that drone. And this suggests one of two things. Either they had to change out their GPS unit and you have to recalibrate the new compass, or it might suggest that something about the aircraft has changed. So remember, we're calibrating for the electromagnetic characteristics of the aircraft frame and its wiring and so forth. And so if you move your battery, if you change something about your frame, you might need to recalibrate that.
Sherman Aeronautics.
That's that father and son team with the two aircraft that fly in a circle tethered by a steel cable. We've seen them get in the air multiple times. We've seen them carry a little bit of weight. We haven't seen them make any competition runs, though.
So Sherman Aeronautics going through pre-flight checks with their two fixed-wing aircraft. We'll see if they get up. This is something you definitely do not want to miss. You want to see that as it continues on, as we are coming up on the halfway point of the 11 o'clock Eastern flight window. Remember, there's one more flight window that comes up at 2 o'clock here at the DARPA Lift Challenge in Dayton, Ohio. We are at the National Museum of the United States Air Force. Our thanks to them as they are kind enough to lend their beautiful facility to us and let this competition go on. Another guest joining us, and he is an important one, Dr. Aaron Lazarus, the director of DARPA's Tactical Technology Office. That is the TTO. Dr. Lazarus, thank you so much for being here. We appreciate it. What's your best takeaway so far since you've been here? Because you've been here all week.
It's just been incredibly exciting. I mean, the amount of energy you get in these competitions is, I mean, it just pumps you up. We've got a whole bunch of our team here, so I am sure the ideas that are going to come from back to the office with is going to be really, really exciting. So I think the greatest thing is the adrenaline that you get from coming to these challenge events.
You know, we've heard about how the program managers will pitch these, and they've got to sort of convince DARPA to accept the project. What made you press the I believe button for this one?
So, you know, a lot of the I believe piece comes from the passion that the program manager brings to the table. And so you guys have been watching Donna this week, right? And you can see he does not like passion when it comes to vertical lift
does
aviation.
not stay still.
Yeah. So so it's really obviously that's a big part of it, the passion that Donna brings to it. But obviously we did a lot of very thoughtful analysis when it came to this challenge. There was a lot of work and background work that came into it, and the key piece to it is because you're really deciding whether DARPA wants to do a more traditional DARPA program or whether we want to do a challenge. And the real thing comes back to the ecosystem that's going to execute on it. Who's going to do the work? And when it comes to this community, that's the thing that I highlighted. There's lots of commercial opportunity in this space, and there's lots of innovators, right, from the commercial side that could bring a lot of unique ideas. And there's a whole slew of performers that are not traditional DARPA performers that could come in and really add a lot of value. And so that's why we went after a challenge at tackling this problem versus the traditional DARPA program.
That's a huge understatement. You could throw a stick out here and you hit 100,000 innovators. We got innovators all over the place out here. I got to ask you, what do you think the greatest value is coming out of this challenge? When you get home Monday and you start to reflect on what took place over the last 7 days, what's the greatest value for you in DARPA?
So I think you can look at the value from this project, and it's sort of divided into two categories, right? The first category is sort of the hard value, and I look at the hard value being the actual technology themselves, right? So there's a whole slew of from the sort of traditional platforms. When you look at the helicopters or the sort of quads or hexapods, that sort of traditional technology or component technologies that's improving their relative performance. And then you've got the technology when you talk about the innovative control systems that are being developed for a lot of these more radical designs. But there are a lot of soft benefits that come as well. So we're tapping a whole new ecosystem, right? There's a whole new set of performers that are now, they know about DARPA, they know how to interact with DARPA. And one really unique thing is a number of DARPA program managers have come from the actual performers. We've got a team from high school. I'm eager to see where they end up in college. We could be looking at the next generation of TTO program managers.
Look at this. This is Avidrone as they go up. It is green on the top right, so this will be an official scoring run, folks. And this could be history being made right now. They are the current leaders in the clubhouse, and they have a ratio of 4.05. That's payload to weight ratio, and they are up and moving.
Yeah, they are climbing to that 100-foot altitude. They'll need to do that within the first half mile, and we've seen them succeed at several runs. Oh, the tail rotor again.
Oh, my.
They struggled with the tail rotor. The tail rotor was slipping. They said they were going to redo the belt. They were going to make it stronger, and they were going to go for it. And it seems like that repair was insufficient to the task.
Okay.
I don't want to claim that as an announcer jinx, but I was pretty amped up to see this thing happen. It didn't go the way they wanted to, but again, as we say, Dr. Lazarus, sometimes progress is painful.
Yeah, I mean, that's a traditional design, and we recognized 4, right, was really a limit for traditional systems. But you got to admire that team, the innovation they put in the design and development of that platform. But you are going to the bleeding edge of what's physically possible, and it's really exciting that they're not afraid, they're not backing down. They're moving forward, and that's the passion and the innovation we like bringing.
Hey, the good news is they're still in first place.
Yeah.
They're still in first place, so you're saying there's a chance.
We really want somebody to take home all the money. We want somebody to get 4, so we're rooting for them.
So let's look at this one more time, and I'll let you and Joshua break this down. Joshua, where did you see the problem?
Well, the problem, of course, is that the tail rotor fails and the aircraft spins out of control from the counter torque of the main rotor. This is the exact problem they ran into yesterday during their 4-to-1 payload to weight ratio run. They told me this morning that they had strengthened the system and were ready to go, and presumably they did, but we just see it wasn't enough. And he said to me, you'd think it would be easy, but we're just hitting the ceiling, and we just keep hitting the ceiling. Hopefully somebody will break through that ceiling, but it seems like it's a very real one.
Like Dr. Lazarus just said, they are on the absolute very edge, and there is the personification of what it is on the absolute very edge as they take it down. A bit of a heavy landing there. So the leaders are down, and it looks like they may be done for the day, unable to go retrieve that, obviously, during the flight window being open, and this is their last opportunity, and this is where it went south. Okay, so the question is, next one up, right? I mean, next man up, next one up, and Donna's out there. This is why he bailed on us and sent his boss over here to fill in for him.
Hey, the team and the passion they bring, that's really, really exciting. And the fact that they're going to keep. So
can we say, and this is a tip of the cap to you and your entire staff, the Orange Army, as I like to call them, they have done a fantastic job. Despite the rain on one day, the thunder and lightning, the shelter in place, the hot weather, the humidity, everyone happy, smiling, and just rolls on.
I mean, it's. I can't tell you how thrilled I am about the team that's performing here. They're doing amazing. Obviously, you guys have had an opportunity to talk to my boss, the director of DARPA.
Yeah.
And, I mean, the passion he's bringing to the agency and the energy, I mean, it's amazing.
Dr. Aaron Lazarus, thank you so much for your time. Appreciate you making this happen, and let's greenlight some other projects. This has been a lot of fun.
Absolutely.
Thank you again. So Avidrone is down. We saw them just take a fall. Unfortunately, it looks like their day could be done as they only have that one flight window, the 11 o'clock. Remember, there's another one coming up at 2 o'clock, and we look forward to seeing that. It's nice having all these smart people around us, JB, because ask them all the questions that we didn't know, and then they come out and say, oh, this is what exactly that means, and it makes it sound so easy. So Avidrone now will sit and wait. They will wait through the rest of this window and then the 2 o'clock window, but they are still on top of the leaderboard, and that's the most important thing. As Dr. Lazarus just mentioned, they are on the absolute edge. I mean, we are talking the absolute edge of what is possible. They are at 3.84. They were going for 4.02, or was it 4.07? 4.05, split the difference. Had they made that, but man, it looked so good until it didn't.
Why not go 4.01? Like, all they have to do is crack 4.0.
Yeah.
And the answer to that is that there are only sort of discrete increments that they can add weight. They're adding those individual weight plates. I've seen weight plates as low as 2.5 pounds, but their mounting system for the weights may not be designed for that. So surely.
Can't come up with just random weights. I mean, we can't run out there with a can of tuna and say, here you go, split the difference and strap that thing on. They are all the weights. And as you pointed out, the Dayton area will be inheriting quite a few weight plates come Monday.
Yeah.
Here we go, Stanford Online.
Oh, this is higher than I have seen them go so far. In the past, they've been struggling to take off, struggling to stabilize their craft, and it is in the air, and it is flying. This is a big moment for me as a fan of this team.
This is where you think their technology and their design is really going to pay off.
Oh, yeah. I would love to see them get into forward flight. So as they transition into forward flight, those vanes will start to act like airfoils and generate lift, and just proving that concept would be really valuable for this team of kids.
This is the highest we've seen them so far as they are approaching 90 feet.
Oh, a little dip there, dip there. Come on, hold it together, guys. I don't want to see this craft come down.
Do you worry about range of signal? Obviously, getting a signal to go that far down. I mean, if they can't be 4 miles away, or could they still have a range connection with their controllers?
You know, the control links, the radio control links that are used for these craft today are extremely robust. Range of, say, 2 to 3 kilometers. He's barely getting out of bed in the morning. It's easy. Obviously, you fly behind a mountain, you fly behind a building, and that's going to have an effect. But in clear line of sight, a distance of 1,100 feet like this is absolutely no problem whatsoever.
So this is Stanford Online High School out of the Bay Area in California, and this is a huge moment as they are just majestically hovering. Look at this. They are up around, 87 feet. The vehicle weighs 45.6 pounds. Their payload, just 2.5 pounds, so they're just getting up there with next to nothing. That's the Titan tracker.
Yes, that's that Titan tracker.
But they're up. They have proven that this design does
work. It flies, and now they're going into forward flight. You can see that rear airfoil lifting up above the front airfoil, getting clean air. All of those fins making lift. And, surely the pilot is just enjoying, flying around there up in the sky, finally getting to do what he loves to do. But also, they're gathering data about how much more efficient their craft becomes when they transition to forward flight, and the motors don't have to do all the work of holding the craft. And I got to say, it does, in fact, look like Santa's sleigh up there. We need to put some reindeer on the front of this thing.
I love your design idea. Get them a superlative. It looks like they're coming into a landing. We'll see if they bring this thing in and save the sleigh. SOS, here we go. Not quite on the landing pad, but guess what?
Yeah.
That's
huge. Oh,
huge.
my goodness. Big smiles. Big smiles, big selfies. Yeah, fantastic.
Students at Stanford Online High School, as well as students at American High School. That's huge.
Think about what it would mean. Think about yourself in high school. You get to come here to the DARPA Lift Challenge amongst such a group of competitors. You get up, you get to fly around.
That was awesome. Good for them. So the question is, are they done? There's still 35 plus minutes left in this 11 o'clock flight window.
I mean, if they like what they saw, they put some weight on. Now, remember, they do have to do an unloaded check flight, which may have been what we just saw there. They'll have to do a half-weight check flight with 55 pounds, and then they could put more weight on. So it remains to be seen. But they will not be making a competition attempt until the safety team clears them. I saw when they set down, it kind of shook a little bit. It wiggled a little bit. The whole frame did. And we've speculated in the past that the trouble they had just getting into the air might have something to do with the frame not having enough rigidity. Seeing how it kind of wiggled, it does make me wonder if they put more weight on it, is that going to get any worse? Let's see if we can take a look at that landing. Watch when it just touches down. We're looking good here. Looking nice and smooth, nice and controlled. And as it hits the ground, just watch that frame almost rack a little bit. There we go. Levels out for the landing. And boom. See that shimmy and wiggle? That's only going to get worse as things get heavier. And it's going to make that flight controller, the little computer that flies the aircraft, it's going to make it work harder.
So Stanford Online High School UAVs out of Redwood City, California. They're in the academia category. And they are back. So they're back on the launch or landing pad, JB, and they're not around it. So I'm wondering if they're back behind that Jersey barrier and maybe possibly going to spin this thing back up again.
Yeah, if they showed the safety team what the safety team wants to see, then they have the option to add weight and do their half-weight check flight. Maybe they're grabbing some weight plates. He got something in his hand. I can't quite tell what that is. They're heading back out.
So they will not be spinning up here in the next few minutes. Which means we get another guest on the set, and our guest is Mark Zaga from the Hovering Owls team out of Boca Raton, Florida. Mark, good to see you.
Good to see you.
Appropriately dressed from Florida Atlantic, representing.
Yep.
So how has been your experience here in Dayton?
Yeah, it's been a pretty good experience. We got here Sunday. We flew most of the week. Sadly, we weren't able to fly Saturday and Sunday. We had to crash off site, but overall, a great experience. Thank you guys. This was an amazing competition, a great experience for all of us, and definitely a ton of lessons learned, and just a great experience.
Well, let's take a look at Team Hovering Owls in action. Give them their due as they made the long trip from Boca Raton. Here they are. Very cool design. Give us some background on this design and how you guys came up with it.
Yeah, so as you can see, the front two rotors tilt. So how we yaw is unique in that we don't have to cancel our rotors like a quadcopter does to get yaw. We actually tilt the front and left at different angles to get our yaw. So our yaw actually gets stronger at higher payloads, and it gets very strong at the 110. And the idea is that the motors can tilt forward, and as you gain speed, you get lift from your wing. So the idea is that it's a wing-assisted flight vehicle. So you offload some of your workload to your wing, but not all of it, which allows you to still have control system with the 4 quadcopter motors that you have with the front 2 tilted.
Yeah, we've talked about the difficulty of transitioning. Like if you have a vertical wing that transitions to forward flight, it can be a real challenge to make that transition. And it sounds like you tried to solve that issue with this design.
Yeah, so definitely our logic, definitely our logic compared to like sort of like a tail slitter design would be that we can always bail, I guess, and that we're always in we're always holding stable attitude, whereas a tail slitter has to switch attitudes, so they might not necessarily have the option to bail out of a transition. We always have the option where if it's not going right, we'll tilt our motors perfectly upwards and we'll just lose speed and
the wing never pivots.
Yeah, the wing never pivots.
And the weight never pivots.
And the weight never pivots. So that might also be a concern in terms of what your payload is and where you're trying to take it. But definitely our logic was that if we ever needed to bail, it'd be a lot safer to bail with this sort of vehicle because we can always tilt the motors back up.
What year at FAU are you, and what are you studying?
Yeah, I'm a senior. I'm a double major in mechanical engineering and mathematics.
Nice. So you took the easy route.
The easy route?
I'm just kidding. Come on, Mark. That's called sarcasm. You're a senior?
Yeah.
Did you graduate high school at 13? Come on.
I'm a little bit young. I'm 19 years old. We have a program at FAU where you can start a little bit earlier. And
did they start you in kindergarten? It's amazing.
They started me a little bit early, but you're
going to graduate as a 19-year-old with your undergraduate degree?
Yeah.
With a double major?
Yeah.
In easy categories. So what's next for you?
Yeah, what's next? Definitely more drone stuff. I mean, drone stuff is very interesting. I love it. We only started doing drone stuff pretty recently, so this was definitely a push into. I mean, there's pushing into the deep end, and then there's pushing into like the ether. Like
you're my new hero, Doogie Howser. Well done, Mark Zaga from the Hovering Owls and Florida Atlantic University. We wish you the best of luck, and we will see you hopefully down the road.
Yeah.
Awesome. Thank you, Mark. All right, we get off of young Mr. Mark Zaga and the Hovering Owls, and MTech is out there on a scoring run, and they are at 4.04. And again, this could be history being made, as we are so lucky to be here at the final day of the DARPA Lift Challenge. Everyone trying to give Donna some gray hair. He is just being pushed to the absolute limit. Will they get it done? Will they get the 4-to-1 payload to weight ratio? They are on the clock, as we like to say. Top right corner is fully green. That means they are good to go. They need to stay above 100 feet for 4 nautical miles, then come in, land, unload the payload, then go back out for 1 more nautical mile and do it all with under 30 minutes.
Yeah, that gray hair is not, will I have to give away this $2.5 million check?
He wants to.
The gray hair is, please, somebody make me get rid of this $2.5 million check. We got a 4.04 ratio. That is above 4 the last I checked. All they have to do is complete the run. But did we have an altitude deviation?
They're not at 0.5 yet, so I think they're okay.
Oh, that's right. They have until 1/2 mile.
1/2 nautical mile, so 0.50, they're still in the good. We'll keep them in the green for the time being. Now, once they cross that 0.50 nautical mile and they dip below 100, that top right corner will go to black and it will no longer be a green. But for those of you that are fans of aviation aeronautics, this could be, and I'm not announcer jinxing them, this could be history in the making, because they're at a 4.04 payload to weight ratio, something that has never been done before. And if they can complete the entire 5 nautical miles, they will be in line for a $2.5 million payoff.
I've noticed the pilot has goggles on his face. We've talked previously about them flying with the unaided eye, but in this case, it seems like the pilot, he's just raised the goggles, so he's had a problem and he's transitioned to line of sight flying. That is a very difficult move. You have to transition from being basically in the craft to looking at the craft. That is a real pro move, although most people wouldn't know it to see it.
They dropped way below. They're down 20 feet and descending. It looks like they're going to bring it back in. So did not crash. That's the good news. But they did.
Something went wrong.
Showed you exactly what they're capable of doing, because they did go above 100, and that's got to be a high five moment.
Yeah. I did see some wobbling as they were climbing and some wobbling as they were flying. It's interesting to speculate about why they might have chosen to fly this with the FPV goggles instead of line of sight.
Did you see he checked his timepiece there really quickly, because they are now under 30 minutes to go in this flight window. And we have said before, everyone who has completed it with weight, his scoring time has been somewhere between 19 to 24, 25 minutes. So they've got about 5 or 6 minutes, depending on how quick they can release the weight, to get this thing done.
Looks like they're taking a battery off that big blue thing he carried away. I believe it's the battery. If they did have some kind of a problem, they're going to want to switch to a fresh battery.
There you go.
Fully charged. Here he's running the new battery out. to install it. The big question, of course, is what went wrong and why will it not go wrong again this time? What are they going to do differently?
Only way to find out is to give it a shot, but you do see a sense of urgency there out on the flight line as they are going to make a swap out. And I'm going to just say roughly, they probably got about 5 minutes to get this thing swapped, changed, and up in the air again.
The more they hurry, the more energy they're going to waste and potentially the more trouble there. So they really want the time to be smooth and slow.
So we are following this team as they make a slight change, and they are dealing now with an under 30-minute window to get things done in the 11 o'clock flight window. Remember, no one gets 2 flight windows a day. It is just one, and we talked to Don about that a little bit. He said, you know what, we didn't want to make it a long, protracted, just keep swinging for the fences, because at some point we did have to end the competition.
Yeah, I mean, unfortunately, although these guys.
Although you'd stay here for another couple
here.
weeks, wouldn't you? I mean, you love Dayton.
You can see there looks like some taping going on. Those are batteries. Are they charging batteries? That is a battery charger on the ground. He might be. Might need to top. Oh my gosh!
Gonna cool him down.
My gosh! We're cooling down the batteries. The battery's getting super hot. On the left side of the screen.
He's going to fire up a generator.
Yes.
Yeah.
Okay, so they are charging batteries. The only reason I can think of why they would do that would be that they don't have spare batteries. These batteries, of course, are very unique and very rare. People have talked about being simply unable to buy them. So they do not have a spare set of batteries. They're going to have to charge these batteries back up. They're cooling them down. This is a very, very tense moment. You can only charge those batteries so fast without risking damaging them or even potentially lighting them on fire. I would not want to be in this situation. Imagine you got to do a pit stop, you got to change tires, but instead you have to recharge the tires that are already on the car. Okay, it's not a perfect analogy. This is not good.
Well, the last 2 days, this is one of the teams that has been involved with pushing the limits of what is possible with the 4-to-1 payload to weight ratio, and that's what took place on the last 2 days. Teams going for 402, 611, 405, 404, and they are in a quick one. But MTech went for a 402. It was yesterday. It was 2 days ago, and they are just trying to get these batteries, as JB said, they're all hooked up, charging and cooling at the same time. So he's got the heat check on there, seeing where they're at. Yeah, he's going to hit those things with the. Could you throw that in a bucket of ice? Could you put it in a plastic bag, waterproof it, and put it in a bucket of ice?
You wouldn't want it to get wet.
No, but seal it in a
you would want to cool it down for sure. I mean, these batteries are heating up the whole time they're using them, and they're pushing them so hard that can cause thermal failure, and of course the aircraft will fall out of the sky. My guess is that the cooling is not directly related to the fact that they're charging them, but is related to the fact that when they get in the air, they don't want the batteries to already be hot and then potentially overheat during the flight. The real question is, they were in the air, they sucked some life out of the batteries. How much time could they possibly have to get that life back in? You cannot charge a battery as fast as you discharge it. You typically will charge a battery about 1/5 to maybe 1/10 as fast as you're discharging it, sometimes even lower than that. So if they flew for 1 minute or 2 minutes, it might take normally 10 or 20 minutes to get that back in.
I don't know if it was you or Donna the other day talked about your iPhone sitting on the dashboard of your car heating up, and then you go to turn it on and it has the warning that it's overheating. This is kind of the same situation. These batteries got too hot too fast, and so they're going to try to give them a little bit of a trickle charge and cool them down at the same time, and then try to get back up the air. By my calculations, we have got roughly 26 minutes left in this flight window.
I believe the object he has in his hand is a thermometer. It's an infrared handheld thermometer. He's checking the temperature of those batteries. There is I'm not going to say what number they're using, but there is a number I would not like to see. If the battery was approaching that number, I would say, hey, this is too risky. I'm not going to put it up in the air. Back to the leaf blower.
Here's a crazy idea. Wouldn't you want to do this in the shade?
He doesn't have you got to have the generator going. You've got the charger. You don't want to take time moving those batteries back and forth.
Extension cord. 2 words, extension cord.
Big extension cord. Yep.
So he's going for the rapid cool down method with a run-of-the-mill electric leaf blower. Just putting some cool air on those things. So 25 minutes, give and take a few seconds, is what he's looking at, and that is still doable. If they can get this back together, get it back on the launch pad, and get clearance and go, they can get it done.
Checking the voltage there. He's seeing how full the batteries are. He's checking his clock.
Yep.
He's saying, when do I call it? If he calls it, if he waits too long and he waits for him to get to full charge, then he may not have time to finish the run. If he doesn't charge them fully, he may, as we saw previously, run out of gas and it just feet from the landing pad.
If you're MTech and you're in second place, there's not another competition tomorrow. Do you put this thing back up in the air and say, okay, we didn't get the 402 on the entire 5 nautical miles, but if you do 3 nautical miles, 2 nautical miles, doesn't that all of a sudden say, whoa, 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 we want to talk to you on Monday?
Yeah, I mean, these guys' phones are going to be ringing. Everyone who places here, everyone who demonstrates something significant, whether they place it or not, as Donna said, there's people out there who need this capability desperately.
A lot of eyes on this.
Yes.
And what I used to call Supercross, and make another sports analogy, we'd always say, what wins on Sunday sells on Monday.
You're right. You're right. And it's not just because of celebrity worship.
Sure.
It's because
this is technology.
Everyone can claim anything, but you actually go out and you do it. You actually prove that you have something to offer here in a crucible like this, and people take notice.
I think there's got to be an award for a superlative for best effort. I mean, if you get up, let's say no one breaks the 4-to-1 threshold, I think someone should get a prize who was up the longest or traveled the distance at 4-to-1. I'll chip in a 20.
I'll chip in a 20. Yeah,
okay.
20.
So there's 40 on the line for whoever can get up and stay the longest. Yeah, he's checking the voltage again.
I mean, honestly, if I'm out there and I'm looking for talent and I see people doing what the teams are doing, are these the kind of people you want working for you?
Problem solving in the field?
Yeah. Because a lot of these people are entrepreneurs. They're not for hire.
Well, we saw it with MacGyver, and we've seen other teams racing around, swapping out everything from batteries, parts, props, rotors to actual pilots when they've come up short. And this is a situation right now for MTech as they are trying to get those batteries not only charged but cooled down.
Yep. Our clock, we're currently about 22 minutes by my clock left in the flight window. That's not an official time, but that is similar to the time that they probably see, and they are thinking hard about how long it's going to take them. I definitely don't think they're going to be changing weight. No. The idea, well, could we remove a little bit of weight? That would take too long.
Yeah, what would be the purpose in that? Yeah. You should jump in a golf cart, race over to the DARPA walk-in refrigerator.
There we go.
Stand there for about 30 seconds.
They're unplugging the batteries, unplugging them from the charger, putting the leaf blower down. It seems like they might be about to put those back on. They're putting them in. That is a Kevlar bag that's used to transport the batteries. If the battery were to light on fire, it would help contain the flames. I would like to see them putting the battery back on the drone. Maybe they've looked at that battery and they've said, hey, this one's not good to go. We're not going to use it. All of these batteries may not be used for this run. So, if you only needed 2 of them, you probably leave the other 2 charging. Maybe it's fully charged? Yeah, he needs at least 2 batteries, I believe, is how many they had on the drone. So the batteries are broken into separate banks and they're all plugged in together. It's not clear why he put that one away. Again, checking the time. Talking to the official.
That's a smart group of people, though. I'll tell you that right now.
Picking up the leaf blower.
They've got some Guinness World Records for speed. So MTech continues to work away. Again, this is a team founded by MIT engineers and entrepreneurs. They have developed advanced autonomous systems and technologies, and they are pushing the boundaries on endurance, payload, and speed. But right now, they are fighting against the clock. Can they get this put back together with the batteries cooled and charged in the next, I'd say the next 2-3 minutes, or they have hit
checking the temperature
the
again.
no joy point.
Checking the temperature of the batteries. If they're too hot, they may not be safe to use. 2 more of those batteries going back in the Kevlar bag. They really need to get this back on the drone and get the drone back in the air if they're going to make an attempt. But it doesn't make sense to do it if your batteries don't have enough juice to finish the job. He goes running out.
With the leaf blower. So I imagine they're going to use every final second they can to keep those things cooled once they mount them.
Is he running to the drone? Going to put it back on the drone? Okay, so they had to bring those batteries back into the pits to charge them. They were not able to bring that charger out to the line. hard to say which would have been faster, carrying the batteries of the Charger, but putting those batteries back on top.
Unofficially
securing them on the drone.
19:30, 19 minutes and 30 seconds in this window. Still time. I mean, this thing moves pretty quick.
Yep.
It's all going to come down to how quickly they can get rid of the weight once they complete 4 nautical miles.
Yeah, to my memory, the fastest run we've seen, well, you haven't seen a huge number of successful runs, but to my memory, the fastest successful run we've seen has been about 18 minutes. So unless they're going to do something, well, they're going to do something that's never been done before, but they're going to have to do it quickly if they want to finish. They do need to be back on the ground before the close of the flight window, and we do not have any indication that they've been granted additional time. If you land and you have to charge your batteries, that's entirely on you. But they're not going to stop. I mean, if they had 10 minutes left, they would go 2 miles, they would go 3 miles, they would come in and land and say, hey, look, we got close. Plugging the batteries in. They're not going to be able to just jump into the air. They're going to need to make sure this craft is ready to go. And you might think, well, all you did is take the batteries off and put them back on again. But still, you know, every time you get in an airplane, you do your pre-flight checks, and every time you put a drone in the air, you make sure everything's good to go. Again, checking the time. They are right up against it. Getting those batteries strapped on. One of the dumbest mistakes you can make, you're kicking yourself at the end, as if you don't secure the batteries, you take off and one of those big batteries comes loose and falls off, and then you're grounded. So there's no time to make a mistake because you got sloppy, because you were in a hurry. But they have to hurry some, or they are not going to finish this run. There's that Titan tracker being strapped on top. Can't finish the run if the officials don't know where you are. And you see him touch that prop and move that prop.
Yes.
He's not even, he's checking the temperature of that motor, right? He's just walking up, just thinking about all the things he needs to check. That was probably subconscious. He reached his hand out. The motor was nearby. He touched it. Is it hot? I'm going to cool it down. He's doing everything they can do to try to increase their odds of success.
So the control center has now said that all lanes will close at 12:30, which means I don't see how they're going to get this up and cover that 5 nautical miles, JB, with a removal of the weight after 4 nautical miles. But I'll tell you what, we're already in the hook for $40 for them to get up. I believe.
There
you go. Look at there. They're putting the leap blower now on the actual props and the rotors.
The motors.
Cooling those motors down.
The motors down. That's right.
What do you think the temperature is today? Right. 80? 84?
Yeah, sounds about right.
A little humid. Not terrible.
A cooler day would make it easier for them.
Sure.
You take a drone that's designed to fly at a sort of normal medium temperature like this. You take it somewhere where the ambient temperature is much higher, and it performs worse. And you'll see cases where people say, "Hey, I bought this drone. I took it out to the desert, took it out to the Middle East or something."
So if it was 55 degrees today with very little wind,
absolutely,
they'd be having better performance.
Absolutely,
Okay.
A 20 or 30 degree difference in ambient temperature will keep those motors cooler longer.
Are you going to be the one to tell Donna we should be holding this in October?
I would rather hold it today.
There you go.
I'm going to ask for an air-conditioned booth.
There you go.
In October.
So they are frantically working, but you know what? It's going to be a win regardless, because they're going to get this up in the air, and they may not get the full distance in, but I think they're going to get up and they're going to fly this baby.
Yeah, they're getting it Titan tracker strapped on, and you know, I believe. We can talk about the experiences that they've had. I mean, the bonding, the stress, the pressure, and how this will serve them in the future. We can talk about that if they do not get in the air, but right now, I want them to get this in the air and get this 4.0 to 1 payload to weight ratio run successful. Titan tracker is secure, walking away. Once he gets behind the flight line, they will be able to spin up and get into the air. Battery looks secure. The drone is ready to go.
Clock is ticking as we are coming up on less than 15 minutes away from the end of this flight window. No one has been given an extension. Most importantly, MTech has not been given an extension. The team from Sudbury, Mass., we saw them go up in the air with a payload that would get them in the $2.5 million conversation. But right now, they've got to get up, and they've got to cover a great amount of distance in a short amount of time. They've got to do it safely. So here we go. It's time to spin it up, MTech.
Pilot It's arming. Pilots lift it off line of sight, giving it a little bit of a wobble to see how it flies. Flying it away.
Gosh, look at that. 4.04
Get it
payload
up in the air.
to
He
weight
is wasting
ratio.
no time. Wasting no time. He is moving already at 34 miles an hour, 33 miles an hour, just going for it.
And they've hit 50. Okay, so they've hit 50.
The big question, though, is how did they get into this situation? Remember, they were making a run.
Yep.
The drone seemed unstable. They brought it in and landed it. They haven't addressed that problem in any way that I can see. They charged the batteries. Hopefully that's something that the pilot said, hey, I can fly around that. I can be more careful. I can do something differently. Or maybe they're just deciding, hey, let's just cross our fingers. We're going to go for it.
Okay, you saw it dip below 50 there momentarily. They have not hit the half nautical mile threshold mark, so they can dip below 50 until that. They're coming up on it rapidly. They're at 0.33 nautical miles. Once they hit 0.50, they can no longer dip below 50, but right now they're good to go.
100 feet.
Correct. Sorry.
Oh, no, they're coming down. They're coming down. Losing altitude. The run is still on until they hit that half mile.
They
They need to be over 100 feet by the time they hit half mile. This is what we saw last time. They were climbing and then suddenly they were dropping. Pilot has his goggles down again. He's flying via FPV, climbing. 0.46, 0.47. They need to be over 100 feet, though.
They're going to be there.
100
Look
feet.
at this. Okay.
100 feet.
So they're over 100 at 0.48, and now the chase is on.
Yep. There we go.
Okay,
so
they can no longer go below 100 feet. They've got 13 minutes to get this done. They're 145 into this one. This is a vehicle that weighs 29.6 pounds. They are carrying 119.4 pounds, and they are off and flying. Look at this, 33 miles an hour.
They have to hurry. We're going to need to see speed for them, or they will not finish this run within the 13 minutes they have available. Remember, they need to go 4 nautical miles. They're going to make multiple turns because this is only an 1,100 foot lane. And they can't just floor it.
You can tell exactly when they're making that turn because they drop down to about 10 miles an hour. Now back up to speed, 32 miles an hour. Plenty of room on altitude. They're at 132 as they approach the 1 nautical mile.
And you can see
we haven't seen anyone go this far.
Pilot looking relatively relaxed now. That suggests they're flying autonomously, and the flight controller is just going back and forth at a pre-programmed route. And they are monitoring, looks like on a laptop or tablet, they're monitoring position. If anything goes wrong or anything, they don't like what's happening, the pilot will take control manually. But certainly the advantage of a pre-programmed route is that a computer is going to be a lot more precise with the altitude and with the speed. The disadvantage of a pre-programmed route is that if anything goes wrong, the computer's just going to keep trying to do what it's doing. And a human pilot can take over and can compensate in some way.
There you see it turn down to 7 miles an hour. Now it's going to pop back up to 30. They're still at 133. 13 minutes in. You know, the question is, JB, and you know this, it doesn't look like a very extensive weight holding apparatus. Almost looks like some not zip ties, but some tie downs that they could, maybe release those within a few minutes and then fire it back up, because that's part of the 30 minutes.
Yeah. I don't know. Maybe
their problem is not 30 minutes. Their problem is the flight window.
Yeah. They're over a mile. They're 1.2 miles.
1.2 miles.
Considering that they didn't even get their run officially started last time, this alone is a big win for them. And at this point, they just got to keep doing it, and see if they can make that 5 miles.
I guess this is why you send your kids to MIT. I mean, this is amazing. 4.04 payload to weight ratio with a drone that only weighs 29.6 pounds. And they are carrying nearly 120 pounds. They are 1.45 miles in to this scoring run. Unfortunately, this window will close in less than 10 minutes.
Yep. That wobble definitely would make me worry as the pilot, seeing that wobble, wondering if it's going to happen again, wondering if this is the time that we come down or if it would keep going. It is possible to have motors and ESCs with temperature measurement in them, but a lot of the motors especially don't have temperature sensors in them. So you do not know if you have a motor during flight that's approaching its thermal limit. Of course, I can't speak to the specific design, whether they have that or not.
No pressure, lads, but there is $2.5 million on the line. They've now hit 5 minutes. So they've gone 5 minutes in with 1.75. Let's say they go 10 minutes. That should put them at 3, 4. Ooh, this is going to be close.
Yeah, they are in second place. So,
Sure.
I mean, even if they don't complete this run, they're still doing really well. But everybody wants to be the one, to take first place and
Right.
to break that 4.0 payload to weight ratio that unlocks the full $2.5 million.
Worst case scenario,
first-place
they're
prize.
already looking at around $750,000 if they can maintain that position that they're on the leaderboard in second place behind our leaders who are at 384 on the payload to weight ratio. They are coming up on 2 nautical miles at 5 minutes and 40 seconds.
Yeah, so there's 2 things I can think of that might end this run now. Number 1 is if the batteries don't have enough juice, and number 2, if they're so close to the physical capabilities of this platform that an ESC, an electronic speed controller, or a motor just burns out. They seem to be flying okay. They seem to have enough authority to make the turns. We're seeing a little bit of wobbling, which suggests that we are very close to the ability of this aircraft to carry this weight. That stability comes from excess power, and they just don't have any. The question is, do the motors and ESCs hold on, and do they have enough gas in the tank, metaphorically speaking, to finish the run? Here we're coming up on 2.25 nautical miles, almost. And keep in mind also, Todd, when they drop the weight, everything relaxes.
Right.
The battery could be, it's not like a gas tank where if you have gas, you have it, and if you don't, you don't. The harder you work the battery, the worse it performs. So when they take the weight off, suddenly, everything's going to be okay. Well, maybe not quite okay, but it's going to get better.
So they have roughly 8 minutes to go. And just to make a point, they cannot replace anything on that drone when it comes in. They cannot
That's
put
correct.
fresh batteries on
No,
there.
sir.
They can't replace anything. Can they go out and take the leaf blower and try to cool it down?
They
for
can. I mean, I'm
Okay.
not an officiant of the rules, but I don't believe there's a rule that would prevent them from trying to cool it down.
Okay.
And we'll know when they land if somebody runs out there with a leaf blower and tries to cool this thing down
So
just a little bit.
They're basically halfway through the course. They did that in 7 minutes. They've got under 8 minutes to go. So this is really going to come down to how quickly they can get the weight off their drone.
Yep. So they are 7 minutes in. Oh, that wobble is not good. That is not good. Hold it together. That flight controller is just trying to stabilize the drone. The motors are getting hotter. The motors are making less thrust. The motors are becoming more inefficient. Everything, and that flight controller is just adjusting in real time. And eventually, either you successfully finish the run or you hit a limit where something says, I can't give it anymore, Captain.
Right.
And the run ends. Yeah. A wobble.
Bit of a
I don't want
wobble.
to see that.
That-
I don't
I
want
mean-
to see that. I don't want to see that
And
come
the
back.
wobble seems to be coming in when they slow down, and they are slowing way down. Went down to 5 miles an hour. Now it's back up to 20. Altitude's still good. They're at 284 nautical miles. They need to hit 4 nautical miles before they can drop that weight. They're at 810 right now. Check the clock on the flight window. It looks like it's under 7.
So they could get rid of that wobble
Yeah.
by going slower.
Yeah.
But they can't go slower because they
go
can't
slower.
afford
No.
to waste time.
And there's the wobble again when they slow down.
They're coming down, descending. Oh my gosh! Oh my gosh!
And it's gonna.
That's it.
Okay.
That's it.
Well, they went nearly 3 nautical miles with a 4.04 payload to weight ratio. In my book, JB, that's a big win.
That's a big win. Oh,
Look how
landed-
close they were
oh,
to the landing area.
Right here. They're right here. Yeah. So something gave out. Something gave out.
And they were probably getting a reading, wouldn't you say, on that that iPad that was basically telling them,
Yeah.
you like some people like to say, land now.
Yeah. Land now.
Donna's the first one out there to congratulate them.
That's right. Big pat, slaps on the back, handshakes all around. An amazing accomplishment.
Yeah.
You know, I'd be interested, maybe we can research this and talk about it another time. I'd be interested to know, for those who have made attempts at the 4.0 or higher, what's the furthest anyone got? Is this the furthest anyone has gotten at the 4.0 or above?
2.99 nautical miles unofficially for MTech in 9 minutes and 20 seconds. Just over 9 minutes, actually, and that was with a 4.04 ratio. So that, I have a feeling you're more connected to this than I am. That's going to reverberate around the internet and the chat rooms of what just happened here in Dayton.
Well, and somebody's going to walk out of here with first prize for completing the whole course at the highest payload to weight ratio. But if I was the one who went the furthest at 4.0 and above, I would be telling all my friends about that at the bar.
You're in the 4.0 club.
Yeah.
Come on.
Yeah.
Own it.
3 miles. 3 miles at 4.0 to 1 is incredible.
We were this close. So do you think, and it'd be great to get a debrief from them what they're saying, do you think it was a battery issue? Was it?
Well, if it had been a motor or an ESC, we would have seen smoke come out. We would have seen it tumble into the ground. The fact that it descended relatively flat suggests a gradual loss of power that would be consistent with running out of battery life. And they didn't seem very surprised is the other thing. They didn't seem very surprised, and so they're monitoring the battery voltage as they go. As a drone nerd myself, I wish I could see the battery voltage because it was flying, but we can't. So it could be. And again, you know, you keep juicing the batteries, you keep pressing on the gas pedal, and eventually it just falls out of the sky.
I have this sneaking suspicion that there's going to be some phone calls made to Sudbury, Mass. at MTech on Monday.
Oh, yeah.
Because we talked about it. What wins on Sunday sells on Monday. But what goes almost 3 nautical miles on Sunday is going to get a lot of interest on Monday with a 4.04 payload to weight ratio. MTech in second place overall officially, but first place in our hearts.
Yes, and we see there talking to Donna, the DARPA program manager. We see Luke Bell and his father. Both multiple drone speed world record holders, hundreds of kilometers per hour. So they are no stranger to doing things that has never been done before.
It's like he's still looking into the goggles. I thought he might just be putting his face into a towel crying. I was that close to $2.5 million.
And Todd, let me ask you, how fast do you think his drone speed record was? I guarantee you're going to guess too low.
Not today.
Not today.
His drone speed, we were talking about Mr. Bell?
Yes, sir.
We are talking drone speed record.
I guarantee you're going to guess too low.
Does it matter the size? There's no size restriction?
I believe it was a 7 or a 10-inch drone. It's a very small drone.
7 or 10-inch drone. I'm going to say, just because you juiced me a little bit, I'm going to say 150 miles an hour.
150. You think you're going high. 408 miles an hour. 408 miles an hour. And by the way, that's just the first of his records.
400 miles an hour a drone?
Yes. I just looked it up.
Can I Google check that?
You can.
I trust you, though.
The thing is, he's got multiple records, so that may not even be his highest one.
So that is it. What a performance.
Flight line, be advised the flight window is now closed. I repeat, the flight line is now closed.
Well, do you think if they had more time, obviously there's a 30-minute time limit, but do you think if they had gotten that up, let's say at the top of the hour, and they could have used the full 30 minutes, they could have backed down the speed and possibly saved battery?
You know, going slower isn't necessarily more efficient. It doesn't necessarily give you more range. There's a sweet spot where you're going just the right speed to maximize your range. And the problem is that the nature of this challenge doesn't let you get comfortable. Like, you can't just say, this is my optimal speed, I'm going to go that speed, I'm going to go 5 miles, and I'm going to land. You're constantly stopping, turning around, accelerating, decelerating, and keeping these guys out of their comfort zone is what the rules are designed to do. So it's hard to say if these guys could have done anything differently. I think they're giving all they can give.
Well, they gave us a great show, and they absolutely pushed the boundaries, so thanks to MTech. Reminder, the final flight window will be at 2 o'clock Eastern. We'll all be there. We hope we see you as well. Welcome to the final flight window of the DARPA Lift Challenge here from the United States National Museum of the Air Force. We're at the DARPA Lift Challenge in Dayton, and we have reached the pinnacle of the competition. Todd Harris alongside Joshua Bardwell as we get ready for the final go.
Flight line, be advised, the flight window is now open. I repeat, the flight window is now open.
So for the last time, the flight window is open here on Super Sunday. That means we have 90 minutes to try and get a drone in the air with a 4-to-1 payload to weight ratio. If they can get that done in under 30 minutes and travel the 4 nautical miles with weight and 1 nautical mile without, they will claim the $2.5 million prize. All right, JB, as we look at the standings right now, you've got Aviadrone on top at 384. MTech sits in second, and Extreme Aerial Concepts currently sits in third.
That's right, 384, 364, and 345, really reinforcing just how difficult it is to hit that 4-to-1 payload to weight ratio. It sure seems like if you could get that close, well, you could just try a little harder. Yeah. But it just shows that these teams are trying not just as hard as they can in terms of their capabilities, but they're stretching the materials and technologies that they're using to the very limits, and that's really the whole point, to find that limit.
So we've got 90 minutes, barring any extension given to the teams that are out on the line. But it's been a great competition. If you were with us for the 11 o'clock flight window, right to the very end, it looked like it was going to happen as MTech was out on the line. You know what? 1.99, or was it? No, 2.99, excuse me. 2.99 miles with a payload of, what was it, 404?
4.0. It was just over that 4.0 payload to weight ratio.
Yeah.
And so, we saw a lot of happiness from the team, even getting that far. Maybe the farthest anybody has gotten with greater than 4.0 payload to weight ratio. And that certainly is something worth taking home with you.
So you heard Ann Bush tell the flight line is now open. This is EFN, also known as Energetic Flying Nuisance, out of Claremont, New Hampshire. Mom came on last night. Had Mom on here. Tell us about all the trips she's making to Home Depot and Lowe's and buying leaf blowers and glue and everything else to get them out there. So here they are. I will say this. The wind has picked up a little bit, and the temperature certainly is quite a bit warmer than it was this morning. The temperature very, very humid. So we've got EFN, Rock Solid also here. Crew out of Austin, Texas.
Yeah, that looks like they've got that pusher propeller pushing them behind. That's the team that had the not a parachute.
Yeah, the parasail.
Inflatable wing parasail, thank you. Haven't been having trouble to getting that inflated. And who knows, maybe they'll solve it today, or maybe they'll take another attempt at solving it, gather some valuable data, and we'll find out, sometime in the future, suddenly they cracked it.
Is this Happy Hellfire?
That is Happy Hellfire, and they have been struggling all week to transition from vertical to horizontal flight and maintain control. Here we see them trying it again. They seem to be doing a little better. Oh my gosh, they seem to be flying into a headwind.
Yeah.
They are pushing hard and barely going anywhere.
Holding still. Happy Hellfire to Pensacola, Florida.
This is the best I've seen them fly in the whole event. They're getting that wing horizontal. They're getting into that flight regime where they can take advantage of that wing's lift as opposed to relying on the propellers, and they are getting buffeted by the wind as well. When your whole aircraft is a giant sail, you can hardly be surprised when it catches the wind. But they seem to be staying in control. It's very nice.
Not a bad thing to put on your resume that you came to the DARPA Lift Challenge and you did fly.
I guarantee they're putting it on their resume. There were a whole lot of people who came out, 489 applicants. Of those, only 132 were selected, and of those, only 76 made it on site, and of those, and here's where I run out of numbers, even fewer actually got in the air. And every single one of those is an achievement. Happy Hellfire has definitely made it to the rarefied air here at the DARPA Lift Challenge.
So we've seen Rock Solid, we've seen Happy Hellfire, we'll see who else makes their way out there. And for a lot of teams, I won't say it's attrition, JP, but a lot of teams have just run out of parts and supplies and batteries and everything else. They've been going for 7 days. This is the 7th day of the DARPA Lift Challenge, and this is literally the last window.
The last flight window, that's right. 90 minutes here, and all these teams will be using their time, whether they make an attempt or whether they, here with Happy Hellfire, for example, we have not seen them pass their check flights, their safety flights, so they will not be making an attempt, but they've been given an opportunity to go up, and here they're going to make every bit of it.
So we'll see who else decides to show up. A lot of teams have this flight window. They are scheduled to be out there, but they can waive it off. They can say, you know, we're just not ready. We don't have the parts, or we're just going to pass. So there's a very good likelihood that a lot of the teams are already maybe deconstructing their drone and getting ready to pack up and head out. I want to remind you, we still got the 90-minute window open. Plus, you can watch the award ceremony tonight. That's coming up at
7 o'clock.
7 o'clock Eastern time.
Yep. And during that award ceremony, of course, at the end of this session, we will know with relative certainty who the first, second, and third place prizes go to. But the subjective prizes will be announced at the award ceremony tonight. There'll be a little bit of a presentation, a recap, and highlight reel. And I'm sure that Donna will get up and talk, and some other luminaries from DARPA.
I know that it's kind of a hidden ballot. No one knows who's casting those ballots and what it'll be, but each prize is worth $500,000.
$500,000, that's right.
Worth sticking around for. So that's coming up at 7 o'clock tonight. That will be from the museum here, the National Museum of the United States Air Force in Dayton, and you can also live stream that as well. So the team's making their way out there. Driftless is out on the flight line as well. EFN, we've already seen the energetic flying nuisance. Looks like we've got another team, roll-ups out of Evergreen, Colorado, I believe. This is another one of the teams that say we're just straight out of the garage.
Yeah, a lot of people coming out of their garage here, getting to come out at the National Museum of the Air Force and put novel designs into the air. This one looks like a relatively traditional multi-rotor design. I see a couple interesting things here. Looks to me like there is that orange connector, that yellow connector hanging down in the middle there. That looks like a battery connector to me. Makes me wonder if there is some kind of an individual powering system for the motors. Yeah.
So roll-ups is on the line, and that's half the battle. You just got to make it to the line. And as you pointed out, over 480 teams applied, and 132 were accepted, and in the 70s were on the line for the last 7 days. Capstone Airlift also out there, the team out of Maple Valley, Washington. Team of aerospace enthusiasts with wide experience and expertise in experimental airplanes and drones, and they said they're excited to bring their expertise to the DARPA Lift Challenge and contribute fresh ideas to the future of flight.
Yeah, and we see these teams coming out, even though they may not be on the leaderboard, just coming out to take advantage of the opportunity to fly these aircraft. These giant aircraft are all under 55 pounds, which is the legal limit per the FAA for most drones without going through a lot of paperwork. But the ability to put the weight on here and go up is something that you couldn't normally do. So there's a lot of opportunity for teams to develop their technology, to test it out at these higher weights using the special permission that DARPA has gotten for this event.
We've also got Sherman Aeronautics, one of our favorites, the double fixed-wing craft out of San Bernardino, California, husband and wife team. See if they can get up and give us a little bit of a show here on the last day of the DARPA Lift Challenge. It's a good look at them. We've seen this before. We'll see if they can get up. It's always fun to watch them spin up, and that's pretty much not the full battle, but just getting up, and then once they get the payload up, they're connected by that cable between the two wings, and they get up. So it's kind of cool to watch happen. So
yeah,
we will
every
see.
time I see it happen, I'm like, I can't believe this is even real.
It's workable.
And you know, it makes you wonder, well, maybe this wasn't that hard. And then you see other teams trying to do it, and there is not a single other team who has successfully gotten the air, that, to my mind, that except for with this design, except for this team. So kudos to them for just making this happen.
If you travel all the way from San Bernardino, California, you might as well take every opportunity to see if you can get your invention up in the air and put on a bit of a show. As we said, there's a lot of people watching this from around the world, also here in Dayton. A lot of eyes on here that are very interested in the technology that is coming out. And this is back to Rock Solid. They're doing the
You know what that is? You know what that is, don't you?
That's the dance.
That's the compass calibration dance. Oh, it's never good when something falls off. I'm sure it'll be okay. Maybe there was a USB cable getting yanked out. Now they'll have to start again. Look how big that battery connector is. Now I'm probably the only one watching it. Maybe not. There's got a lot of drone enthusiasts watching this. That big orange connector, it's a gigantic to handle the massive amounts of current that these drones are pulling and these batteries are delivering. Just shows you the scale of what we're working with here. You know, if that compass calibration dance gets interrupted, you got to start again.
Yeah.
You got to do the whole thing over again.
So we'll see if Rock Solid has sorted out that calibration situation and then get their craft up in the air. 90 minutes is the flight window. They don't have to use the entire thing, but that's where they will shut it down, and then the competition will be over.
Yeah, and we certainly see who's in the lead now, and it certainly makes you wonder, is that it? Is that how it's going to stand? We haven't seen a lot of movement in the leaderboard. We've seen a lot of people taking some big swings, but so far, not a lot of movement. And certainly if you're calibrating your compass at this point in the competition, I think chances are that you're not going to be the one to shake that leaderboard up. But still great to see these very innovative designs and these very determined teams getting out here.
All of this, of course, taking place during the midst of a Flight Fest, which is also on the campus here as well. So it is just a sea of activity here in Dayton all week long as we bring it to a close here on a Super Sunday. I want to bring in a special guest here, Luke Bell from MTech. And if you were with us for the last flight window, you saw just how close they went. Luke, thanks so much for spending some time with us.
Yeah,
appreciate
sure.
it. Congratulations. Welcome to Dayton. How's your experience been thus far?
It's been a wild ride, I'm not going to lie. A lot of lows, but a lot of highs as well. It all comes part of the territory, Engineering is always going to be very difficult, but at the same time, very rewarding. But to be honest, me and my dad, when we were working on this project, we actually had quite a bad crash. I think literally a week before we were flying over here, and I literally said to him, well, that's the end of the project. Like, we're not ready for this. We can't go. And I think we spent about 3 hours thinking about it. Can we cancel it? Can we not? And then we were like, no, I think we should just go. Even if it's to meet the people here and just see what everyone's come up with. We put in all this effort and we just wanted to be a part of it still.
And it was not an easy flight. You guys traveled from Cape Town?
Yeah, from Cape Town,
South Africa. Not a direct flight to Dayton.
No, I think it was 3 flights total and probably about 31 hours of travel time. Yeah, so kind of rough, but we arrived a few days before the event to actually build everything. So I think for the first day, I just slept in the whole day. Yeah.
Well, Luke, you're no stranger to breaking records. We've got some footage we're going to roll of you attempting to break this 4.0 to 1 payload to weight ratio. You and your father also hold several world speed records for drones. How has this been similar and different to breaking those speed records?
That's a very good question. I would say it is remarkably similar. It's got literally all the same aspects of you come up with an idea, you run the calculations, and then it comes time to actually build and test your device. It's always the same process, and it's sometimes a little easier with less failures, but most of the time you have a lot of failures along the way, and it's kind of what we get used to as engineers. And yeah, it was very similar actually. And I actually found out about this competition from my endurance drone video. Once I posted that, I got a lot of comments about, you should do the DARPA Lift, and do you know about that? And I was like, no, what is that? And then I read the brief, and I was like, that sounds pretty cool. I think I could do that.
What was your first reaction? Was it like, oh, that's easy, I could do that?
No, it was not. I mean, at first I was like, that's interesting. So then I think I spent literally the entire day running calculations to see how difficult this was. By the end of the day, I was like, oof, this is rough. I don't know if this is possible. Yeah.
But you got so close this morning at 4.04 payload to weight ratio. You guys were up for 2.99 nautical miles. Take us through the drama before that, because we were on the edge of our seats. You took the batteries out. You had the leaf blower going. You were trying to charge them at the same time. You put them back in. What was going on with the team? What were the conversations like?
I mean, it probably almost looks like we made it up by giving you guys more drama, but that's not the intention, I promise. Essentially, we started out the run because we crashed our drone yesterday into a massive fireball. There was literally nothing left. So we got home at about 4 p.m. and worked the entire day throughout the night. I think I only slept for like an hour. Got the drone ready in the morning, brought it here, and of course, first thing you turn it on, the compass isn't working.
The compass calibration dance?
So that wasted about 10 minutes, I think. We did the dance. I don't know if you saw that. And it seemed to work. And then we took off, and the compass actually fell off the drone.
Yeah, we saw you take off. We saw the drone start move, and then you came back in for a landing very rapidly.
Yeah. So it was pulling back like this because it's all programmed to be autonomous.
Right.
And then it started yawing like this and then going crazy. And then I was like, I just need to take control. So I brought it back. I tried to do the run myself, but it's it's borderline impossible to fly as efficiently as a computer
Right.
can. So I was like, no, this is not going to work. I'll bring it back. We can charge the batteries. Maybe we can go again. And that's basically what we did. And from there, I think at one point I was almost just charging the batteries to at least make it look like we were doing everything we could. And then I was like, wait a second, there's actually probably enough time to do this. So we took the batteries off. They weren't fully charged, which is quite unfortunate. Launched the drone in the air. Realized it was flying really low. And I was like, that's not right. I put in 42 meters as the target altitude. And then Bryce, the team member, he was like, check the settings. He was like, dude, you changed the settings to feet. Like, what? Oh. So I've been doing these calculations this whole time to switch between meters and feet. And eventually I was like, no, I'm just sick of this. I'm gonna change my RG pilot to feet. But I completely forgot that, obviously, because I didn't sleep. So he called that, and he was like, oh my God, okay. Then he quickly changed the number, put it in, and the drone literally rose to the target altitude above 100 feet. I think within, like, probably a few feet.
You know, it's great to get your perspective because we see these things happening and we're like, why did it do that? And sometimes it's as simple as I was up all night working and I forgot to convert meters to feet. You guys are just fighting it every step of the way.
Yeah, exactly.
So you started the run and it looked like it was going pretty well.
It was. It was good. It was smooth. We were getting quite bad vibes on the drone, which are vibrations. Right. You know, you get that orange warning. That's never good. So I'm literally changing the tune mid-flight to try and get it to be more stable, which can be risky, but we've been doing it this whole time. Sometimes it's the best way because you get instant feedback. You change the number, you can see how it reacts, and I could never get it locked in as well as I would like. So you probably saw it was quite wobbly, not as smooth as we've had it before, and eventually. I still don't know why it came out of the sky like that. Yeah, I don't know if you remember, it kind of just dropped when it was at 3 nautical miles. The battery was not too low.
It was not.
Oh, okay. It still had enough juice, very probably to actually finish the run. I tried to look at the ESC logs before I got on here, but I haven't seen a conclusive answer yet.
So something happened, and the flight controller decided it was time to go down to the ground.
Exactly. And when it started dropping, I switched into stabilized mode out of autopilot. I was going full throttle when it was coming down, but it wasn't listening. Maybe even a motor turned off. I don't know. I really need to check it. That's going to be very interesting to actually find out. And it landed, which is pretty heartbreaking. But I think right after we were done, it kind of made the whole thing a lot better because everyone came up to us and basically congratulated us as if we had just completed it. So that was an amazing moment. It was really cool to come full circle and have Donna there as well, and just everyone so excited that we got that far. Even though we didn't get it, it still felt like a massive accomplishment, and I think we can be proud of what we accomplished here, especially considering a week before I was this close to canceling our flights just because I didn't want to come all this way with something that I wasn't confident could perform well.
Yeah, it worked out well. How aware were you of the time? You know that the flight window was closing, and you needed about 20 to 24 minutes to complete it.
That is a very stressful aspect. And I don't know if you noticed, but our drone flies pretty fast.
Yes,
and
we did.
It's literally just because if you're not moving, you're going to run out of energy. Because the longer you're in the air, the more battery power you need. So our strategy is basically speed up and return as quickly as possible. And along with that comes pushing the acceleration to the max. So it needs to stop immediately and then come back right away. Because all that time you spend just turning around, if you came up there, did a nice slow, steady turn, came back, we wouldn't be able to make it. We would run out of battery.
There's a sweet spot, right? If you were to just go full throttle as fast as you could, you'd waste a lot of energy. Exactly, and of course, you say if you go too slowly, you waste time spending in the air. Did you put a lot of work into finding that exact sweet spot?
We did. And on our earlier runs, we actually tuned that mid-flight. So I would do one loop, Then from my laptop, I would change the acceleration, the top speed, do another loop, and etc. And then eventually I could calculate what is the best, I guess you would say, miles per gallon.
Right.
But for a drone, so it's watt hours per kilometer or
yeah.
miles. And from there, I've determined about 15 meters per second. I think it's like 30 miles an hour.
Again, that whole metric to
I know
imperial
it's.
thing.
I know there's been a couple big disasters when people have mixed it up.
It killed a space mission too.
Yeah,
so you're not
exactly.
Alone. You're in
At
good
least
company.
we're not alone.
Well, we sure appreciate your time, Luke. We wish you the best of luck. We hope you see you down the line. But congratulations to MTech. 2.99 nautical miles at over 4 to 1. So it was a great show, and we appreciate it. Even if you did sell us on the drama on the batteries a little bit, that was awesome. You, Bryce, your entire team, thank you so much. We wish you the very best. So MTech doing a great job there, and they are still on the leaderboard. So that is the good news. Top 3 for them. This is Capstone Airlift out of Maple Valley, Washington, the small business category, and they are going at 3.48 payload to weight ratio. This would put them into 3rd place, JB.
Yeah, MTech, who we just spoke to in 2nd place, not threatened by this, but 3rd place could potentially get knocked out. Of course, we've seen that there is a long way to go between getting in the air and finishing that full 5 nautical miles. So,
you know who's watching this with close attention?
Yep.
Extreme Aerial. They're sitting at 3.45, so they would be eclipsed by Capstone, who would go 3.48, and that would push Extreme Aerial into 3rd place. And that does. Where are we at on the distance? So they have not hit the half nautical mile, so as long as they stay above 100 feet, once they hit the 0.50, they're good to go. Now they're way high.
They're over that 200 foot by a lot, over by 100 feet. I don't know what kind of discretion they get for, we know they have to hit the 100 feet floor before a half mile. I don't know what kind of discretion they get for exceeding the 200 foot ceiling. Of course, the actual FAA permissions have been granted up higher, so there's no issue there.
Yeah, I think that was a geofence violation anyways.
Yeah, I'm hearing that they crossed into another lane and were forced to bring it down. Situation where, depending on the judgment of the officials, they may be allowed to bring it back and fly it back under control, and they'll just have their run disqualified, or they may be told, no, bring it down, and they'll be forced to
it looks
land.
like they are not close enough to go retrieve that during this final flight window, so their day may be done. As we take a look as Extreme Aerial, who is breathing a big sigh of relief right now, so a team that was trying to bump them from 3rd place, 2nd place into 3rd, 3rd place into 4th. Capstone looks like their mission to climb into the top 3 has come to an end.
Yeah, and it's a shame, but remember, this is about more than just lifting the weight. It's about lifting the weight in a controlled manner and performing a specific task, being able to move that weight around. And if you can't stay within the lanes, well, it's more than just potentially you've created an unsafe situation, or less safe than preferred, let's say. You have not demonstrated that you can control the drone in the manner necessary to accomplish the task at hand.
So, JB, why was Capstone Airlift able to just incrementally go up just to the point where they were just eking out Extreme Aerial Concept from 3.45? They went 3.48, just a micro change on the ratio. Why can't another team just say, I'm going to go 3.85?
Yeah, well, there's 2 factors here. One, you got 2 numbers. It's a ratio. So you have a top number and a bottom number. The top number is the drone's weight, and the bottom number is the payload weight. The drone's weight is going to vary, and that's why we're seeing different ratios here. The bottom weight is defined by the number of weight plates you carry. So you might have a 25-pound plate, you might have a 45-pound plate, but you're going to have like a 17-pound weight plate. You won't find that at your local gym. So depending on how they've designed the mounting points for the weight plates, there's only certain combinations of plates, and so of course the drone weight itself is fixed, and so only certain ratios are available to each team. But of course that's all up to their own decision making about how they designed their drone.
So there is the current leaderboard as we approach the witching hour. That will be the final hour of competition here at the DARPA Lift Challenge. That comes up in just a few matter of moments. We are scheduled to close it down at 3:30 p.m. Eastern Time, and then all scores will be final. They'll be tabulated. The only thing left to do is the superlatives. There are 3 superlative awards up for grabs for $500,000 each. Most revolutionary designs, most revolutionary powertrain, things like that. So Happy Hellfire, they look like they are still trying to make another flight possible. They're
It does look like they're doing something with a weight plate.
Yeah.
I don't believe we've seen them do their unweighted check flight, and so I would be surprised if they were putting that 55 pounds of weight on for their half-weight check flight. But we do see they've got that gray Titan tracker removed. That's the tracker that tells the officials the drone's location and that we're using to know their height and speed and so forth. And it does look like they're putting a weight plate on there. We've talked about that they're having trouble getting into forward flight and they might benefit from additional weight. Perhaps they've been given permission to put some weight on and try and get it flying better. We will see what happens.
Well, the good news for them is when they do have a crash, they bring it down rapidly. There's not a whole lot to damage. I mean, the majority of that structure is pretty, I don't say damage-proof, but relatively indestructible with the wing.
It's just a skeleton with some fabric.
Right.
You know, the main advantage going to be that it would pack down really easily, and it's relatively easy to repair if it does get damaged. And here we're looking at Sherman Aero out of San Bernardino, California. We've got those two airplanes attached by a steel tether, and they are lifting some weight in the air. You know, we've seen them consistently we haven't really seen any major drama from them. We do know at one point they had to replace their GPS unit.
Yep.
But they have lifted this weight and set it back down again several times, and I think they're really demonstrating the capabilities of this system, a system which most people would have said was completely non-viable if you'd asked them before we got here and saw it done.
So their vehicles weigh in at a weight of just under 32 pounds, but their payload now is at 57.4, so the ratio 1.80 payload to weight for them. And the folks from, who's this team? Rock Solid there in the foreground. Looks like they're going to give it a go again.
Yep, one more attempt at getting that parasail inflated. And you know, they're struggling with this hurdle, but a parasail has the potential for one of the best payload to weight ratios of any sort of aeronautical vehicle. The challenge is getting it inflated and keeping it inflated. If they can accomplish that, well, probably there's not enough time left in the competition for them to actually score, but just demonstrating that they've solved that one technical problem could open some doors for potential future innovation.
Sherman Aeronautics has come back to Earth. The weight is on the ground. We'll see if they spin it up. Pretty stable though. Look at that. I mean, it's kind of the holding pattern.
Yep. They're making it look easy. One of the things we've talked about is that as they add weight, those planes get pulled together. And you'll see that as the planes start lifting, they spin faster. They increase the speed to keep the tension on that wire. And one of the things we haven't seen from them is a transition like into forward flight. They've kind of gone up, down, meandered around. I really would love to see them actually get a little bit of speed and sort of move in a direction. I'm curious what it would look like. Only 6.7 miles an hour, just kind of drifting around at this point.
But they are at 80-something feet, 80 plus feet.
Here we go. Here we go. They're going somewhere. I'm intrigued. It doesn't actually look like there's a lot of tilt on that quote-unquote rotor disc, if you imagine the plane spinning around as if that was a rotor disc of a helicopter. That kind of is. That's what Dono explained to us earlier, is that it's basically like you took the outermost part of a helicopter rotor and got rid of everything else, and just the part that produces lift. But it didn't seem to tilt over much as they picked up some speed and started moving, and now they have slowed down again.
So we are T-minus 60 minutes in the final flight window here at the DARPA Lift Challenge. Coming up on the last hour of competition. Does anyone have any magic mojo left to try and push the limits and get that payload to weight ratio to 4-to-1? We've been close. We've got teams that have actually gone up in the air with over 4, but unable to complete the 4 nautical miles plus 1. And Sherman Aeronautics here in lane 10. They've been in the air now for almost 4 minutes, kept it above 50 feet. But as you see in the upper right hand, JB, not green. So this is not a scoring run, a little more in the testing area.
You know, the folks here from Sherman Aeronautics, I've got to be looking over at the Skyweaver team. That's the other team that has the sort of 2 tethered airplanes. And on the one hand, they got to be saying, well, we're sort of brothers here. We brought this technology. They got to be saying, also feeling pretty good. These guys have gone up and down multiple times. We've seen Skyweaver struggle to get into the air. And of course, that's all part of the challenge here, is figuring out what works and what doesn't work. I wonder if they were surprised. I wonder if Sherman was just surprised to show up and see anybody else with this design.
Yeah. So it looks like they are just kind of meandering about the course. See their speed not very far. They're not logging a great distance, but they are moving.
And they're staying in control. That's the thing. We've seen so many radical designs here try to get into the air, fail to get into the air, go out of control. I mean, to see somebody lifting a 1.8 payload to weight ratio with such a novel design and just be going up and down and staying nicely in control, that in itself is a heck of an achievement. Yeah, that 1.8 ratio is nothing to sneeze at. 1.0 is pretty typical for even large cargo helicopters. They've almost doubled that. And it's only in the context of this competition, where we have multiple teams going even farther, that that's anything less than amazing. And they're slowing down. And as they slow down, notice they're starting to whip a little bit. Now they're going to try to get this. Ooh.
No, that almost looked like it gone rogue.
Yeah, you think they were going for broke? They just gunned it. I don't know.
Absolutely.
We saw them slow down. They started to get a little cockeyed sideways, then they sped up. That speeding up may have been an attempt to flatten out. We know that the planes will pull harder on that steel cable the faster they go, but it just sort of slingshotted them into the ground.
Let's look at this one more time, and again, it did look like someone gunned it, or he hit the nitrous button, because look how slow, calm.
Airplane's going high.
And now hit the juice.
Getting out of control and whipped into the ground. Woof. You know, the good news is that these are relatively inexpensive, relatively simple designs. Of course, I'm sure the folks at Sherman don't feel like they're inexpensive, but compared to a lot of the stuff we've seen out here, this is the kind of thing where you can probably be more afford to iterate on this and keep trying. And they've done really well over the course of this competition, that they haven't had the number of crashes and other things that we've seen from
the one
other
thing
teams.
with that design, though, JB, is if one fails, more than likely the other one's going to fail, because your future is tethered to your partner.
Yeah, something happened to that system where both planes started going high on one side of the circle. Maybe there was a gust of wind or something, or maybe the computer that links them up and synchronizes them made a decision that didn't work out. But if one of them goes, certainly the other one's going to go as well.
So this is rock solid again. They are. Ooh, the wind might have just blown that off its stand.
No harm done. No harm done. Put her back up. Maybe it just slipped.
There seems like to be enough gusty wind, Joshua, that they should be able to get this thing up. I mean,
this
it's
is
any day. This is the ticket.
This is the one team that the wind might help if it's coming in the right direction. Yeah, the big challenge, if they do get this inflated, and by inflated I mean think about how a parasailer gets started. They're on a hill slope and the wind's blowing up the hill, and they kind of pull it and they let the wind inflate it, and then they get in the air. Or you think about a base jumper, they hang the parachute below them and then they jump over it and woof, it inflates. These guys have to accomplish that, and they've really struggled with it. They can't just like flip the drone and have it inflate. Well, I've heard people say, why don't they just flip the drone? It's not that easy.
Not that easy.
The other challenge they're going to run into is they're going to have to drop that weight. So if they do get it inflated and they do get in the air, most likely it will fall and deflate again, and they'll have to repeat the process after they drop the weight.
And the transition time is going to just be it's going to be a tough one.
Yeah, they'll have to reset all those lines, and I like to say if you do something once, it might be luck. You know, when you're trying to do a really hard freestyle trick with a freestyle drone or anything else in your life, you do it once and it might be luck. And so if you do it and you go, wow, yay, I did it. Well, great, do it again. Prove to me that it wasn't luck. And these guys, I mean, ultimately, if this is going to be a viable solution, they got to figure out how to get this inflated, not once, not twice, but, well, basically every time.
Yes. Part of the R&D process as they continue to put out those tether lines out there. It seems like most of the attention is on the parasail and not on the actual drone.
Yep. they've made some changes to this drone. This big rotor on the, well, it's a complete redesign almost from the way that it used to be. This big rotor on the back, we see that, we call that a pusher rotor. Imagine like a boat, like a prop on the back of a boat pushing it through the water. A lot of times these multi-rotors, they will just tilt forward. They'll tilt forward and then pull themselves forward. But this design, it looks like they've got a giant rotor on the back so that they can gain that forward speed, presumably to help inflate this parasail. But they just haven't gotten to a point where that even matters. We've seen them get in the air, we've seen the sail hang below them, and we have not seen anything sort of remotely close to inflation. Detangling those lines. We saw them pack that up and stuffing it in the bag, keeping those lines from getting tangled so that it all inflates correctly. This is all part of this process. But you know, this is a fascinating potential for this design. I mean, you think about it, if this could carry a 4-to-1 payload to weight ratio, think about how small this packs down compared to many of the other designs we've seen. Imagine you've got a scenario where you're going somewhere remote and you have to carry it, and the weight really matters, or maybe the size really matters. You know, each of these technologies is solving different problems. You might have a great big giant drone with a lot of motors and it's redundant. You might have a drone that packs down really small, but then you have this technological hurdle of how do you inflate it. So like everybody is thinking about different problems to solve along the way, and each of these solutions might have a different application somewhere else other than the DARPA Lift Challenge.
So just getting themselves squared away, ready for takeoff, is a big challenge here. But you're saying possibly this design could outweigh the downside of all this, as we say, faffing about to get it just ready, flight ready.
You know, there's a famous quote that I'll mangle, but it's something like, if you judge a fish on its ability to climb a tree, it'll be terrible at it, right? And the point is that every solution is tailored to a specific problem. And if you don't have that problem, then the solution looks like, you're like, well, there's no point to this. But there's definitely problems for which this type of design is the perfect solution, and somewhere someone is going to be rooting for these guys to figure it out. They're like, I need that.
Trying to crack the code here at the DARPA Lift Challenge. This is the 7th and final day. We're at the National Museum of the United States Air Force at the DARPA Lift Challenge in Dayton, Ohio. And if you're wondering, DARPA stands for Defense Advanced Research Projects Agency. We're lucky enough to have Philip Smith, call sign Donna, with us. He is a Marine pilot in reserves, Lieutenant Colonel. Thank you for your service. He's the program manager. Joined us throughout the day, but he is going to be down on the flight line, he told us, for these last 2 flight windows.
Yeah. Seeing those guys, and we've seen him out there personally shaking the hands of these teams making the 4.0 to 1 payload to weight ratio attempts. Both teams not successful at making the attempt, but seeing Donna walk up to them, shake their hand, congratulate them. As we heard Luke Bell say, it made them feel like they were a winner, even though, of course, they would have liked to have successfully completed their run.
This looks like roll up. They're either going back in to do the dance in private, or they are needing more tools. So roll-ups will take it back to the prep area. So the competition comes on. We're 5 minutes away from hitting the halfway point of the final flight window here at the DARPA Lift Challenge. A lot of teams, as we've seen, JB, throughout the lunch hour, are starting to pack up, and they've kind of, I don't say waved the white flag, but they've done all they can do.
Yeah. Well, eventually you're done. The clock runs out, or you've got nothing left to give, and you just sit there and you think about your day, and you celebrate your wins. You know, everybody who got here had 1,000 wins. They solved 1,000 different unique problems, and then eventually you find one that you don't solve, and you go back, you recollect yourself, and you see where you're going to go from here. And I think that's where a lot of these teams are at this point.
So still action down on the flight line as we are coming up on that last 45 minutes of the flight window to wrap up the competition here in Dayton. We've been fortunate enough that we're close enough to the flight line that we can have special guests pop in, and we have another special guest from Atlas Advanced Tactical Lift Aircraft Systems. Orion Mangio joins us now. Thank you for being here. First question is, what's your experience been like the last week?
Oh, it's been a blast.
Yeah.
I've been doing RC my whole life. So this is like peak RC.
Yeah.
You can't do any more RC
You're
than
with
this.
your people.
Yeah, all the people in one place.
How'd you get into RC? What was your first introduction?
I mean, I was doing rubber band powered planes. That's when I was a kid, and then gliders, and then gas, and then.
How does a guy who does rubber band powered, RC hobbyist end up here at the DARPA Lift Challenge?
It's a circuitous path, as my uncle would say.
Yeah.
So, I was went to school for engineering, control systems.
Okay.
Master's degree in that.
Oh,
and then
okay.
Went through the Air Force, did the pilot thing a bit. Then I did cyber, and then.
I think you might have been underselling it a little
Yeah,
bit
there
when you
you
first
go.
got here. I was master's program, Air Force. What'd you do in the Air Force?
Was a pilot for a bit, and then I had to switch to cyber.
Okay.
And then I was a cyber officer, and then I went to a research lab. I'm co-founder of Motovolo.
Nice.
So
University of Buffalo or Buffalo University?
University at Buffalo.
University at Buffalo. The Buffaloes.
They sponsored this.
They're very good.
So we're kind of the industry partner.
Very good. Well,
Yeah.
we appreciate you being here.
Crash Lab.
Are you impressed by what you've seen so far? Are you surprised by anything you've seen so far?
Yeah, I mean, it's interesting. Like, for example, our drone had about 15 pounds of batteries, but some of the guys that were farther up the list had, 25 pounds. So you're kind of playing the game of how much battery weight versus aerodynamic efficiency. So,
Yeah. So you talk about some people, you had 15 pounds, some people had 25 pounds. As
Yeah.
you're going into this, you have a lot of engineering trade-offs to make.
Yeah.
Tell us about how'd you end up with 15 pounds? Tell us about some of those trade-offs.
So we had some interesting constraints. So, I mean, we had kind of a shorter timeline. So we wanted to use components that we had for our production drones. They're fully 3D printed. So same motors and then same batteries, because then we had them on hand. And then same firmware, because that's the same tune on the ESC.
Yeah.
So then that left us at 6S, 12S, or higher would have been a lot better.
Yeah, I think a lot of people look at what's going on here, and of course it's easy to armchair quarterback, and they say, well, why did they do that? It's obvious that it would have been better to do X, but it's not like you start with unlimited time, unlimited money, unlimited attention. You start with some constraints, don't you?
Yeah, it's tough to even just source components right now, like the drone dominance challenge. Like, most of the motor manufacturers won't even talk to you.
Oh, man. If you can't get motors, you can't fly.
Yeah. Yeah, so
That makes it interesting.
it's
So
tough.
what's next for you? You come away from this with lessons learned, and what do you do going forward?
I mean, we're going to keep going with our 3D printed drone. We're scaling that up to 36-inch props. We build our own 3D printers, so we'll
Nice.
keep doing that. Yeah, it's not going to slow down at all. But now I've done a lot of genetic optimization type stuff, so this will kind of feed into that. I've kind of done optimizations on certain parts, but
Yeah.
really you got to do the whole system.
So you're saying the data you're getting here is super valuable regardless of where you end up on the leaderboard.
Yeah, unfortunately, I mean, usually you want to go through the whole design live like 3 or 4 times.
Yeah.
And this was the first time through the live.
Okay.
Thank you so much, Ryan, for sticking around and visiting with us. Ryan Mangio from Atlas, that is the team from Crash Labs, the University at Buffalo, as they were participating in this year's DARPA Lift Challenge. Speaking of which, the director of DARPA, Stephen Winchell, gave us his thoughts on what this competition is all about.
We're trying to create an environment where thousands of people who are passionate about a problem, who know how to solve it, actually work on a problem. And there's no way to do that. I can't get 1,000 unique vendors on contract. I can't get people that are on a farm or, in their garage on a contract for DARPA. But what I can do is I can give them $2.5 million if they can build a drone that can actually meet our specifications. And so that's what we're doing. How do I build things quickly, field them quickly, learn quickly, and then rebuild them, redesign them, and refield them as quick as I can, right? You want to collect the data, you want to learn, you want to innovate and change and adapt, and then you want to redo it and relearn. And I think that that's what we're seeing here in real time. One of the other things that's been really exciting is seeing that there's been 3 teams so far that have gotten their drones loaded up with over 4 times their weight and gotten them off the ground and out onto the range. And those drones were destroyed, every single one of them. And for me, being a part of an event where people are pushing beyond the limits of their hardware, where people are pushing up to the hairy edge of what's physically possible, and where people are failing, but they're failing in all the best ways for all the right reasons. And that is just a great place to be, and it's a great group of people to surround yourself with. Every program needs to have impact that stretches far beyond the core element, right? The core element here is, how do I build a drone that can lift 4 times its weight? And how do I control it? But if you expand that circle out a little bit, it's how do I build businesses that can make the drones of the future and that can build the supply chains for those drones of the future here in the United States. And if you expand it a little further out than that, why is it here in Dayton? It's here in Dayton, co-located with Flight Fest, because I'm trying to get the future, right? Future innovators. There's flight enthusiasts, thousands of them over there, and really unlocking the future talent and getting them to see what they could do in their future, right? This is a phenomenal opportunity to get your get talent early on, expose them to some of these really rigorous and challenging engineering problems, and inspire them to step up and become the next generation of engineers and leaders that the nation needs. If you think about what DARPA is, what DARPA is all about, it's about that. It's about enabling program managers to do the impossible, and it's about enabling communities to come together to do what was considered absolutely crazy just a week ago.
All right, we appreciate the time for all the folks from DARPA that have popped by here or given us insight. Stephen Winchell, the director of DARPA, giving us his insight on the Lift Challenge, and Don and his entire staff have been fantastic all week long, dealing with whatever Mother Nature or the competition has given them, whether it's rain and thunder and lightning, shelter in place, whether it's trying to get every people plenty of flight times, compressing schedules, things like that. So tip of the cap to them.
Yeah, for sure. I was thinking last night that you can tell a lot about the leadership of an event by how the event is run, and this event speaks very highly of leadership. Donna and the others.
No question about it. Good folks at DARPA here. I like to call them the Orange Army. They're out there. If you see them in an orange T-shirt and you're here on site, give them a thank you, as they made this possible. Still trying to get that up and going as teams are out there working frantically on the flight line to give one more shot at getting up in the air. We're coming up on about 40 minutes to go until the flight window and the competition comes to a close here in Dayton.
Yeah, that's right. He's looking at Happy Hellfire there. We speculated that they might be putting some weight on. Looks like they're getting ready to go back out and put it up in the air again. I'd love to see them finally make that transition into forward flight and really prove that their design and their build can do what they think it can do.
Well, a lot will happen on Monday. That's tomorrow morning when all this is taken down, and they'll take home the data. They'll go back to DARPA. They'll say what worked, what didn't work, and everyone will be wondering how can we make it better or how can we help out. One of the people that involved in that is the Director of Small Business Programs Office at DARPA. That is Jennifer Tabbitt. She's standing by with Elena.
I'm here with Jen Thabit, who is the Program Office Director for DARPA's Small Business Program. Jen, can you tell us more about how small businesses, how they can work with DARPA, and what's the importance of that in the innovation ecosystem?
Oh yeah, absolutely. So DARPA is really that start of the innovation pipeline, right? We are where you go to help move your ideas from disbelief to doubt. And so we really look for those small business innovators. We do about 27 to 29% of our work with small businesses each year, which far expands the Lift Challenge, the SBIR and STTR programs. If your idea is bold enough to matter, we really want to hear and work with you.
Very nice. And can you give us some insight into how the teams that are here at the challenge this week can work more with DARPA after this competition?
Yeah, absolutely, right? So when you are starting at the start of the innovation pipeline, right, we know that we are often your first or second touch point with the government. And so we have lots of different resources here to help you. First of which I think you've heard about this week is called DARPA Connect. And that is really our front door to the agency, where we really help educate you and teach you how to work with us. The other piece that we have here is the last several years we've made a very dedicated effort to build out all of our innovation entry points for DARPA. So we have everything from a plussed up SBR and STTR program, the ARIS Marketplace, which you will hear about, and more pitch days and seedlings. The goal really is, if your idea is bold enough, we want to give you an entry point to work with us.
And where can people go to look up all this information?
That's a great question. The easiest place is to go darpaconnect.us. darpaconnect.us, sign up for a login and start learning.
All right, well, you heard that. Back to you, Todd.
All right, thank you very much, Elena, and thank you, Jennifer Thabit, the Director of Small Business Programs Office at DARPA, for that information. All right, as we come down to the home stretch here, JB, we're looking at just under 40 minutes to go. Teams are still out there trying to make the most of these last 40 minutes. I figure if you traveled across the country, or even in some cases like MTech across the world from South Africa, you're gonna use every single possible minute.
Oh yeah. I mean, we heard the analogy that this event coming to a close feels like summer camp ending and nobody wants to go home. Yeah, if they were having one more sing-along around the campfire, it doesn't matter how many songs you already sang, you're definitely going out just to try to make that moment last a little longer, just to try to say you did one more thing at the DARPA Lift Challenge.
Well, it does not look like, and this is a soft doesn't look like, we're going to reach that 4.1. We did see one team, MTech, go up for 2.99 nautical miles. Remember, the threshold is 5. They went up for 2.99 with the 4-1.
That's right.
But then came down to earth rather quickly. We had Luke Bell on set. There's just so many what coulda, shoulda, woulda beens. I mean, just flipping from meters to feet, having the extra batteries, having the time. It was just a couple of variables, but you can see just how close they are.
Yeah, they're so close. And, you know, I said earlier, when something unexpected happens, the number one thing you want is to know why it happened so you can learn from it and prevent it from happening again. And we heard him say that the drone just started to descend and he didn't know why, and that he was just not capable of flying it line of sight, although he did switch it back to manual control, try to keep it in the air. It was just coming down. Maybe a motor or an ESC was pushed too hard and stopped working, and it sure seemed like they were going to go for it.
As the saying is said, and I think someone should put this on a t-shirt, it's us versus the drones.
Us versus the drones, that's right. These darn drones, if it weren't for them, we'd be getting so much done.
So much great action throughout the week. 7 days of competition, and it will all come to an end in less than 40 minutes. And there will be champions crowned. Worth noting again, since does not look like we're going to get to that 4.1, that payout goes to half. So instead of 2.5, it's 1.25 million, which is not terrible.
Not terrible. I'm not going to be sad if I go home with $1.25 million. Let's see, $750,000 for second place and $50,000 for third place. Here we're looking at ratio, spinning up those big rotors and trying to get their craft into the air. We got it pushed back a little far, probably for safety. It sure looks from here like those rotors are overlapping. So what you're doing there is you're getting increased thrust and increased lift out of a smaller physical size. You know, physical size does matter. We saw a team earlier in the day packing their drone into the back of a minivan. Well, you can imagine if these rotors are beyond a certain size, you wouldn't be able to do that.
No.
And you have to transport these drones sometimes. You don't just fly them everywhere they need to go.
This is Ratio Drones, as you pointed out, a team out of Austin, Texas, and they are a aerospace startup building for Frontier Logistics, and they deliver heavy payloads and on-site power generation wherever the work is, beyond roads and infrastructure, serving defense, energy, agriculture, and emergency response. And that's not just talking points. I mean, you think about trying to get a generator into the Australia or the Alaskan outback in the wintertime.
Yep.
You're not driving it.
I can't help but notice the pilots are crouching down behind the Jersey barrier. I laugh just because it's a little unusual. You know, they've got a fence, like a chain link fence up there so they can see it. Maybe they feel like if something comes loose and goes flying,
exactly,
they would like to have a little more protection. It's very important. You see this at drone races. You see this at flight lines. Anytime where something like this might happen, you have some protection for the pilots and the spectators. It's always amazed me that they do full-scale air shows. And I guess for a full-scale airplane, Jersey barrier wouldn't be enough, but for these little aircraft, we can give these pilots something to keep them safe. Now we're spinning the rotors down. They do look like they overlap. When the rotors overlap like that, it is reducing the efficiency and reducing the amount of thrust since they are sharing the same airstream. But there's a trade-off there with the reduced size and the increased portability and packability, and ultimately that's one of those engineering compromises and trade-offs that you make.
So they spun up momentarily, did ratio drones, and then they shut it down, and it looks like they're going to take a look at something. Maybe they saw something coming on their telemetry that they just did not like.
You saw the pilot reach down. It looked like they unplugged a battery. So this does look like an electric system, not a liquid fuel system.
Do they always do that when they go out there just for safety purposes?
Yeah,
Does it
pretty much.
Fire up on its own?
Pretty much. I mean, if you think about it, there's a little switch on that pilot's controller, and when they flip that switch, then the motors start spinning. And you might think, well, gosh, just don't flip that switch. But accidents do happen, and so there's multiple safety protocols. So you saw that pilot or the engineer, the team member, walk up, and the very first thing they did, they walked up and they unplugged it, and now it is sort of inert and safe, and they can walk around and they can inspect it and they can do what they need to do.
Got a whole host of folks out there, and he's kind of body languaging what he was seeing or feeling. It looked like it was something off center and a little bit of an angle. So they'll try to get that thing sorted out. All the problems. They've still got 30 minutes.
30 minutes would be enough to make a run.
But we're getting down to that no joy zone where we're saying, what, to be safe, you've got to have at least, what, 22 minutes?
Yeah, 18 to 22 minutes in the air is
If you've got some
about what
serious
we're seeing.
intentions of getting a scoring run on the books, you're going to need a solid 20 to 22 minutes, because remember, you have to take the weight off after the 4 nautical miles and then get it back up and go another nautical mile. So we've seen teams come up short because of time, and we've seen teams get it done as fast as 19 minutes. So there, it's kind of the sweet spot of the window, but as MTech can attest, sure, it'd be nice to have an extra 10 minutes.
Oh, yeah. You'd like that time. Of course, these guys would need to have completed their safety check flights. And I don't think that's the case. I don't think they've done that. So there are ways from trying to make a competition run, just using this time they've been granted here at the DARPA Lift Challenge with the special legal waivers. Doing this kind of testing wouldn't be possible under a lot of conditions for a lot of people. So there are people who came out there just for the opportunity to get to fly here at the DARPA Lift Challenge, gather some data, and see how their aircraft performs under pressure.
All right, we talked about the top 3 prizes. Again, if no one hits the 4-to-1 payload to weight ratio, the payout cuts in half from 2.5 to 1.2. And then we have the superlatives. And these are the 3 categories that it doesn't matter how you performed in the competition, as long as you came and you presented something. One of the first ones, and this is interesting, the most promising or most revolutionary powertrain. I kind of like MacGyver.
Yeah.
I think they got to be in the running for this one.
Yeah, the best powertrain is going to be one that produces basically a lot of power, a lot of thrust for the amount of weight. And so these may be situations where, for whatever reason, they didn't finish the run, but they still push that limit forward, what we normally get.
Portal Aircraft also might be in the running for that as well. Vertsolve, one of our guests, Kevin Horn, was on with us yesterday.
Yeah, that hybrid power system with the turbine driving the generator, charging a battery. Sounds like more complicated would be worse, but this is a case where the weaknesses of one of those systems is offset by the strengths of the other. The turbine makes a lot of power, but is not very responsive.
Extreme Aerial out of San Jose, California. Another cool design.
It's a turbine-driven rotorcraft. Again, trying to see if these turbines can be scaled down. Normal turbine engines, they're extremely powerful for their weight, but they don't get small enough to work on craft of this size. So several of these innovators have brought them down into the size class here, and we may be able to take advantage of that additional power to weight.
So those could be potential candidates for that superlative award of $500,000 if they are deemed worthy enough. It'll be voted on. It's a secret ballot. JB, I don't think you and I even get a vote, do we?
I wouldn't presume to inject my opinion.
I got ideas, but I don't think they're going to ask for my opinion. So we'll see how it plays out.
Yeah.
Again, you can watch the awards ceremony tonight for the DARPA Lift Challenge on air at 7 o'clock Eastern Time. Most promising design. Now, this is another one, and there's a lot of cool designs out there. We'll see which one's most promising. Avadrone, I mean,
certainly in the lead.
Yeah,
so
if
anything's promising, the ones who got to first place certainly are promising. To me, the most promising design is like just overall.
Right.
You know, there's not any one thing we can point to that you did very well, but overall, you got a lot of promise, and we think you're going to get there.
How about Burl? That was kind of a cool design, right?
Yeah. Big wing, get it spinning around with the weight dangling underneath it. I mean, I give him looks most like a stealth aircraft for sure. I don't think there's any money for that. But
there's the Titan tracker hanging down well below.
And here it begins its spin. That's on purpose. That's not just for looks. It will spin like that, and that spinning large rotor generates a lot of lift.
This is Defend Tech's Australia by way of Moab, Utah. Maybe the lightest drone out there that did the most work.
For sure. They got in the air with, I believe, a 9-to-1 payload to weight ratio. That a 12-pound craft was lifting 110 pounds. Again, every drone expert in the world would have lost money betting on that.
And one of our favorites, just by design and the material they use, this is D Material out of Bedford Park, Illinois.
Yeah, D Material, that inflatable drone design made of Dyneema is the material. And they say they are the only ones in the world who are manufacturing frames like this. It being inflatable means it's very light, and you would think that means it's very squishy, but no, you can see there that craft jerking around and the frame staying perfectly rigid. That's a case where you got a solution in search of a problem, but if the right problem links up with that solution, somebody is going to be very, very happy.
So D Material, we thought we're going to go up and try to make a run at the 4-to-1 today, but we got some intel that they had some more technical issues that prevented that from happening. Another superlative on the board is the aerodynamic most revolutionary design, and this one is, wow, driftless. Let's put them at the top of the list as far as what we saw this week.
Yeah, aerodynamics, of course, the science and study of how air moves over surfaces. And although that's a pretty well-studied field, trying to find new ways to use existing technologies, making a whole aircraft out of just the rotor. That's the kind of thing that this most revolutionary aerial design would be looking for.
This was UMD, the team out of College Park, Maryland.
We also saw a lot of prop-driven rotors. Instead of driving the rotor from a central shaft of a large motor, you've got smaller motors or other propulsion sources on the wing itself.
Here we go, Stanford Online High School. Look at, they brought out Santa Sleigh from the West Coast, from Redwood City. Didn't see a lot of success, but today we saw them get up and get some serious altitude. Doesn't look very aerodynamic, JB. Sell it to me.
Yeah, well, that is a stacked airfoil design. So each of those little fins is itself a small airfoil, and the idea is that by dividing that surface up into multiple little airfoils, basically you get a situation where the sum is greater than the whole of its parts. And you don't see a lot of people trying to commercialize stacked airfoils, and I think it would be certainly a memorable moment for these high school students out of Stanford, California, to win one of those prizes.
We are T-minus 30 minutes in the final flight window. This is driftless out of Neenah, Wisconsin. Now, they've got some special writing on there, and I'm going to see if we can't get it. Try to hit me, or
try to hit me.
Catch me if you can. What? Well, we're being told that Driftless is offering up their services to go up in the air and let the counter folks see if they can't bring him back down. Turn the Raptors loose.
Yeah.
How
the Raptors. So the Raptors are the team whose job it is to make sure that any aircraft that excessively violates the geofence, if they don't come down willingly, they come down unwillingly.
So basically it's a situation if they lose control of something.
Yeah, well, it's a last resort. Let's say that. It's a last resort where if an aircraft went outside the geofence and was not coming down, it would be brought down. And here,
how
it seems
bad
like,
do you want to see that?
Well, I mean, I want to see it a lot. I think it's going to be hard because if you think about it, how much is there on this aircraft to even hit, right? It's just rotors and they're spinning. And so
not a lot of surface area.
These guys are going to have their work cut out for them. I think it's going to be awful fun to see them make the attempt, and it's a real privilege. You just don't get to see this
Well, we saw something similar to that at Flight Fest. With the aerial destruction derby.
We did see that.
They put up 70 RC planes at one time and said, go get them.
I mean, we could put this thing up and let the Flight Fest guys come over here and I'll try and hit it.
Yes.
The thing is, when you've got 70 radio-controlled aircraft in the air, and they're all trying to hit something. Well, just by the luck of the averages, somebody's going to do it. In this case, we have one craft in the air and one counter-UAS aircraft that is going to try and take it out. And that pilot, well, if he gets it on the first try, he's going to feel mighty good about himself. And if he has to take a couple passes, I still think that's fair.
I guarantee if we open an online voting of who wants to see this, I think it'll be 100% agreement.
The folks who stuck around for this part of the live stream are in for a real
bringing the
treat.
country together right here on this. Everyone's going to be
Everybody
everyone's
loves
going to be in
destruction.
agreement. Everyone wants to see this. But that's a time situation. So if we do have time, we'd love to get in and see that. But no promises. But I do like the fact that Driftless went to the effort of just sending out a little trash talk.
Yeah, little trash talk.
Aerodynamic trash talk.
And it's going to be, if we do get to see this, if there is time and if it does work out, it's going to be a little bit of a relief, because this whole time we've seen crafts crash, and, we've been like, oh, gosh, it's heartbreaking for that team. Oh, they learned, everything's going to be okay. And finally, we'll get to potentially see a crash that everybody's in on, and everybody's just out there to see the carnage.
Well, there is the scene here at the National Museum of the United States Air Force. This is the DARPA Lift Challenge in Dayton, Ohio. Day number 7 is almost done, and that will wrap up the competition. JB, I don't say your final thoughts, but from what you heard when you first contacted about being a part of this and to where you are today, what has changed and what have you learned?
The number one thing that's changed is that when I first heard about the DARPA Lift Challenge, I looked at the fact that modern aircraft tended to be around a 1-to-1 payload-to-weight ratio, and they were asking people to quadruple that. Like Luke Bell, I crunched some numbers. Now, he's much more of an engineer than I am, but I crunched some numbers and I said, I don't think it's possible, my first reaction. And then I thought maybe it is possible. The difference between me and Luke Bell is he came out and built a drone, and I went into the broadcast booth to commentate. The biggest change for me is I believe that this can be done. We know for a fact that a 3-to-1, multiple teams have done it, and I still think with just a little more work, we're going to see a 4-to-1 at some point in the future. Somebody's going to do it just to prove that they can, even if it's not here at the DARPA Lift Challenge.
Well, Don and his team certainly have lit the fire of ingenuity of what is possible, and like a lot of people, Joshua Bardwell did not think that was possible, not because he didn't have faith in America and people putting things together, but it just didn't seem right. And you said you crunched the numbers. So obviously when the call was put out there, everyone said, oh, we think we can do it, and Donna gave me the opportunity to be at a place where they think they can do it.
That's right. Give them a place to prove me wrong. And, oftentimes I think the surest way to get something done is to be wrong publicly. And somebody will be like, oh, I don't like him. I'm going to do it. So if I could take any little bit of credit for this, I certainly will.
Well, we're coming up on the final 20 minutes now here in Dayton. And we'll see if anyone's going to get up in the air and put on a little bit of a show for the folks here still at Fan Fest on the 7th and final day of the DARPA Lift Challenge. A lot of people have traveled across the country and around the world, and we'll see what happens. But if we have an opportunity to put up the leaderboard right now, we can show you the top 5 and where they stand. And this may be almost official, JB, as we come down to the final few minutes of this one. There it is. Aviadrone on top, 3.84. They are the leaders. Second place belongs to MTech at 3.64, and third place belongs to Extreme Aerial Concepts at 3.45. Just missing out on the big money is H Squared in 4th and MacGyver in 5th.
Yeah, all of those teams going home with half prizes for breaking the 2.0-to-1 payload to weight ratio. It is starting to look like Donna's going to have to give some of that money back to the government, but well, if you didn't do it, you didn't do it.
I think we got time for one more guest. Let's bring in, and I hope I get this name right, Jakadowski. Peter Jakadowski from Extreme Aerial. You guys are currently sitting in 3rd place.
Yes, we are.
You're in a situation to make DARPA write you a nice check right now. Give us your feedback and what you thought of this whole 7 days.
Well, we are excited to be here. We arrived already on Sunday. We did our first flight on Monday morning, and to my knowledge, I think it was the first cohort flight. And we played it the conservative route. So we started with 110 pounds on Monday and adding another 20 pounds every other day. So on Wednesday we were out at 160, on Thursday at 180, and today we did an excellent run this morning at nearly 200 pounds. So to my knowledge, maybe we are lifting the most weight, but due to the rules and because our craft is a little bit heavier, it's a third place, but it's fantastic to have chances for the third place, so I'm really happy.
Talk to me about that decision making. We've been looking at how teams have decided how much weight to put on and what ratio to go for. How do you know how big is a big enough step, big enough to increase your standing, but not so big that you overstep and fall out of the air?
Well, we did our home studies, of course, so the whole thing started in February. We did a lot of test runs. I, for myself, I'm coming from Vienna, Austria, so we produced those turbine engines, and we produced a souped-up version of what we had available, and we did a lot of test runs on a dyno, on some crafts, and so on. And we saw it's pretty easy to make the first step. So to go, let's say, to 100 pounds, from 100 to 120, but it doesn't go forever, because there's coming up a certain point, let's say, at 150, 160, so every 10 pounds, every 5 pounds, it's a major step, and you've got to be careful.
Yeah, how do you know where that step is?
Well, we read out the turbine temperature, so the EGD, exhaust gas temperature, and the torque on the turbine. We have a telemetry system, and we see what's going on. I'm coming from full-size helicopter flying, so search and rescue, cargo hold, and so on. So I know a little bit about it, and I bring all those ideas into this drone technology, and I have the experience, and I hope we proved that it is a reliable system.
Has this been a learning experience for you as well? I know you guys came in with a lot of technology to that, but you go back thinking we are that much farther ahead now.
It was a kind of a learning experience. I mean, we had the idea to combine the step-down gearbox inside the engine. So we are more or less the only ones that combine a turboshaft engine with the gearbox. And so it ended up in a design which is just 8 pounds, that size, 23 horsepower, continuous 24 transient. So the leverage is very high, the power density is extremely well.
Yeah. How does that compare to other designs out there in terms of the power to weight?
I think power to weight is leading, especially if you compare to any piston engines. If piston engines are normally maybe, as I said, we got 3 horsepower per pound. Piston engines maybe got 1 or 2.
Oh, wow. That's a big step.
And pretty often to be air-cooled piston engines always could suffer in a helicopter solution because you need constant power and the cooling is always a problem. So maybe it's better to go to some liquid-cooled engines, but then you've got the radiator, the fan, the cooling, everything. If you go in freezing ambient conditions, you need some antifreeze in it, so it gets complicated. And as you see in full-size aviation, let's say cargo hold or search and rescue, I mean, already back in the 60s or 70s, we saw there's a big change, and there's nearly no commercial aircraft available anymore that doesn't have turbine power right now in full-size aviation. But it's different, of course, with the drones.
Peter, do you expect a big response from this competition? I mean, is your phone ringing off the hook on Monday?
Yeah, I hope so. I mean, on Monday I'm actually going back home to Austria, so I'll be in the office on Tuesday. But yeah, I hope so. I got already a lot of emails right now, and there's a lot of folks and people talking to us because it's an interesting technology. And what I liked so much is that at the very end it was a challenge between electric and more classical, but still refined, new thought turbine technology. And I think that was a very good idea. And I think DARPA and Donna did great just to have the opportunity to show that and what's going on here.
Do you think the parameters were right? The distance you had to go and the weight, the maximum weight and the 4-to-1, do you think it was right on point?
Yeah, I think it was. It was a challenging ratio. That 4-to-1. Now, but we have seen a lot of crashes the last 2 days. So as soon as the ratio went up above 3, it was a little bit dangerous, even flying in a lane, because we heard crashing left and right, and so we had to be careful. What was a little bit tough for us is flying out all the way, and the aircraft is very far apart. Because if there happens something, it is really difficult for the pilot to take over and bring it back in. We did all our test flights standing in the middle and going left-right. But of course I understand that here, because of those many participants or so, you have to go in parallel and all are standing there. But it's really impressive if the craft comes over you and it's turning there and it goes back in. So I was impressed by myself, although I know that turbine stuff already for decades.
You know, a lot of people were hoping that someone would say, just damn the results, I'm going for 4-to-1. Talk about the decision to do that versus maybe we're going to play it a little bit safer.
Well, I guess 4-to-1. Also, at the very beginning with our calculations, we saw it's hard to go there, and we've seen it today. I mean, many teams tried it very hard, and so it's quite risky. So, but I think 3-to-1 is an excellent ratio, because when I do some full-size flying, normally it's 1-to-1 or 1.2-to-1. I'm flying the Llama back home. I mean, it's a very capable helicopter. I mean, it got 1 ton. I have to be on board. I got 200 pounds. I need another 200 pounds of fuel, and then maybe I can lift 1 ton of cement or whatsoever. But this is about the limit, and we've got to be careful, especially in higher density altitudes. We are pretty low here from mean sea level, but it's very humid, it's very hot, and so it's tough for every motor. For piston engines, for turbine engines, for every engine.
We've debated how much the weather affects the performance, the density, altitude. Would you say the weather had a major effect?
Yeah. I mean, if there would be temperatures, let's say in the 50s or 60s, and it wasn't so humid, we could pretty easily show the 4-to-1 ratio. But you know, I'm more a conservative guy, and I think we are better off maybe with the 2nd and 3rd place at no crashes, because we didn't do any crash, no issue, no instances so far, so we are happy with that.
That sounds like something that someone coming from full-scale aviation would say.
Yeah.
Not like us drone pilots who just crash at the drop of a hat.
I know the public likes the crashes.
Yeah.
But we like to be crash-free. So.
Other than your team, Extreme Aerial, are there any teams that you've been impressed with? Any designs that you've seen and you're like, you know what, I kind of like that one? And it's okay, no one else is listening. You can just tell us.
Avidrone is very impressive to me, because I never thought an electric craft can do this.
Nope.
MacGyver was trying very hard, many times, so I was pretty impressed. And also the MTech guys, I think they are affiliated or coming from MIT, if I'm correct. So
would you
very impressed.
Would you ever have believed that a 12-pound aircraft could lift 110 pounds?
Absolutely not.
Absolutely not.
Maybe, I think they just flew maybe 1 or 2 minutes, but I never ever believed they could fly 1 second.
Yes.
So I was really impressed.
Okay.
It was great.
You're much more of an established engineer than I am. I'm a little bit of a hack, and I'm glad to say that you agree with me.
No, I think, Josh, I think you have excellent experience, because I'm listening to you now for many days. To be honest, coming from full-size aviation, please regret I didn't know you so far. I just.
Well, maybe we'll get you into FPV drones.
But everybody told me you have such a great name, and so it's great to be here, sitting next to you.
Well, it's great. Thank you.
Hey, Peter, thank you so much for being with us. We appreciate it. We congratulate you. We still have unofficially another 12, 13 minutes, but it looks like you guys are going to be receiving a nice little infusion of cash for the company.
Thank you so much. Hopefully no surprise shows up in the last 12 minutes.
All right, that is Peter Jagodowski from Extreme Aerial. They are based in San Jose, California, and they are currently sitting in the money in a top 3 position. So we wish them very best as we tick away these final few minutes here of the final flight window here at the DARPA Lift Challenge. A lot of good intel from him, JB, and I think it was most interesting in him talking about how the weather affected them and his appreciation from some other teams that had some great designs.
Yeah, we've debated whether the density, altitude, the difference in temperature over the course of the day could have an effect on the engine's performance, and he confirmed that it definitely could have had some differences. It also made me think, I'll bet that the turbine engines and the piston engines are more affected by the density, altitude, and the temperature than the electric engines. Donna talked about that a little bit, and it just makes you think how potentially different environmental conditions and different test conditions could have affected the results of this competition.
Well, unofficially, we are 12 minutes away from closing the DARPA Lift Challenge. I would love to say the first annual DARPA Lift Challenge, but this is kind of a one-off, JB, and there's really no plans to do another one next year at this time, but I think it would be interesting to see if they did this, maybe raise it to 5 and take it into a cooler temperature or somewhere maybe more forgiving time of season.
Yeah, the folks from DARPA have been here and they've talked about how they don't like to get too comfortable. They don't like to just have somebody say, I did the thing and I'm just going to keep on doing it. They like to keep pushing and innovating and iterating. And so I think there's no chance that we'd see another DARPA Lift Challenge exactly like this, but there definitely has seen a lot of value come out of this in so many different ways, in so many different directions. I think there's a lot of attention being paid to what could be done next, sort of in this vein.
So the activity is slowing down on the flight line as we are coming up on the final 10 minutes of competition here. And there is Driftless. They are a volunteer to be taken down possibly by counter UAS. They have decided to go up and mock them. You missed it. Give us a chance. You can't catch us. They're just talking aeronautical trash right now.
Yeah, for sure. This counter UAS, you think about, well, if you have an aircraft, a drone, and it has gone outside of the safe area, and the pilot is not able to bring it down or is not bringing it down for some reason. How do you bring it down? And well, you just use a drone to take down another drone, right? And hopefully we'll get a chance to see that here. Very rare because this is not something that you normally would do. Maybe with those little toy aircraft, just for fun.
Think of it as our farewell gift to you. It's kind of like the finale of a fireworks show.
Oh, yeah.
We're going to send things out with a great show, and so we appreciate the good folks at Driftless for showing up and saying, you know what, you can send us out there.
Yeah.
We'll be the.
Well, they don't want to bring that thing home. Look how big it is.
It's too much to travel.
You ever leave something behind in your hotel room because you're like, I'm not packing that.
No, absolutely.
Yeah.
Absolutely. So the final 10 minutes of the competition, and I think back to what happened on Thursday morning at the 9 a.m. first window when we first came on air. Obviously, there was competition taking place earlier than that, but when we first came on Thursday, that's Thursday, Friday, Saturday, Sunday, 4 full days of, I don't know how many flight windows, but there were a lot. The competitions, the crashes, the emotions, everything we saw, JB, it has been fantastic.
It's been fantastic. I have seen things here. I remember walking around my very first day before we started broadcasting and just walking through the hangars, mouth agape at the things I was seeing. You know, you do this long enough and you just think you know what a drone looks like, what an airplane looks like, what a helicopter looks like. I saw stuff in here that looked like it was out of a sci-fi show. I saw stuff in here that looked like it was out of a 5-year-old's crayon sketchbook, and we saw all of it go up in the air, fly, and make an attempt at doing something that has never been done before.
I felt like such a negative Nelly the first couple of days. I'm like, that can't fly. That can't fly. There's no way that can fly.
Yeah.
There's no way that can fly and carry weight. That can't fly.
Yeah.
And proven wrong on every single account. So thank you.
Yep. Thank you. You know, I like being right. I wouldn't surprise you to learn that I like being right.
No.
But I like being wrong as well when I'm wrong in a way that produces, such a result but pushes innovation forward. If I say it can't be done and you do it, you got nothing but a firm handshake from me.
It's like Happy Hellfire is back under the prep area, and not seeing a whole lot of activity on the line as we are under 10 minutes officially. 8.5 and counting until they will close it down and the flight line will go cold.
For the last time.
Yeah.
For the last time for this event.
I think Donna's going to sleep well, right?
Oh, man.
I mean, these last 7-8 days, actually the last 11 months for him have been a bit chaotic, and his entire team. And here we go. Driftless is coming out. The sacrificial lamb.
What does it say on that wing? Something again? Try again, maybe?
Try again.
Got X's on there to help them.
Try again.
Missed us. Try again. You know, I said earlier that this reminds me of those toys you had where you spin it between your hands and the helicopter blades go up in the air. And I had such a sentimental feeling as I watched it fly through the air, slow and graceful, almost seeming to defy physics.
If we're going nostalgic and we're talking about great memories, you remember those jet rockets, clear plastic, and you filled it with water, and then you pumped it up as much pressure as you could, and then you hit the button, and it just.
I'm amazed we didn't see one of those here.
Yeah, something like that.
Maybe
that was Spitfire. Maybe that was Spitfire. So good. So good. Thank you so much for educating me and the rest of the folks watching. You have been fantastic. They certainly got the right person for the job. And all I can say is, folks, if you want to get into drones, if you want to learn about drones, if you want to know anything about drones, you head to Joshua Bardwell's YouTube channel, and you will get educated.
Yep, that's what I do. I say, you're going to learn something today. Just like I've been hopefully teaching some of the folks here about aircraft and drones. And Todd, also, I'll give you a compliment. For a sports broadcaster, you did pretty good for your first drone broadcast. I think you might have a future if sports doesn't work out for you.
As a drone pilot or just as your wingman?
I don't know, as a pilot, Todd. Let's not get crazy. But as a broadcaster, for sure. You want to learn about drones? I'll see you over on my channel. I think you'd have better odds of becoming a drone pilot than I would of a sports broadcaster.
Want to remind you also, we still have the awards ceremony. That's coming up later tonight. If you're not here, you can obviously watch it. That's at 7 p.m. Eastern time. We've also got the FOD walk coming up. That's the foreign object debris walk, and that is kind of a traditional send-off where the crew will be down there and they will be looking for any small objects that can have big consequences, a screw, a piece of metal, anything like that. FOD walk is obviously prevention. You want to do that, and they want to be good stewards of the fine
Yeah.
folks here at the National Museum, the U.S. Air Force, and the DARPA people are going to make sure they leave it as nice as they found it, and everyone just owns it, and it's a part of the aviation culture.
Yeah, it's more than just like, oh, if we leave a piece of debris out here, it could get into an aircraft engine. It's ceremonial. It's a part of community, and it shows their commitment to attention to detail. You know, aviation is one of those disciplines where preventable mistakes have to be avoided at all costs, and attention to detail is important. So in addition to just cleaning up the flight line, you're also reinforcing that and having a nice community moment.
And there's no way I can confirm or deny that Donna's going to be out there replanting and resodding the burned areas as the scars. I think you leave them. It's a nice little reminder, a little souvenir.
Well, I know they've made arrangements with the National Museum of the Air Force exactly how they're going to clean this up, recondition it, and put it right back how it was before they got here.
I've heard some crazy things from people that are here, part of the Orange Army, is they're going to have this thing pretty much stripped down in the next 3 or 4 days. It will be like it wasn't even here. And I tell you what, you walk around this massive facility, the number of trailers, scaffolding, tents, golf carts, all that stuff, that all has to get up and go, and they're going to get in and like that get it done.
You know what will remain, though, is the National Museum of the Air Force.
Correct.
An amazing museum. If you're in the Dayton area and somehow you didn't get a chance to head over, it is well worth a look. And if you're coming to the Dayton area, you should definitely make time to go there. So many historic aircraft.
Go see a Dayton Flyers game and then pop on over and see the National Museum of the United States Air Force. This is Ratio Drones out of Austin, Texas, and they just want to be the last ones. They
want to be the last ones in the
kid
air.
in the pool.
Yeah.
They say the pool's closed. They're going to be the last one. Get the last run on the ski resort.
Mom
says,
says, hey, the street lights are on. Come on home. And this one kid says, nope, I'm not coming in.
I'm coming in until those lights go dark. So Ratio Drones, they are going to try and get the last possible moment of glory here at the DARPA Lift Challenge. Again, we've got the FOD Walk, which we'll give you a bit of coverage of. We'll have our final thoughts. We'll send you off at 7 o'clock for the awards ceremony. And if we haven't said it already, thank you again to the good folks at DARPA, the folks in the orange shirts, the folks that made this all possible, the security, everyone that came in just did a fantastic job and a magnificent effort. And it wasn't always easy. Some hot days. The people that are doing the cleanup, the people that are doing Flight Fest, thank you. Big thank you.
Yeah, for sure. Thanks to the public who came out to witness this. I've gotten to meet a lot of people who came out to see this competition, came out to Flight Fest, and of course also thanks to the competitors who put in. You might say, well, gosh, they're going for the cash prize. Obviously, they had something in it for them, but so many people came out here who didn't need to come out. So many people came out here, without regard for what they might get out of it, just because they wanted to experience it. They put in so much work, time, and money, and gave us such a show.
So there is Driftless waiting to receive its fate. And I have a feeling, JB, that the counter UAS folks, they're really chomping at the bit.
Oh yes, they're hungry,
salivating.
They're hungry.
Just get a chance to knock these punks out of the sky.
Yes, so's our audience. Hungry. I mean, if they don't know what they're going to see, they're in for a real treat.
Happy Hellfire. They are loading up, so they are done for the day, and we are just waiting for Ann Bush to give us the all clear, all cold, and the competition will officially come to an end, and the flight window will close.
Yeah, Todd, and speaking of the counter UAS team, obviously you never want to have to be. You want everything to go safely, and you never want. But on the other hand, if your job is to do counter UAS things, and the whole event, as far as I know, they haven't had one opportunity where they had to actually go up and do their job.
Themselves.
So they've been sitting there. And then somebody goes up in there, and they're like, okay, ready? Nope, everything was fine. And so this is their one opportunity to actually do what they came here to do.
They are the personification of hurry up and wait.
Yep.
As they are here every day, anytime any drone's in the air, they are there, they are ready to go. Hopefully we don't need them, and we have it so far, touch wood.
Yeah.
But we are coming up on the final moments, and the countdown can begin as we are under 2 minutes away from the competition being called.
Yeah, no pressure to that counter UAS team. Obviously, that's their job. We're going to see how well they do it.
Happy Hellfire is going to take a happy ride back to their prep area, and they'll begin to pack up. I imagine the Dayton airport tomorrow, the baggage handlers there, they're going to see some interesting things coming through.
Some of these will pack down a lot smaller than others. Nice that that Happy Hellfire gives you a little bit of shade.
Yeah.
You don't get that with a multi-rotor.
Quick odd question. When you travel with a drone? Do you ever travel with a drone? And how is it getting it through TSA or packaging?
No, my drones are a lot smaller than these.
Yeah.
So typically I'll have one drone with me if I'm going for work, because if my check bag gets lost, I need to show up ready to do my job.
Yeah.
I'll have the rest of the drones in my checked bag, and then you got to keep your batteries with you, which surprises some people, but the theory is that if a battery did have a fire during a flight, you want it in the cabin where you can deal with it rather than in the cargo hold where it kind of is going to do its own
Unless
thing.
I'm sitting next to you, then
But yeah,
maybe
it's
not so
really,
much.
Not really an issue. They do swab the batteries every time. They look at them very suspiciously. They swab them, and they say, okay, everything checks out.
They always ask you, what's this for? And you say,
it's a drone battery.
Please,
Yeah.
I'm Joshua Bardwell.
They say, I'm Joshua Bardwell. Do you know who I am?
So the flight window has now closed here at the DARPA Lift Challenge, and it's time to unleash the Raptors. I think before we do that, we got to get Driftless back up and
They got blown over by the wind.
I do not think they'll be able to start up at that position. Right? That's way too easy of a target.
Yeah, no.
I could hit that.
On the ground.
Yeah.
Oh, I'll tell you what. I'm going to give you an FPV drone. Let's see if you hit it.
Yeah,
not so easy, is it, Todd?
Pressure's on. All right, so it has gone official, and we can now share with you the top 3 teams that will be awarded a cash prize for their efforts. No surprise, they were consistent all week long, and they stayed right around the top 3. Aviadrome, MTech, and Extreme will be walking away with the big cash prizes here. No one hit the 4-to-1 payload to weight ratio, so that 2.5 becomes 1.25. That goes to Aviadrome Inc. with a 3.84 payload to weight ratio. MTech finishes in second, just behind it 3.64, and in third place, Extreme Aerial Concept 3.45, just missing out H Squared and MacGyver as they finish in the top 5.
Yeah, just amazing results. Amazing results. Good results for these teams.
Yeah.
They got to be happy to be going.
And then the other 3 will be superlative awards, which will be worth each $500,000.
And we will find out about those at the closing ceremony tonight at 7 p.m., which will be live streamed.
So look at this. Driftless is trying to spin up. This is lane 8, final flight of the day, as the Raptors and the counter UAS team, they're going to show off just a little bit.
Heck yeah.
I don't want to put too much pressure on them, but they better go one shot, one hit.
What do you think, Todd?
One shot, one hit? I think they get them on the first shot.
Maybe miss. Those blades are not very big targets.
No,
they're very small and they're moving.
Look at the taunting. Come on. The taunting's not going to help their cause.
We're looking for those small props on the main rotors to start spinning. It will start going around and it will lift off. Just wait.
Do they have, is this something where they have, they can lock on by signal, RF signal or something like that, or heat-seeking signal, and maybe go for the Titan?
There's various ways to go about that. Whether you do it manually, whether you do it with some kind of autonomy, we don't know exactly what they're doing.
Look at this, Driftless.
There we go. Now it's under control.
I feel like saying thank you for your service, but
thank you for your sacrifice.
We got to get them up first. So how high do you think they're going to go before we unleash the counter UAS?
I don't know. We'll know when it gets in the air.
I feel like saying release the hounds, but it's
release the
Raptors.
Raptor.
Yeah. Here we go.
It just shows
spinning
the
there
spirit
up.
of these pilots. The spirit
Here
of these pilots. If it produces a good result, let's crash it. Let's break it. Let's learn something.
Come on,
let's
Driftless.
Just do something fun.
Driftless is up. And right now they're calling up the Raptors saying, we got danger. We got danger.
We got a target in the air.
Driftless is up and flying.
It doesn't look like Driftless is going to make it easy for them. They are not just going to hover in place. It looks like they're moving. Maybe they're just moving to position.
They're at 91 feet and climbing. Hit 100. I'm calling in the dogs. Release the hounds and the Raptors. Raptors have launched.
Let's see what we see. We may just see a tiny little speck on screen.
They're trash talking the Raptors. You don't want to do that.
Yeah, these Raptors are going to be pretty fast moving. We'll have to see what we have to see.
Driftless. Driftless. Here we go.
There
in view.
There's the Raptor. Driftless saying, come get me. I'm a big lunch. Come eat me. With that taunting.
Look at him. He's going to size him up.
Right through the rotor blades.
Right through the rotors?
I told you, it's hard to hit those blades. He passed through that disc. Two of them up there. 3 of them.
What if Driftless chops him up?
I think Driftless just smacked the Raptor.
Oh, he got one.
No, Driftless just knocked the Raptor down.
So it's Driftless 1, Raptors nothing.
Oh, my goodness.
Oh, look at this. Oh, it clipped him twice.
There we go.
Yeah, the Raptors are just having their, it's like piranhas. They are just.
Oh, one of those struts gone. And as we know, when one of those goes, the others are stressed. It becomes imbalanced.
Oh, they're not done with them.
The
They're
whole
not done
thing
with them.
falls apart. We saw that Raptor get knocked down, but it got back up again and made another hit.
Look at Driftless. It's still in the game, and they are losing.
Driftless.
It is coming back to earth. So the Raptors did their job.
That's right.
Didn't go for complete destruction, but they did what they had to do, and they brought Driftless back down. That's an ego check right there.
Oh, who would have thought that little guy wire would be the thing that they finally would have broken?
The smallest thing on board. So thank you very much to the counter UAS folks, the Raptors, as they did their job, saved us from a rogue Driftless who offered up their opportunities. And let's take a look one more time, JB. The final time I'll ask you to break this down and tell me what went right.
Oh, man. Oh, we see that Raptor coming up and hitting, knocking pieces off. One of the things that's interesting about these Raptors is they are reusable. You saw them making multiple strikes and coming back for more. If the first one doesn't do it, there's more to go.
Well, they did their job, and they brought Driftless back down and put their egos in check. So thank you, Driftless, for going up in the air, and thank you to all the teams that participated here at the DARPA Lift Challenge as we are getting ready for the FOD walk, which will take place again for an object debris walk. They'll walk through with a group of the Orange Army, and they will pick up anything and everything that could damage an aircraft or create a safety hazard, especially small objects, which can have big consequences. It's an interesting thing for the viewers is this is one of those things happening behind the scenes that they probably never think about when they see an aircraft take off.
Yeah, we've certainly left a lot of debris out there in the field with all the crashes we've had. Of course, under the watchful eye of the safety team. You know, you're going to push boundaries, you're going to break some things, but definitely going to get that cleaned up and make sure that any aircraft coming through here are safe and don't have any problems.
So in case you haven't heard, the flight window has closed and we are complete here at the DARPA Lift Challenge. And the folks are lining up to do this FOD walk. Really, it's a personnel systematically inspecting the operating area, and they'll go and pick up anything that could potentially reach a hazard. So there's the final leaderboard. It is Avidrone that will get the top prize at 384 payload to weight ratio. MTech will finish in second place at 364, and Extreme Aerial Concepts will finish in third. Tip of the cap to H Squared, MacGyver, and the other teams that showed up. To think about the numbers, we started with well over 480 teams that were basically applying. 130 plus got the cut, made the cut, and somewhere in the 70s to 80s, they showed up and put on the show.
Yeah, and now we have 3 of them.
Yep.
That made it. 3 of them that made it over a 3.0 payload to weight ratio, which, as you remember, Donna said when he was planning this, some people told him 3 to 1 wasn't even possible.
Well, 2 went over 3.5 to 1.
Yeah.
So they will be on tonight. You can see that again. You can live stream it at 7 p.m. Eastern, same place where you've been watching us all week. The winners will receive their trophies, and superlative awards will also be revealed, and that's coming up later this evening from the National Museum of the United States Air Force here in Dayton. It's worth looking at one more time before we say goodbye. The teams that were certainly pushing the limits, Joshua, it was Avidrone. Obviously, they went for a 402, as did MTech a 402. Defentex went for a 611.
Don't forget that Defentex also got in the air just for a little bit with a 9 to 1.
Avidrone also went for a 405, and MTech also went for a 404. So did not rest on their laurels. They didn't say, hey, we're in the top 3. That's good enough for us. They really pushed it, and in some cases, at the detriment of their drone.
Yeah, and I'm going to be keeping an eye out over the next few weeks and months because, like, if I'm Avidrone, I go home, I take a breather, I sleep for a couple days, and then I start thinking, I'm going to try to do this. I'm going to find a way to make this happen just for my own gratification. So.
Yeah, and MTech went, what, 2.99?
Yeah.
Kind of just ran out of time and battery.
Yeah, and it landed because they don't know why. I mean, they could have just kept going.
He said they still had battery.
Yeah,
they still had battery. What could have been?
So, yeah, well, eventually you got to call it.
Yeah.
Say, okay, that's enough attempts. But I have a feeling all of these teams are going to, like you said, their phones are going to be ringing off the hook with people who are interested. and how far they got and what they accomplished here.
Can folks get some breakdown of this on your YouTube channel? Can people get a recap of what's going on? Will you be posting material?
I certainly would like to.
Okay.
I certainly would like to. I mean, I feel like there's a lot of opportunity to put some of that out there, but we have to see.
Very proprietary, so you can't unveil what you can't unveil. But I think a lot of people would be interested, even just getting your take on what happened this week. And is this, I would think, a positive thing for moving aviation forward?
Oh, well, yeah, for sure. Definitely positive.
All right, so we are just waiting for the FOD walk to commence, and that will kind of ceremonially bring this event to a conclusion. The fans have made their way towards the turnstiles and are beginning to head home. But again, thank you so much for everyone for tuning in, for watching, for sending in your comments, your questions. We read them all. If we didn't get them all on air, didn't get to them, we apologize. But great interest has been on Dayton, Ohio for the last 7 days, especially for those folks who are involved in drones like my partner Joshua Bardwell, and for those people that want to see the improvement of aeronautics and aviation. The FOD walk begins shortly, and again, one last reminder, the award show will begin at 7 p.m. Eastern, where the winners will receive their trophies, and you can find out who wins the superlative awards, and that will be revealed, the $500,000 as well. So, for the last time, we will say goodbye. Todd Harris, Joshua Bardwell, Elena Buenarostro. Thank you, sir.
Thank you,
That was
Todd.
a lot of fun. Appreciate it.
Sure.
What do you say we do it again sometime?
I'd love to.
Just call Donna. I'm sure he can whip something up that we can chat about. What a week it has been, and today certainly did not disappoint on the final day here of Super Sunday at the DARPA Lift Challenge. We welcome you to Dayton, Ohio on a beautiful day here as we get ready to make history in the world of aviation.
Excited to do something that flies. Ready to rock and roll.
We got a real shot to win this thing.
We're excited to be here. We're here to fly. We're here to break things and find it.
Now that they're finding out just how hard this is.
We do have liftoff, so here we go.
We push the limits, and that's one of the exciting parts about this event.
It's not what you already know, but what you don't know.
Initially, we had really crazy ideas, but then we realized, that it's not so easy to do.
And we're, believe it or not, flying better than ever. Oh, he's going to put it right in the center. Now you're just showing off.
The first time you fly, if you crash, that's kind of like the start of the story. We're not quitting here.
We thought we could learn a lot just from being here and seeing what worked and what didn't.
So we're flying right now. As you can see in the background, it's up in the air. We're doing... Well, you win some, you lose most.
You got to stop giggling.
What just happened out there?
We're testing the limits, so we found it.
This is kind of a dream come true, to be honest. I can't emphasize enough how friendly everyone is here at this competition.
People just laughing and having fun.
It's the biggest drone and the weirdest drone I've ever flown, but yeah.
This is my one opportunity. I will never get the chance to build a 150-pound drone.
I think it would be cool to work this up into some sort of firefighting drone. In some way, I'd like to save lives with drone.
You could use it for your business. You could use it for rescue missions.
Coming here is part of the journey.
Teams pushed the limits. Some came incredibly close. We saw just how hard it is to achieve something that has never been done before. What a powerful example of American spirit. The courage to try, the determination to fail forward, and the resolve to keep pushing. That's what this week in Dayton has been all about. Thank you for watching.
Flightline, be advised the DARPA Lift Challenge flight windows are now closed. I repeat, the DARPA Lift Challenge flight windows are closed. That's a wrap.
Back in Dayton now, it's time for the FOD walk, or the Foreign Objects Debris Walk. Anything on the ground at the flight line that does not belong there and could damage an aircraft or create safety or a hazard, they are going to pick it up.
Yeah, that's right, Todd. Small objects can have big consequences. Anything left over from this event, a crash, a screw, a piece of metal, stone wire, even loose hardware, can become a serious problem. They get sucked into an aircraft engine.
Yeah, this is a definite military tradition. The FOD walk is all about prevention. Personnel systematically inspect the operating area and remove anything that could create a hazard, as you pointed out. But this is one of those things that Donna was very passionate about. He told us to get the crew out there.
Yeah.
Gives them a chance to walk the line and find anything out there. And it's, I don't say a bonding experience, but it's a nice piece of tradition.
Yeah. In aviation, safety is not just the responsibility of the pilots or the safety team. It's everyone's responsibility. You might even say it's part of aviation culture.
Yep. And they want to leave the field how they found it. So by picking up the pieces, they're returning the environment to the same way that they found it a week or two ago, before the competition even began. So see the folks out there, who knows, they might find a cell phone, an iPhone, or something like that.
You never know.
Your
A
Rolex.
souvenir,
Yes.
a piece of a drone. If I found something on the ground there, I might pick it up and put it in my pocket, take it home with me.
This is one of those things that happens behind the scenes that most people probably don't ever think about when aircraft take off. But Donna is out there as the head honcho, the program manager, and he's out there doing the pickup as well.
It looks like his burly shoulders right now, if I'm reading it right.
So this is kind of putting a cap on the competition as they do this FOD walk. As a former Harrier pilot himself, he is leading his Orange Army as they make the walk down the line, and they will pick up any small debris, anything that could possibly be a hazard. Of course, there's going to be some folks out there, they're going to be mowing that grass in a couple of days, and they don't want to leave any metal debris, shards, anything like that on the line.
I bet Don has participated in a lot of FOD walks through his career as a Harrier pilot. I wonder if this one has a particular meaning to him, being this event that he championed, he argued for, and he led and planned, obviously not all by himself.
Sure.
And now seeing it come to a close with so much achieved, it's got to be a really, really sentimental moment.
Look at that. That is the literal definition of the Orange Army making their way across the flight line.
I'd like them to come to my house and clean up the yard.
Jeez.
Find all that.
They get it done fast.
I got a lot of FOD in my yard, I'm sure.
They would get it done fast, no question about it. It looks like Fan Fest has also come to a conclusion. But we are focusing our attention here on the FOD walk here at the National Museum of the United States Air Force. We appreciate them loaning this facility to us throughout the week for the DARPA Lift Challenge here in Dayton. Another shameless plug, if you're in the Dayton area, this is worth popping by that museum.
Yeah, and Flight Fest. If you're interested in RC flight, and especially if you're in this area, but people come from all over the country to attend Flight Fest. One of the biggest our radio control festivals in the United States, and a great way to just find an RC community.
As we are coming up on 4 o'clock on the East Coast, just in about 3 hours, there will be the awards show. That comes up at 7 Eastern time. The superlatives will be revealed. The top 3 are there, and the top 3 teams will receive their trophies and their cash reward. That'll be live from the museum here, just right in the distance there as the FOD walk continues.
I'll finally get a chance to go over to the museum. I've been meaning to go all week. We've been working here.
Are you the keynote speaker?
I am not.
You didn't bring your tuxedo?
I did not bring
Dang it. I was going to go if you did. Yeah. Joshua Bardwell will certainly be there, so if you want to pop on, get some autographs and some pictures, he'd be happy to do that. And now they got vehicles involved, JB.
Oh, yeah. Yep, we see them walking the field. Everybody just walking in the line, looking down, looking for anything that doesn't need to be there.
So as this FOD walk wraps up, and we again thank the good folks at DARPA for making this all happen, I want to get your final thoughts as you look forward and go back into the community and people ask you, hey, how was the DARPA Lift Challenge? What's going to be your line?
Amazing. I saw so many things, and I met so many people inspired by the attitude that people brought. And just uplifting in every way. Makes me want to go to more DARPA challenges if they're all like this.
Yeah, they said that there's another one coming up in November, I believe, down in Texas. And it's going to be all about triage, so we wish them the best of luck. We hope it goes off without a hitch. I'm sure it will, because they do things so well as they continue to be great partners with the National Museum of the U.S. Air Force, cleaning up after themselves, picking up any foreign debris. FOD walk, that's where you get it. Foreign object debris walk, and they are going to pick all that up as a kind of a final gesture to not only the crew themselves, to the team at DARPA, and to kind of put a cap on this whole competition.
Yeah, this is not one last task that we have to do before
Sure.
we can go home. This is the opportunity to get out there as a team and focus on accomplishing one thing together. Just sort of put a capstone onto this.
So they have reached the limit, and that will put an official cap on the competition. Remember, tonight at 7 o'clock Eastern Time, you can watch the award show if you're in the Dayton area. Come on by. We'll see the top 3 teams receive their trophies and their checks, and the superlatives for the most revolutionary 3 teams will be revealed as well. So for the last time, from the National Museum of the United States Air Force, the DARPA Lift Challenge is now complete. We say so long from Dayton, Ohio.
Hello, hello. Wow. Echo, 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 echo. Seeing all you guys come in, it's amazing. I recognize almost everybody's faces. And if I didn't recognize someone, you didn't come to orientation. So let's talk about that first off. No, it's amazing. It's been quite a week. And on behalf of DARPA and the entire Lift Challenge team, I'm honored to welcome you tonight to the closing ceremony, where we will celebrate not just the conclusion of an incredible event, but the beginning of a new chapter in aviation. Slide. I forgot. Yeah, there we go. You know, it may have looked to you guys that everything went really smoothly, but can you guys make the font larger too? I can't read that well. I'm tired. All right, competitions like this don't happen by accident. They require a lot of expertise, careful planning, technical wizardry, long days, and an unwavering commitment to ensuring every team had the opportunity to demonstrate what they built. So let's all take a moment to recognize the people who made it happen. First of all, to our partners at the National Museum of the United States Air Force. The 88th Air Base Wing, whose 2 reps are here. Ma'am, sir, can you please stand? Your all support and belief in this mission were instrumental from the very beginning. Thank you to Flight Fest for adding to the energy and excitement by co-locating your amazing event with ours. To Lox Media, our broadcast host, Todd, Joshua, and Elena, thank you for helping us share our story with the world. And finally, to our own DARPA team, the amazing people that are sitting in the back there. Couldn't have done it without them. It was amazing. Thank you. And so many more. The Naval Information Warfare Center Atlantic Team, Oscar 6, Strategic Analysis, Chugosh, Code 19, and all of our military and civilian volunteers who showed up to sit in the sun and work on this event. Thank you for your time, the skills, and unique experience. And all of that is what it takes to create and execute an event that embodies the spirit of aviation. Please, once again, give me a round of applause for our partners, staff, and volunteers. Whether today ends with a trophy, a check, or simply another hard-earned lesson, each of the DARPA Lift Challenge competitors accepted a really difficult challenge. I want to start by thanking the teams and your families, who we all know may have suffered even more than you guys did. You invested countless hours designing, building, and testing, repairing, rethinking, and trying again. You willingly tackled problems that don't have known solutions. That willingness to push into uncertainty is exactly what the DARPA Lift Challenge was designed to encourage. Equally important, you did it alongside your peers, building a tight-knit community. From the camaraderie in the hangars, sharing your parts and pilots, to lending a helping hand to other teams in need, even offering up a laundry help. You proved that the spirit of aviation is collaborative, generous, and very much alive. Competitions launched when DARPA launched the Lift Challenge back in October of 2025. It wasn't simply to determine who could lift the most weight. We asked a much bigger question: how can we revolutionize vertical lift to make it a transformative, accessible tool for both the U.S. military and commercial industry? Sure, a 2x increase in payload to weight ratio would be useful, but we're DARPA. we aim to redefine the limits of what's physically possible. We set the bar at a 4x metric and expanded the innovation pool by opening it up as a general competition. Just imagine the future: flying cranes, massive agricultural operations, large-scale heavy resupply missions wherever you are. Those are just of the few sci-fi ideas that are one step closer to reality because of the innovations that you demonstrated. That's the beauty of challenges like this one. They compress years of innovation into months. They create a place where ambitious ideas collide with reality, where assumptions are tested, where hardware meets physics, and where failure isn't the opposite of progress. It is often the fastest path towards it. Aviation has a wonderful way of keeping us humble. Not every attempt ended exactly as planned. Some demonstrated that gravity remains undefeated. And a few spectacular contributions to what engineers effectively call learning opportunities. These moments deserve recognition as well. Please enjoy a special tribute to those brave machines that gave every last bolt in the pursuit of progress.
Whoa, there it goes. Oh, right on the hard. Oh, that hurt.
The cloud, no fire, but the cloud of dust just reminds me of the song. Dump, dump, dump. Another one bites the dust.
It's trial and error. It's crash and learn. We rebuild, we crash, we build again.
You gotta stop the other one.
That's good.
We've got a scoring run underway. I've got the sense and heard it from a lot of the competitors here that crashing always isn't this bad thing.
Yeah.
Progression is not always pretty, but it's progression.
Yeah, it is. It's a stepping stone to progress. You have to take risk in innovation.
Well, we've done more progression in the last week than before. It's, you know, it's trial and error right here in the actual challenge.
And celebrating that risk, not being demoralized or just saying I'm going to quit, is how humanity has gotten here, right? It's what we've had to do. That is the spirit of innovation. Yeah, that was pretty awesome. We will be posting that to YouTube later, so you guys can watch it over. Throughout this competition, we watched teams overcome obstacles they expected and plenty they didn't. Yet every successful lift, every recovery, every clever workaround, every unexpected breakthrough adds another piece to the future we're collectively trying to build. Less than a year ago, the DARPA Lift Challenge started with an announcement. The rules were fresh, the course was theoretical. Some of the systems we've seen this week hadn't even been imagined yet. More than 480 teams raised their hand with an idea. The majority didn't make it here, but you did. Now making it from concept to competition into DARPA Challenge is never guaranteed. As a Marine pilot, I can tell you the ambitious missions have a way of exposing every gap between the plan and reality. Things break. Assumptions get challenged. Ultimately, the field gets the final word. The teams here tonight pushed through all of that. The result was 76 systems capable of attempting something that before this week, no drone had ever done. So let's take a minute to recap a few of the highlights.
And we we welcome you to Dayton, Ohio on a beautiful day here as we get ready to make history in the world of aviation. What started out with 487 applications, 132 were selected, and we are down to 81 competitors on site ready to do something special.
Hold up. We're okay. Give me a second. I'm gonna get it. Oh my gosh.
3 days in the books, and we are 2 sessions down on day number 4. We had some great stuff, including a new leader.
So nice to see them fly.
That's a buttery smooth landing. You release the weight.
They're back up, and they have to do one more nautical mile.
Oh, he's going to put it right in the center. Now he's just showing off.
Oh, yeah, well, you got to do it.
We're testing the limits, so we found it, and now we know.
Aviadrone moves out in front with a 3.84 ratio. And we are set to go as we welcome you to day number 5.
This event has been so cool. I'm so glad we came out here and flew. We'll have to see what broke, figure out how we can fix it, and come back again next time they have a challenge.
That's just
look at
cherry
it.
on top of cherry.
Everybody's happy when somebody succeeds.
Handshakes all around, success. Nice, very nice on day 5. We welcome you to the National Museum of the United States Air Force as we get ready for another day of competition. We are flight loaded today with 63 flights scheduled. Flight window has opened officially here on day number 6, penultimate day here at the DARPA Lift Challenge as we get ready to go out on the flight line. Second place belongs to MTech Operations 364. They put that up today. Aviadrone out of Columbia, Maryland. They are at 4.02 on the payload to weight ratio, so history possibly be made here as we've got a scoring run underway.
Oh, no.
And I gave them the old announcer jinx.
Looks like the tail rotor.
Remember there. Look at this. This is 4.02. So
oh, no.
And it is still Aviadrone on top. They have the highest payload to weight ratio. Day 6 goes into the books. And that just leaves one more day. And we welcome you to Super Sunday at the DARPA Lift Challenge. The National Museum of the United States Air Force is buzzing with excitement.
Last day.
It's fun, huh?
Awesome. Didn't you hear me? I was like, okay, there, just caught it. That's okay.
At this time, please join me in welcoming DARPA Director Stephen Winchell to the stage.
All right. Can y'all hear me? So you'll have to forgive me because this speech is not going to be as good as I thought it was going to be, because we're here in the Museum of the Air Force, and I am extremely distracted by all these phenomenal aircraft around me. So, you know, I mean, there's an F-22 right here. There's a bird of prey. I mean, I could go on and on. I'm supposed to talk about the lift challenge. I thought this was going to be in a tent, so I wouldn't be distracted by all these aircraft. But before this event is over here in this building, and this is a magical place, go back there and check out some of these things. You've got a Wright Flyer, a B Wright Flyer right there. You've got the only fixed-wing aircraft that someone won a Medal of Honor in, sitting right back there. So spend a little bit of time, walk around. It is awesome. I myself spent a bunch of time working on those drones right there, and you know, that's a whole nother story. But anyway, let me tell you a different story. This is a story of Donna walking into my office in September of last year, and saying, I've got this great idea. Every DARPA program starts with a great idea, with a person who says, I have a blinding flash of insight. I know something that is absolutely true that no one else knows, and I'm willing to bet on it. Give me a chance. And he explained to me the lift ratio concept. We went through all the technical data that supported it, and I'll just say, he has been proven right in his intuitions, in his insights, in his engineering. Because, man, that four is really hard to get to, and everybody found that out today. And it's equally hard to get to independent of your propulsion system, independent of your design. It is just sitting right there at a very hard place. So I just want to have everybody put their hands together for Donna, because he did a phenomenal job. Thank you. So DARPA did, I would say, the easy part, right? We set up some rules. We gave you the physical space to experiment along with Wright-Patterson Air Force Base. They were the main contributor there. And we also went to the FAA and we got the regulatory space you needed to actually be able to fly these things the way they were meant to be flown. Once that came together, we had to focus on the logistics and on supporting all of you. And that's where the team here came together and demonstrated unbelievable grit. And I mean, that is really, that's the only word I have for this. Dr. Tyler McQuaid, the deputy director, and I got to come here on Friday. Unfortunately, we had other things going the rest of the week. We'd have loved to be here the whole time. And what we saw through rainstorms, through heat, through humidity, teams working so hard, gutting through all the challenges and problems that the real world threw at them, it was unbelievable. It was just so impressive. And so that's really kind of one of the big insights that I'm taking away from this event. The other thing that I'm taking away from this event, and this is really maybe the most inspirational thing for me personally, is watching those 5 attempts at going after and beating that ratio of 4. Every single one of those teams tried for it. None of them scored. Yesterday, 3 went down in flames. 2 rebuilt overnight. Both tried again today. And it was unbelievable to see that. And I'll just say, in a world where people go slow, where people are conservative, where people do not want to take risks, where people don't want to put themselves, their name on the line, we saw that happen over and over and over again with every team here. We saw people that had already gotten a good score push their machines to the limit. It was unbelievable. It was inspiring for me personally, and it is just awesome to see that this community of people came together to do that. It is unbelievable. And it's not just the community here that came together. It was the greater community that supported us, right? You have Wright-Patterson Air Force Base. You've got the community of Dayton. You've got all the volunteers and the DARPA staff members, the security forces. Everybody came together to make this event happen safely, smoothly, and to empower all the teams here. So, what's next? We've accomplished an immense amount here. Teams moved from nothing through advanced concepts and prototypes to actually get things out there flying that nobody thought were even possible. We've seen kind of the short-term innovations of structural design. There's new materials, there's new power engineering, there's all sorts of new control systems. That's all happened. That's going to feed into the rest of the ecosystem for the aerospace and technology industries, and it's going to transform them, right? We're just seeing the tip of the iceberg today. We're just seeing the very beginning of the transformation that this community is going to bring to the aerospace industry. And DARPA is so excited about that. And so we've partnered with a couple people. We've partnered with Small Business Innovation and Research Grant awards to actually connect new teams to resources to build successful companies. We've got our commercial strategies team here as well to connect you with investors. And I think that we're going to see very successful, immensely transformational capabilities and companies coming out of the efforts that you've put into this today. Again, in the short term, you already beat the pants off of most of the things that are on the market out there today. Done. But in the longer term, some of the innovations that allowed you to do that are going to proliferate throughout the entire community. And that's really exciting. So, just to end, I just want to thank you all, really sincerely, thank you all for coming out here, for showing up, for being part of DARPA. Every single team here, you are DARPA. You're what makes DARPA magical, and I want to thank you for doing your part to change the world. Thank you very much. Give yourself a round of applause. Now, before I throw it back to Donna and we get to the actual good part, which is like not people talking, but big checks, I want to invite Dr. Tyler McQuaid, a Deputy Director of DARPA, up here as well. Thanks. Let's give him a round of applause.
All right. Before we get into the awards, a lot of people are asking what's next. We have a number of things, but on the 5th, so just a few days ago, posted on sam.gov through the SIBR was a follow-on, and Mr. Winchell has committed $15 million, 10 awards, $1.5 million each, through the Small Business Innovation Research Office. So go on to sam.gov, look at that. Not now. You're not going to do it now. There's a bit more to this requirement. You know, there's an application process, paperwork, all that sort of stuff. But it is out there. It is written for the follow-on for this competition. We actually wrote it a month and a half ago and then just released it, anticipating and knowing from the papers and the videos that you guys saw that we were going to do something amazing here. All right. Thank you, sir. Thank you, both of you. Now let's review the awards we'll be presenting this evening. Tonight we'll recognize achievements in 4 categories. Over the past week, a panel of DARPA judges, program managers like me with deep aviation experience evaluated teams' designs based on a combination of technical merits, innovation, and potential impact. We're taking a page from your favorite award ceremonies and we'll show the contenders in alphabetical order before revealing the winner of each category. First up, most revolutionary aerodynamic design. These teams showed true novelty in their design as well as potential for improved performance such as lift, drag, stability, and feasibility of operations. Avalon Aero from San Juan Capistrano, California, implemented a coax rotor system with minimum mechanical complexity, allowing for an extremely light system. Driftless Robotics from Wisconsin made clever use of Kevlar string to reduce lag, provide structural rigidity, and reduce rotor flapping on a propeller-driven rotor system optimized for aerodynamic efficiency. Stanford Online High Schools from Redwood City, California, took an innovative approach to incorporate a wing in a multi-rotor design. Its slotted design uses airfoils at different angles of attack to create lift at various forward speeds and orientations. The University of Maryland Autonomous Micro Air Vehicle DLC team, UMD for short, from College Park, Maryland, blended a tri-rotor into the propulsive design of a propeller-driven rotor. by using servos to change blade and motor angles. Their craft takes off and lands like a multi-rotor aircraft and then transitions to a prop-driven rotor once airborne. And the winner is the University of Maryland Autonomous Micro Air Vehicle Team. We'll bring up the, do we have the check? All right. So if you guys saw them, let me give you a little background here. We had a number of prop-driven rotors here. If you guys saw them, they flew the first time and they were dead. Like, it was on strings. That thing was flat. It took off. It transitioned perfectly. It flew out for its unloaded lap. It came back. It made a dead stop in the air. That thing looked like a rotorcraft. It was amazing. And then as they were coming down, it just all of a sudden flipped over and burned up. And that was that tricopter you saw in the video that burst into flames. I went and talked to them afterwards, and they said, "We hit the wrong button." So this award goes because there were a number of prop-driven rotors, and this one went to the one who had figured it out the best. They also had that ability to transition into tricopter, and actually they were going to make their unloaded lap in tricopter mode and then do the weighted in helicopter mode, which we thought was really innovative to be able to solve those wind problems that all the other prop-driven rotors had. Next up, oh, they're not here today, so we're not giving them. After they crashed on the first day, they said, "We're going home." Next up, most revolutionary powertrain design. These teams demonstrated novel propulsion systems that have the potential for improved efficiency, reliability, and scalability. MacGyver from Baltimore, Maryland, used a custom battery created by his team for this vehicle, providing the power to perform exceptionally well for a multi-rotor design. He's not sharing that design, but you can get online and find it. Find his company. Portal Aircraft Company from Mansfield, Texas, created a novel, scalable concept using hot or cold turbine exhaust to drive the rotors that replace drive shafts and mechanical linkages. Their approach could provide higher reliability due to fewer mechanical components. VertSolve from Phoenix, Arizona, combined a gas engine with a generator used to power its electric motors, which at this size and weight category is amazing and has not been done. Extreme Aerial, well, hasn't been done very well. Extreme Aerial Concepts from San Jose, California, used a custom designed 8-pound, 23 horsepower turbine engine to produce a tremendous amount of thrust at a relatively light weight, powering a traditional helicopter frame to exceptional performance. And for a while, that engine was on 2 of the top places for the competition. And the winner goes to Portal Aircraft Company. Please come join us up on stage. The trophy? Grab the trophy. Oh, no, it's just the check. Just so you know, if you go to a bank, they will not take that. And for our last subjective award category, overall most promising, this one was really tough. These designs showed strong overall potential to meet the needs of future customers, considering factors such as cost, performance, scalability, usability, and transition potential. We had a number of military drone operators, and their opinions came into this decision making. And the runner-ups. Avidrone Inc. from Columbia, Maryland pushed the limits of electric helicopter design to an incredible efficiency level, setting an early competition benchmark with a 3.81-to-1 ratio. Burrell Aerospace solved the difficult takeoff and landing problem common to prop-driven rotors by blending a quad rotor for vertical takeoff and landing into the propulsive design. Defentex from Moab, Utah attempted the highest ratio in the competition, lifting almost 10-to-1 off the ground. Their aircraft uses string-based support to individual motors to reduce hub structure and overall vehicle weight. It's simple, easy to deploy, and minimizes disk loading on each propeller. In addition, it was one of the quietest aircraft on the line. D-Material from Bedford Park, Illinois, has a strong inflatable structure that is easy to pack, transport, and assemble, and is also simple to scale and has numerous applications for the maritime environment. And the winner goes to Defentex. All right, let's give one more round of applause to our subjective category winners. Now we've arrived at the moment that defines this competition, the overall payload to weight ratio awards. This is the Lift Challenge's primary metric. Every team's best official flight was evaluated using a simple demanding calculation, payload weight divided by the aircraft weight. To be eligible, teams had to successfully complete the course while carrying at least 110 pounds of payload. Aircraft and payload were independently verified by DARPA immediately before flight using certified scales. As a reminder, the benchmark everyone was chasing was a 4-to-1 payload to weight ratio. We chose the target because we believed it might be possible, and we actually proved that this week. Even though we didn't hit it in an official score, we saw the path. At this competition, everyone here, numerous teams, proved what people told me was a stupid idea and a stupid challenge, and you guys did it. With very little time on the clock, with very little time left on the clock today, we would have actually seen this previously impossible feat accomplished if we had just 30 more minutes on that clock. While no team hit it, they sure came close. And for that, they deserve recognition for getting us one step closer to that vision. Now it's my pleasure to recognize the top 3 teams. When I say your team name, please come to the stage. Our third place achieved a ratio of 3.45 to 1, earning a $500K prize for an outstanding demonstration of engineering, excellence, and flight performance. Congratulations to Extreme Aerial Concepts. Please join me in welcoming them to the stage. Our second place finishers pushed the limits of what's possible, delivering an exceptional payload to weight performance of 3.64 to 1 and earning a $750,000 prize. Congratulations to MTech Operations. Please come on stage to accept your award. And what a roller coaster they went through. And now for the highest honor of the DARPA Lift Challenge. This team demonstrated outstanding performance, exceptional engineering, and remarkable execution throughout the competition. They posted the highest overall payload to weight ratio, a record-setting 3.84 to 1, establishing a new standard for efficiency, innovation, and execution. Along with MTech, they finally both destroyed their last aircraft, attempting that 4-to-1 ratio, which was amazing. Please join us in a round of applause for $1.25 million for Avidrone. Please come on stage to receive your award. All right, thank you guys. All right, let's thank you again. One really fun thing. Thank you guys. Go ahead and I know you want to stay. Just soak it in. Soak it in. A really interesting event that the museum has allowed us to do is actually put the winners' aircraft here on display for the challenge. So up to them on how long they want it to stay. And I was just talking to the team, and I think it's really appropriate that in a museum with beautiful aircraft, they didn't see what it took to get to that. They didn't see all the crashes. They didn't see all the work, the flight test. We're actually going to keep their final broken aircraft on display. We're going to preserve it in its broken condition as an example of what it takes to achieve new heights, what it takes to make one of these beautiful aircrafts, the steps that it takes to achieve those things. Once again, give a round of applause to Avidrone. Before we wrap up, and believe me, I am almost done. I can talk a lot. I'd love to leave you with one final thought. The true value of this challenge isn't measured in dollars. The director wouldn't have allowed me to do that. It's measured in the ideas that became progress, the prototypes that became aircraft, and the boundaries that you pushed through every time you took the flight line. This competition was the catalyst, but the innovation it sparked is now yours to unleash. And what comes next is not actually up to DARPA. It's up to you. This week, you raised the bar for the entire community, and that bar is the next limit to push. I can't wait to see where you take these technologies next. Congratulations to all of our winners and competitors, and safe travel home. Thank you very much.